Здравствуйте, коллеги, друзья. Я очень рад
Hello, colleagues and friends.
участвовать, видеть вас, наверное, виртуально видеть вас.
I'm really
Обнимаю своим
happy
взглядом.
to see you virtually. I would like to hug you
1600 человек
with my eyes,
на нашей
all
ежегодной
these
конференции
1,500 or
PGConf, но в
1,400
онлайн-режиме.
people
Я хочу
in
начать
our
конференцию
PGConf
с
annual
некоторых
conference in
воспоминаний.
online mode.
На этой
And I would like to
графике
begin
вы
with
видите
some memories. In
всех
this photo,
участников
you can see all
нашего
participants
совещания в Торонто. Это первая
of our
международная
meeting in
конференция,
Toronto.
которая
This is the
была
first
организована
international
PostgreSQL
conference that
сообществом
was
в
organized
июле
by
2006
Postgres
года, через 10
community
лет после старта проекта
in
официального. То
July
есть вся конференция была посвящена
2006,
десятилетию.
10
Видите,
years after
сколько нас
the
здесь?
start of
50-60
this
человек.
project.
Но еще можно
You can see that
увидеть, что
here
здесь
there are
мы
about
на
50 or
15 лет
60 of
моложе.
us.
Вот
And
здесь,
you can
видите,
also
это
see that
Федор
here we're
Сигаев.
15
Здесь
years
вот я
younger. This is
спрятался.
Fedor
Вот
Sigayev, this is
ассамблея.
me,
Какие мы все
this is
тут
Tom
молодые.
Blaine. So we are actually very young
10
here.
лет работали и не видели друг друга. То есть
For
общались
10
только с
years,
Христом. И, конечно, в
we've
первый
been
раз, когда
working
мы
and we haven't
встретились
seen
друг с
each
другом,
other.
нам было очень
And of
приятно
course, when we saw each other
встретиться. Я
the first time, it was really
познакомился лично
pleasant
с
for
Томом
us.
Блейном. Вот здесь Федор
I
Сигаев со знаменитым
acquainted with
указателем
Tom
Postgres.
Blaine.
Посмотрите, вверх-вниз.
Here you can see
Мы,
Fedor
конечно, очень
Sigayev.
волновались с Федором, потому
And
что
of
нам
course,
дали
Fedor
целых
and
2
I
часовых доклада.
were really worried because we had
Опыта
to
выступления на международных конференциях
speak
таких
for
подгрузовых у нас не было.
2
Но
hours, and
мы
we
справились с
hadn't
этой
had any
ситуацией,
experience
потому что
of
на
speaking at
самом деле доклады,
international
конечно,
conferences,
были
but we have
действительно
managed to
серьезные,
cope
и
with
вы
this
можете
situation.
посмотреть на
Indeed, these
2
presentations were
слайда из
serious.
наших докладов.
Here you can see
Первый
2
доклад,
slides,
он
more 2
посвящался джину.
presentations. The first
Тот самый
presentation
джин,
was
которым
devoted to
пользуются
Gene.
сейчас миллионы пользователей Postgres. В
Now,
том году
millions
мы
of
его
Postgres
изобрели,
users are using it.
реализовали,
And
были
that
настолько
year,
поражены
we actually
мощью
invented
этого,
it. We had it
того, что мы
implemented, and
сделали,
we
что мы назвали его
were really
русским словом джин.
overwhelmed
Ну,
with this
мы-то все
feeling.
знаем, что джин это волшебник из
It was really
лампы, который
powerful. So we
действительно
decided
всемогущ
we
и
call
может
it
много
with
что
Russian
делать.
word genie.
Но
We know
западные
what genie
пользователи,
is,
они
like
джин
genie.
воспринимают как
And
Юпитер, или как
you know, for the Russians, genie is
по-научному
genie. It
обобщенный
is a
обратный
magician.
индекс.
But for
Но вот знаете, что джин
other
это
users from other
джин из
countries,
лампочки.
they perceive genie is a
Второй доклад был
drink.
посвящен полнотекстовому
But for us,
поиску.
it's the
Это тот
genie.
самый полнотекстовый поиск,
And
который в Postgres
the
встроен
second
и
presentation was
которым люди
devoted
пользуются.
to
Так
search
что
option,
эти 2 серьезных доклада,
which is
конечно,
built in
они дали нам
Postgres.
уверенность в том,
These
что мы
presentations were quite
выступаем на
serious,
такой
and they
конференции не
made
просто
us
так, а вот
confident that
представляем
it's not for
серьезные
teenagers that
работы.
speak on this conference, that we
Ну а
represent really
сейчас мы
serious
уже
work.
все
But
встречаемся
now
на онлайн-конференции.
we are
И
meeting
вам тут
in
мне сказали,
online
что пользователей
conference.
зарегистрированных порядка
And
1600.
I was
Но я
told
уверен,
that
что их будет еще
here there
больше.
are about
Потом смотреть
1,600 users
выступления.
registered. I'm
Так что
sure
мы
that
видим,
even
как
more users will watch
Postgres
these
вырос за эти
presentations.
15 лет.
So we can see
Из
that Postgres has
50-60 до
grown
1600
these
только на нашей
15 years.
российской
So at first
конференции.
there were 15,
Популярность
60,
Postgres растет. Вот
or
можно даже
1,000.
судить по данным
The
сайта DB
I would like to
Analytics.
mention
Это такая
that
позиционерка для
Postgres
баз
is
данных,
more
которая
popular.
собирает информацию
This is DB
про
Engine's
популярность
website. This website
всех
collects
баз данных. Мы
information
видим здесь вот
about
относительный
databases and how
график,
popular they are. And
показывающий
here we can see this
относительный рост
curve
популярности
that
баз
shows
данных.
relative
И
growth
здесь
of
сравнивается Postgres, это
database
синенькая,
popularity.
голубенькая,
Postgres is
MySQL,
blue,
Oracle, MSSQL. 4 популярных
MySQL,
реализованных базы
Oracle,
данных. Мы
and
видим, что
MS
единственное из всех Postgres растет
are compared here.
неумолимо
And we can
вверх.
see that
Мне
unlike other
приятно думать
databases,
о том,
Postgres
что он
is
начал расти с
growing.
того самого
So
времени,
it's really
когда
pleasant to
мы с
understand that
Федором
it's
изобрели
starting growing
JSONB в
time
2014
when
году.
Fedor I
Но, возможно, это
invented
поменяется
JSON
еще, конечно, и другими
15.
более объективными
Probably
причинами.
there are some other
Также
more
мы видим, что за
reasons of
последние
its
4
growth.
года Postgres
We
3
can also see
раза
that over the
был
last 4 years,
признан базой данных
for
года.
3
И вот в
times,
этом году
Postgres
Postgres опять же.
has been
В 2019
recognized as a
году мы уступили
database year,
первенство
and on the 2019,
MySQL. Но я уверен, что в
MySQL
2021 году
became the
также
database of the year.
база
But
данных.
I'm sure that in 2021,
Если
Postgres will
посмотреть
become
по
database of the year as well.
News, который публикует
And look at
вакансии
Hacker News
айтишников,
website.
опять же,
It
сравнивая те же
publishes
самые базы данных,
IT
мы видим, что
vacancies.
Postgres, опять же, начиная где-то
We
с
can
2014
compare these
года,
databases,
вакансии
and we will see
растут
this
вверх,
from
так
2014.
же, как
The
остальные просто
vacancies in
падают.
Postgres go up,
Действительно, Postgres
but the
база
vacancies in
данных,
other
которая
databases go down. So indeed,
набирает и
Postgres is the
по
database
популярности показывает
that
непрерывный
is
рост.
becoming more popular and that is
Всеми любимый
continuously
сайт Stack
growing.
Overflow
Stack Overflow website that is free and developed by all IT specialists in and we can see that Postgres is one of the place that MySQL database that is mostly used, and place after Vegas as a database that is mostly loved. And our competitors are much below us. This year, Dice company published review of IT salaries in America. So I made a query from database. I'd like to thank Alexander Smolin for the opportunity provided to me to do it. And here we can see that Postgres is on the second place without Postgres, and it shows growth. The first place we see NoSQL, and it's clear because quite recently since type NoSQL. In the third column, we can see that is going down. Is about 10% lower. Of course, salaries are not growing as fast as admin and transcript are below Postgres as well. So speaking about salaries, we can see that Postgres is quite confident, and we can be optimistic about it. So all of us here that Russia is actively using Postgres. There's nothing to watch federal systems like Rosneft, Sberbank, and they are starting to use Postgres to reject all systems. Postgres, we have systems with hundreds of transactions, and is the largest user of Postgres.
Именно федерального уровня, они
переходят на Postgres. Federal level systems have transferred to Postgres. And I think that everything will be transferred to Postgres because Postgres is reliable, dependent, and there is no sense in using Oracle or SQL Server and the system. So such large companies as Yandex or Vita use Postgres. The Russian community, well, your channels will grow. Here, I found the channel. This is a channel. Use it now. There are 5,810 users.
Я думаю, что статистика телеграм-канала еще требует пристального внимания, чтобы посмотреть на разные тенденции. Но вот пока что вот эти цифры, они уже тоже внушают, конечно, уважение. Потому что действительно серьезный канал. Я очень хочу, пользуясь случаем, благодарить админа канала, который помогает мне содержать его в порядке. И очень активных пользователей, которые действительно просто видно изо дня в день практически работают и помогают новичкам овладевать, решают серьезные задачки, интересные задачки. Вообще у нас достаточно очень культурно. Приятный канал. Особых проблем нет.
And I was not happy about it. There's also Facebook group last year about participants. Now there are 3,100
мире по Postgres происходит в России. Ну, как одна из них PGConf.Ru, другая PGD.ru. У нас идет целая серия региональных конференций по Postgres. Происходят митапы. Вот, и мы представлены на всех больших международных конференциях с докладами, участниками. Россия, можно сказать, что Россия является
So I can say that Russia is a full-fledged member of international community.
Вышло 2 университетских курса по Postgres, то есть это наша
компания. Actually, 2 university Postgres courses published. So, published course on database technology,
идет курса и один курс по оптимизации запросов. Вот по ссылке внизу вы можете найти все эти курсы. Они абсолютно бесплатно, бесплатные, свободные. Вы можете пройти их самостоятельно, послушать видео, посмотреть, полистать слайды, а потом получить, попытаться пройти сертификацию, которая тоже в нашей компании организована. И уже достаточно много людей нашли все силы сдать и получить диплом. Кстати, совсем новость, то есть в конференции вышла наша знаменитая книжка-малышка, которая разошлась уже несколькими тысячами экземпляров. В этот раз мы называем ее Black Edition, и она посвящена новому релизу Postgres 13-му. Она тоже доступна на сайте. Мы ее напечатали, будем раздавать уже на конференции офлайновской, которая, мы надеемся, пройдет у нас в мае, если все будет хорошо. Postgres является наиболее используемой базой данных в России. По источникам свободным, которые мы нашли вакансии, мы можем судить о том, что мы уже в прошлом году перевалили, обогнали вакансии по Oracle, ну и в этом году уже не уточняли, но, скорее всего, этот рост, конечно, продолжился. Я задался вопросом, а как же пандемия, как наш тяжелый год сказался на Postgres? Если взять Google Trends, то мы видим, что, конечно, к сожалению, количество запросов по PostgreSQL, здесь два слова, Postgres и PostgreSQL, конечно, уменьшилось. Вот точка вот здесь вышел Postgres 13, то есть это 24 сентября. То есть примерно осенью вторая волна, она повлияла на уже на популярность поиска по Postgres. Интересный эффект, то, что в России люди ищут слово PostgreSQL, скажем, Канада, Америка, ищут слово Postgres. Это такой интересный факт, который показывает, что все мы люди разные, но ищем одно и то же на самом деле. Просто Google не знает. Также сказалось в России. В России вы видите уникальные посетители сайта PostgreSQL.ru.
Here you see the unique users website. Our website is the
потому что у нас опубликована русскоязычная документация,
we have Russian documents.
Разве что летнего у нас не наблюдается. То есть
there are no real gaps you can see here. So
что нас больше всего порадовало,
the pandemic in Russia is not that large, and what we were especially happy about.
Большое. То есть, оказывается, это порядка
the number of
50 человек.
visitors is quite large, around 50,000.
В России это не просто Postgres, это уже, значит, большая сила.
So Postgres in Russia is not just Postgres,
Я
it's
хочу
a big
с радостью
power.
и гордостью представить наших
And
золотых
I'm
спонсоров.
happy and proud to present our golden sponsors.
Все прекрасно знают, чем занимается эта компания, но нам она интересна тем, что она в частности разрабатывает это новое поколение памяти, которое очень интересно постгресистам. Например, мы тестировали эти чипы для
Postgres users.
валы,
We tested these
и хранение валов на этих памяти является одним из очень интересных направлений, и в зависимости от нагрузки мы видим, что десятки процентов действительно мы экономим. Или не экономим, наоборот, производительность вырастает на десятки процентов. Вторая компания — это молодой такой мировой лидер в сегменте частных облаков, и он является пионером гиперконвергентных решений. И мне приятно сказать, что мы являемся стратегическим партнером компании Nutanix. Уже несколько месяцев работаем с этой компанией, помогаем его клиентам, чтобы Postgres был быстрый, надежный и так далее. Мы оттестировали нашу базу данных Postgres Pro тщательно на database. И надеемся дальше продолжать наше сотрудничество.
and we hope to continue our cooperation with you.
сказать всем
And so,
спасибо за внимание. Все, что
thank
вам нужен только Postgres. И хочу пожелать успешной работы все эти 3 дня. И передаю слово Ване.
during these 3 days, now I would like to give the floor to Ivan.
Ваня, тебе слово.
Ivan, the floor is yours.
Ваня, тебя не слышно.
I can't hear you.
Да. Ну вот пока Ваня решает свои проблемы со звуком,
Ivan has to settle some technical problems.
я займу немного вашего внимания. Вот с этим таким слайдом.
I would like to show you this slide.
Покажу вам. Так, все готово. Все хорошо.
Здравствуйте, друзья. Я хочу всех поприветствовать, но я буду краток.
I would like to welcome everyone. I will be brief.
Я хотел бы сказать, да, сейчас я тоже пошарю картинку, но они будут не столь содержательные, как у Олега.
My pictures probably they will be interesting as
расскажу,
next.
что будет на этой конференции, чем она отличается от обычной конференции. Честно говоря, очень хотели провести обычную человеческую конференцию.
Actually, we really wanted to conduct an offline conference.
Но
We've been
в
missing.
сложившейся обстановке мы, конечно, и для российских участников вряд ли смогли бы это провести как следует, а уж иностранных точно не смогли бы пригласить. Поэтому мы решили на то, чтобы сделать онлайн-конференцию в надежде на то, что обычную конференцию проведем позже. Если повезет, то это будет в конце весны, начале лета, но это будет зависеть от эпидемической обстановки. Я надеюсь, мы скоро об этом сможем объявить. Значит, наша конференция очень похожа по своей структуре на нашей прошлой конференции PGConf.Russia. Вот, но отличие. Сейчас я не расскажу вкратце. Прежде всего, мы работаем с помощью команды Онтика. Это наш технический партнер, это организаторы широко известной конференции High-Low. Они предоставляют свою платформу для нашего онлайн-общения, на которой мы сейчас находимся. Вот, ее всем нам предстоит освоить, посмотреть, какие там есть возможности. Эти возможности такие. Во-первых, прежде всего, слушать доклады, это вы уже, по-видимому, делаете. Значит, можно задавать вопросы в чатах. На каждом докладе, в каждом зале есть ведущие, которые потом эти вопросы будут с помощью, будут передавать докладчику, возможно, помогать ему отвечать. Вот, ну, в результате закладчик ответит, а если времени не хватит, то вы можете перейти в пространственный чат, типа чат. Это партнерская система такая, очень интересная, в которой можно двигаться по комнате и слышать тех, кто рядом с вами. Не забывайте голосовать за доклады.
Remember to vote for the presentations.
Значит, вы сможете голосовать за доклады. И обратите внимание, на этой конференции, как на обычной
You will be able to vote for the presentations, and also we'll have short presentations, 5-minute presentations, and there will be up to 10 of them. So please apply for those short and brief presentations. Also, we'll have user meetup. We'll have 2 slots for user meetup. In those meetups, you can apply at the platform for those meetups, and also you'll be able to vote for these brief presentations. And the way you vote will depend on which type of reports or presentations, brief presentations you are going to hear. So the time of the end of the conference is not clear because we don't know how long those final short presentations will take. But please pay attention to the rules. So these are the general rules of Postgres environment. And you can see the user guide on the chat, on the slide. I'm now handing over to Yulia Popovkina, and she represents Ontika company, and she will speak in greater details about the capabilities of the platform. On this slide, you can also see a list of our partners, and we appreciate their participation a lot. Probably as we go, we'll have one more partner, we'll have more sponsor. Things happen. And now I'm handing over to Yulia. Hello, everyone. Welcome at PGConf.Online conference. So once again, welcome you at PGConf.Online 2021 conference. My name is Yulia, and I will explain how our platform operates. I'll speak about the menu first. So the first tab demonstrates what is going on now and what is coming in the next hour. So you can press this button to switch to the appropriate page, and you can actually read the brief description of the presentation. Here, on the right-hand side, there is a 5-minute reminder, meaning that you can receive reminders or notifications if you click with asterisk the presentations you are interested in. This is the player. On top, above the player, this portion represents what is broadcasting now. On the right-hand side, there is a chat for your questions. It would be better if you use hashtag questions so that our moderators and editors immediately see the questions and will read your questions after the presentation. So all questions will be taken from the chat. Each hall has its own chat. After the presentation, if there are any other questions remaining, if you want to interact with the speaker, please come to this special chat. We have 3 rooms, so 1 room per each hall, and you can actually speak with the presenters. And it is interesting the way those chats work. You can change the volume of your sound, and you can see where your circle of volume is. Under the play, you can see welcome speech. This is not welcome speech, this is just explanation of the platform, but in the future, here you will see a description of a report and the type of poll that we're going to use. So Ivan mentioned the polls that you can use to evaluate the presentation, and then the best presentation will be selected out of all that will be presented during this presentation, during this conference. Also, at the bottom of the screen on the right-hand side, you will see notifications. You can actually hide them. Notifications telling you about the upcoming presentation or giving you some important notices on the blue background. Those will be messages from the steering committee of the conference. Now about partners. This is the partners page, and you can actually contact some of the partners. This is the schedule, the agenda, room by room, Earth, Sky, Fire. You can see Moscow time. So this report was selected by me, and here I receive a notification, a reminder 5 minutes prior to the presentation time. If you click on the name of the presentation, you'll get to its description. Here we have the library, which contains links to the previous conferences of the past years, meetup of the presentation. We have 2 slots for meetups, one for meetup and for enlightening talk. So please fill out the form, suggest a topic of your presentation, and then vote. Actually, you can vote whether you find this potential presentation interesting or not. 1 hour or 2 prior to the time of those brief presentations, the poll will close down and the steering committee will decide which of the top 10 reports will be selected for the final portion of the presentation. For example, you can see nothing here, but later you will see the appropriate meetup here below. If you press star, you will receive a reminder 5 minutes before the presentation. So meetups will take place in this special chat, and the short presentations will be broadcast in room 1. And finally, this is the chat tab that contains all the 3 chats, one per room, and this is the organizers chat, the partners chat, and the final chat is the conference chat where you can interact and ask your questions. That's all on the menu. Anyway, if you have any questions, please ask them. You can write to Telegram or to email, or at the bottom of the page you can find our contacts. That's all I have for now. I hope you are going to have a productive and interesting conference. Handing over to Ivan. Thank you. Welcome once again. Hello everyone who just joined. I will be the moderator of this room for the time being. So the first presentation is by Oleg Bortunov. I hope Oleg is ready to take over. He took some rest after the welcome speech and now he's ready to join us. Oleg Bortunov, together with Oleg Glukhov, one of the developers, and the report is dedicated to JSON B. JSON B is not just JSON, it is JSON brisk, I guess. B stands for brisk or quick. So he will speak about what Oleg and Nikita has done. So JSON B has become even faster. So Oleg, the floor is yours.
Всем привет, это Федор Сигаев.
Hello everyone, I'm Fyodor Sigaev. I'm the moderator, at least for the first presentation. The first presentation is given by Nastya Lubennikova. She is manager and contributor to Postgres partitioning, and my congratulations. She has made a great contribution. She has contributed a lot of her efforts to Postgres partitioning, and she will speak about this. Don't forget about giving her likes. And also don't forget about asking questions. Hello, everyone. My name is Anastasia Lubenikova. I will speak about Postgres partitioning. I work in Postgres Pro and develop things for open source version and for commercial products of the company. In this report, I will provide an overview of development of embedded partitioning in Postgres. I will speak about work in progress, about what has been done and what is yet to be done. So, what is this presentation for? Who is this presentation for? I recently started working in this area and I had to understand everything about partitioning in Postgres. I found out that there were a lot of materials on how to use partitioning, how to select strategy, hash or range, but information on the details or limitations on its implementation you can do only if you deep dive into the documentation and all the comments to it. So I decided to focus on this in my report. Moreover, I will compare embedded partitioning to PG Pathman and PG Partman to understand what is missing. And then I will provide the overview of features on which the community is working on, and I would like to inspire the listeners to join the review and discussion. So this is a recorded presentation. All presentation is relevant as of February the 19th, 2021. So what is declared partitioning? It's a set of features to work with big volume of data, which includes special syntaxes to work with section tables and internal optimization of productivity. So there is no single feature as partitioning. This is a set of different features, and for convenience I split them into 3 groups. Number 1 is convenience of administration. These are the commands that are seen to the users and that are needed to use with partitions. Number 2 is productivity, internal optimization, selection of things, and finally the compatibility with other subsystems of PostgreSQL. All these 3 things are important to be able to use partitioning and to make it a productive instrument and tool. Here you can see the history of development of Postgres. The first limited version was Postgres version 10, where new syntaxes was added and most of the tasks in administering had to be done manually. In Release 11, the situation improved and a lot of new features were added for convenience of working with partition. In version 12, the developers strongly improved the productivity of queries, and starting from this version, partitioning in Postgres became really useful for most scenarios. And finally, in Release 3, the latest one, we added further improvement in productivity and compatibility with important features such as logic replication. If you want to learn more about the background of Postgres development, please follow the link below. And now let me remind you about some definitions that we use as we speak about partitioning, although most of you are familiar with them. So we have tables split into sections or partitions. Such tables are sometimes called parent tables. From the point of database management, so these are the data and all data will be directed to appropriate sections. Partitioning can be multi-level, and in this case, we'll have the full hierarchy of tables. And the lower tier tables will contain physical data. The partition tables are defined through partitioning strategies, hash, list or range, and key to partitioning or partition key. It's a set of columns or expressions by which we divide our data. The conglomerate of data is defined by the borderlines of partitions, defined depending on a given strategy, and also you can assign a partition by default, a default partition, which contains data which does not belong to the current existing sections. Information about strategy and partition key.
Информация о границах секций хранится в записи системной таблицы PGConf.
So, information about the partition borderlines are contained in PG class. There is a flag showing whether this table is partitioned or not. As you see on the slide, the borders are kept as internal structure and aimed at internal use. It is not easy to decipher them in this form. Well, to receive more readable data on borders, you can read the definitions of tables by means of /d+ command. Starting from version 12, Postgres has a set of functions to research the tree of partitions. PT partition 3, tree, PG partition ancestors, and PG partition root. Please find the examples on the slide.
Дальше я хочу перечислить разные детали о том, как работают.
Here are a couple of details on how sectioned partitions work. Some of those sections explain how the feature is designed. Some are constraints of the current implementation. All partitions should have the same set of tables as the parent table. This is logical because we use partitioning, and all our partitions, all our sections are part of the parent table. If we want to add some additional columns to partitions, we can use an appropriate mechanism, an inherit mechanism, which Postgres also offers. If you want to convert a regular table into partition, it's not possible. This is a constraint of the current version, but at some point of time, hopefully, those commands will be available. But you can add a table as a section by means of attach partition, or detach it and turn it into a regular table by means of detach partition command. The ranges of values should not overlap in the partitions. This is a condition and a rule that helps us implement various productivity levels. And finally, by default, values can be assigned per each section, per each partition. It's important to remember that they will not be applied through a parent table. So our default values will be applied only when we insert data into the partition itself. This slide shows details which are specific for various partition strategies. Hash partition does not support default partition. This is also logical because for hash partition we can always define a set of partitions. In the current version, list partition does not support the multi-column key. It's a constraint that will be lifted at some point of time.
The partitions can get min value and max value that are used to specify open intervals. And finally, branch partitioning has by default partition that can have no value. The constraints check and no are always inherited by all partitions, but in this implementation it's not possible to set global constraints that would cover all partitions. It means that unique indices and primary keys in partition tables should always include all the columns of partition key, and it's not possible to develop global exclusion constraint that would cover all partitions. For various service transactions and tables, necessary to use blocks, and the optimization is important not only for performance, but for transactions that block tables for a long time, frequently not used in high-load systems. For example, there is a particular transaction. The next issue the slide are constraints of current implementations. Some corrections are on review now. So to delete or prune partition, it's necessary to use exclude block in parent table.
Но само
Position
ожидание такой
pruning
блокировки
doesn't
может
take
потребовать
long,
времени, если с
but
таблицей активно
it can
работают
require
другие
some
процессы.
time when you
Для
await for
присоединения к
such block.
секции требуется
If there are other
эксклюзивная блокировка
processes
на дефолт-секцию,
to
если
join a
таковая
partition,
имеется.
it's necessary to
Нужно
use
просканировать
exclusive
секцию
block
по
on
умолчанию,
default
чтобы
partition.
убедиться в
It's
том, что она не
necessary to
содержит строки,
scan
которые
partition
должны
by
относиться
default
к новой
to make
секции.
sure that it doesn't
Если
have
наша секция по
the
умолчанию
lines
содержит много
that
данных,
should be
то
related to
этот
new
процесс может
partition.
занять довольно много времени.
If there are a lot of data, this
Чтобы
process can
его
take a long
оптимизировать,
time.
если
To optimize
это
it,
позволяет ваша схема, можно заранее задать
if your
на
scheme allows for
дефолт-секцию
it,
ограничение
it's possible
exclusion constraint,
to
который
set
подскажет планировщику, каких строк в
exclusion
данной таблице
constraint
быть совершенно
on
точно не может.
default
Тогда
section.
сканирование не понадобится, и процесс
In
присоединения
that
новой
case,
секции
scanning
произойдет
will
гораздо
not be
быстрее.
needed, and this
Ну и
process
еще один
of
факт,
new
это
partition
то,
joining
что
will be much
сейчас
faster.
команда create
No
index
fact is that
concurrently,
today,
блокирующая построение индексов на
command
секционированных
create
индексах
index
не поддерживается.
concurrently is not supported in partitioned
Вот
tables.
список фич для администрирования, которых нам
This
пока
is
не
the list
хватает.
of features for
Некоторые из них
administration that
относительно
we lack.
простые, другие требуют
Some
очень
of them
много
are quite
работы
simple,
и какой-то
others require
архитектурной
a lot of work,
проработки отдельных
and
систем Postgres. Но на
some
слайде они перечислены
architectural
довольно случайном порядке.
processing of specific Postgres system. You can see
Во-первых,
them
было
on the
бы
slide
здорово
in
иметь
random order.
возможность создавать партиции
First of all, it would be
автоматически.
great to have an
Сейчас, если
opportunity
пользователь хочет создать
to
таблицу с
develop
лишней секцией,
partitions
то он должен 100
automatically
раз написать
if the user
соответствующую
wants
команду.
to
Ну,
develop a
конечно, так
table
никто не
with
делает,
100
и можно
partitions.
написать скрипт или
He should
функцию,
write this
которая
code 100 times. Of
автоматически их
course, no one
создает.
does
Но
it
все
this
же
way.
пока
It's
это
possible to write
обязанность
script or a
пользователя
function that
или
will
какого-то
create them
расширения, которое
automatically.
он может
But still,
выбрать.
the user should do
Следующее,
it, or
что
the user should
необходимо
select
для
the
работы с
extension.
партициями, это некий
Thing that
триггер
needs
на
to
создание новых
partitions.
секций. Это
It's a
может быть
trigger
удобно, например,
for new
для
partition
автоматизации удаления
development.
старых данных
It can be
или
convenient,
для
for example,
переименования автоматически созданных партиций. Сейчас можно
optimization of
воспользоваться
old data.
ивент-триггерами, но они пока
Now it's
недостаточно
possible
хорошо
to use event
детализированы для
triggers,
этой задачи.
but they are not well
Следующая фича – это
detailed
возможность
for
изменять
solving
лица
this
секций.
task. Another
Опять-таки,
feature
сейчас это можно
is the
сделать вручную.
opportunity
Сначала надо отсоединить секцию, а потом
to cancel
прикрепить ее обратно
the
уже
borders of
с
partition.
новыми
Now
границами.
it can be done
Но,
manually.
как я
So you
упоминала на
detach this
предыдущем
partition,
слайде,
and after
это
that,
может быть не
join
самым
it
быстрым
once
процессом.
again with new borders. But as I already said,
Другие
this
функции, о
can take
которых
quite a
часто
long time.
спрашивают, это возможность
Other functions that are
разделять
frequently
или
asked about
объединять
is the
партиции
opportunity
или секционировать
to
уже
join
существующую таблицу.
or to detach partitions or to partition
Ну и,
an
наконец,
existing
пользователь хотел
table.
иметь глобальные ограничения или
And
индексы,
finally,
которые
the
охватывают
user
сразу
has
несколько секций.
global constraint or
Это, наверное,
indices
самая
that cover
сложная
several
реализация
partitions.
фича из
This
перечисленных.
is the
Было
most
уже
difficult
несколько
thing in
подходов к
implementing the
ее
feature. There
реализации, к
have
ее
been several
разработке,
approaches
но пока
to
они не завершены
its implementation, but they
в
haven't
существующих версиях
finished
приложения.
yet.
И последний пункт на слайде – это поддержка ссылочного
And the last
секционирования,
point
о
in
которой
the
меня
slide
спрашивали как раз на
is
предыдущем
preference
докладе.
partitioning
Она
support.
может быть
I
интересна
was
тем,
asked
кто
about that before. It can be
мигрирует в
interesting to
СУБД
the ones
Oracle.
that migrate from Oracle DBMS.
Теперь давайте перейдем к оптимизациям производительности.
Let's speak about
Секционирование само по
reforms
себе
of
предназначено для
optimization.
работы с большими объемами
By
данных,
itself
и
is
некоторые
aimed
операции
at
можно
working
сделать
with
быстрее
big
просто за счет
data, and some
разделения данных
transactions
на
can be
разные таблицы.
faster
Например,
if you
можно
divide
удалять
these data
данные
into
или
different
переносить
tables.
их
For
в архив
example, it's
целыми
possible
таблицами.
to delete data
А для того,
or
чтобы
transfer them to archive
ускорить
in
работу
whole
с
tables.
секционированными таблицами в
To
целом,
speed
со
up
всеми
work
секциями или
with
несколькими,
partitions tables as a
применяются
whole, with
разные
all partitions or
оптимизации.
some partitions,
Первый из
it's
них
possible to
это
use various
position pruning.
optimizations.
Ее суть в
The
том,
first
что
one is
мы
partition
исключаем из
pruning.
плана секции, в
It
которых
means
точно
that
нет
we
данных,
exclude
удовлетворяющих
partitions
запросу.
that
Мы знаем,
contain
это исходя из
data
данных о
that
границах секции.
query. And we know this
Константы
from
и
the data
константы
on partition
выражения
borders.
обрабатываются на этапе
Constant and
планирования
constant
запроса,
expressions
а
are
runtime
processed
выражения
at the
обрабатываются
stage
до
of query
выполнения
planning,
запроса.
and
То есть мы
runtime
можем
expressions are
оптимизировать
processed at the
наши
time of
выборки не
query
только когда мы
execution. So we can
сравниваем
optimize
какое-то
our
поле в
samplings
таблице
not
с
only when we
константой, но
compare
и когда мы
some
сравниваем
field
с
in the
каким-то
table with the
выражением.
constant, but also compare it with
Разумеется,
an
эта
expression.
оптимизация не может быть применена к
And of course, this
volatile
optimization cannot
выражениям,
be used
которые меняют свое
for
значение в
volatile
процессе выполнения
expressions
запроса.
that change their value in process
Следующая
of query
оптимизация
execution.
position-wise join
Another optimization, partition by join. This is joining partitions tables by joining specific partitions. So instead of taking all data from each table, and after that join one big data set with another, we can join specific partitions. It will take much shorter time. This feature has its constraints. First of all, for the planner to understand that it's possible to use optimization, and partition should include all partition keys. Secondly, partitions should correspond to each other. So, in the current implementation, we cannot join one section with several partitions. So this optimization will not be used if one table is divided by days and another by month. For the 18th implementation, it was necessary to have similar range of partitions in both tables. For example, partition by join was not applied if one table did not have one partition, but starting from the current release, this constraint no longer exists. And the second optimization is groupings. Partition by aggregates and groupings. This is an optimization that allows us to do grouping or aggregating partition tables separately for every partition. Without this optimization, if one section is an outer table, we'll have to download the data after that, count the aggregate, and thanks to the optimization, we can count the aggregate for each partition separately. For example, the number of rows, the amount of values, and after that, we can sum up several figures. Very important, for example, sorting that can be implemented on the basis of Postgres partitions.
Теперь перейдем к следующей группе фич секционирования.
Of partition features. In this presentation, I'm speaking about the things that we lack, and we can have quite a specific understanding that partition had well developed in Postgres, of course, there's always room for improvement, but actually a lot of systems and subsystems are completely supported and they can function partitions tables. In this slide, you can see the examples of such features, and here I tried to specify the version starting from which they are supported. For example, returning command and insert on conflict command are supported by partition tables. Starting with release 11, copy command is supported starting from release 11, but with the 12th release, the performance has been additionally improved. Indices and triggers of parent table are inherited by all partitions. As you remember, we've had it from the beginning, and it's possible to join foreign tables as partitions. For key support, functions well starting from version 12, logical verification for partition tables is quite transparent, users starting from version 13. And the index command is the last one on this slide, supported starting from release 14 that hasn't been released yet. It means that when we call index command, it will automatically cover all tables, all partitions of this parent table. Could be added thinking about compatibility with various subsystems. I think that we add a lot of things. Here you can see the things that I've heard in discussions. For example, it's possible to improve on the vacuum for partition tables to get a slightly more quality the freeze command partition tables at it's also possible to add various non-blocking transactions working with indices. For example, create index or drop index in partition tables. Now let's propose the extensions that implement some functions that are missing in Postgres. There are two popular extensions, PGConf and PGConf.Online. They appeared quite a long time ago before build partitioning, and they work with
разработан и поддерживается компанией Postgres Professional. Он имеет
by
полностью
Postgres
свою
Professional
реализацию секционирования,
by it,
начиная с
it
версии
has
10 он поддерживает декларативный синтаксис, который появился в Postgres,
implementation starting
и
from
он реализует
10.
стратегии
It supports
секционирования хэш и
partitioning,
range.
it implements hash and range
PGConf
management
разработано и
strategies.
поддерживается компанией Crunchy Data,
Developed
и оно
by Crunchy
более
Data
узкоспециализировано, оно
and
предназначено для
more
секционирования
specialized.
time series и serial ID
It is
данных, то есть
for
для
time
числовых
series
и
and
временных
serials
рядов.
ID
Начиная с версии 10,
partitioning.
оно
Starting
основано
from
на
version
встроенном
10,
секционировании
it
для
has been built
Postgres
on in-built partitioning of
и, по
Postgres.
сути, является удобной
And
аберцией для него.
actually, this is a
PGConf
convenient wrap for
здесь
it.
на слайде перечислен набор фич PGConf, он довольно большой
Here
и
you can see a number
впечатляющий.
of
Можно,
features.
в нем
It is
есть
quite
удобные
impressive.
функции для управления секциями, например,
Convenient
можно
functions for partition management.
присоединять
For example,
секции,
it's possible to join or to drop
разделять их
partitions,
или, наоборот, сливать вместе.
to detach them, to
Можно
merge them,
замещать
split
существующую
them.
секцию
It's possible
какой-то
to
другой таблицей,
replace
которую вы
the
подготовили
existing
отдельно.
partition
Также
table that you
поддерживается
prepare
автоматическое
separately,
создание секций
and
и
so it's possible
динамическое
to
автоматическое
automatically
создание
create
секций
partitions
при, например, вставке в
and
ранее
create dynamic
секционированную
automatic
таблицу,
creation
если такой
of
секции еще не
partitions. For
существует.
example, if you insert range
Поддерживается
into partition
блокирующее
tables,
секционирование существующих таблиц.
unblocking
Есть
partition
очень
of existing
интересная
tables is
функция
supported.
пользовательских
There is
колбеков
an
на
interesting
создание
function
секций,
of user
в которой
callbacks
в
for
этой функции
partition
можно
creation.
реализовать,
In this
например,
function, it's
переименование
possible
партиций
to
или удаление каких-то
implement
старых
renaming
данных,
of
которые нам
partitions
больше не нужны.
or old data
Также
removal
в
that
PGConf
we
есть своя
no longer
реализация
need. And so
оптимизации
PGConf has
планирования.
its own implementation of
Это
planning
то же самое
optimization.
partition pruning, partition wise join и
This is
агрегаты, про
partition
которые я
pruning,
уже
partition
говорила.
wise join,
Они
and
появились
aggregates
в
that I
PGConf
already
больше
mentioned.
и поддерживаются для
They were
более
present in PGConf
ранних
before,
версий,
and
чем
they
во
are
встроенном
supported for
секционировании.
previous versions.
PGConf, как я уже сказала, имеет более узкую
PGConf, as
специализацию,
I said,
но все еще
is more
довольно
specialized.
много
Still,
функций для
it has
удобства
quite a
работы
lot of
с
functions for
секционированными
convenient work
таблицами. Он
with
также
partitioned
позволяет
tables.
автоматически генерировать
It also allows
страницы,
us to
позволяет
automatically
разделять
generate
существующие
orders.
таблицы
It
на
allows
секции
us to
или,
put
наоборот,
the
объединять их
existing
обратно.
tables
И
into
также в нем
partitions
есть
or
background
merge
workbook,
them together,
который можно
and it
использовать
has
для
ET
обслуживания
work
секций,
that
то
can
есть
be
для,
used
например,
for partitions
автоматического
and,
создания
for example,
или
for
удаления по
creation
расписанию.
or canceling by schedule.
У разработки и использования расширений, как и, наверное, у всего, есть свои
Speaking
плюсы и
about
минусы.
extensions,
Здесь я
they
посмотрю в
have
основном с
advantages and
перспективы
disadvantages.
разработчика и
Now, I will speak about
человека, который
it from the
поддерживает эти
standpoint of a
продукты.
developer
Ну,
and of a person
во-первых,
that supports these
что
products.
приятно, когда мы работаем с расширением,
It's quite
нам
pleasant
гораздо
that we
легче
work
и
with
быстрее создать
extensions. It's
минимально
much
полезный
easier and
продукт.
faster for
Здесь
us
мы ни от
to
кого не
develop
зависим и можем, в
useful
общем, не
products. We do not
оглядываться, не
depend on
искать никаких
anyone in this
компромиссов.
respect, and
Мы
we don't
просто
have to
пишем
look
так,
for
как нам удобно.
compromise. We just
Можно
write it the way it's
выпускать более
convenient for
часто
us.
релизы, так
It's
как мы не
possible to
привязаны
issue more
к релизному
frequent
графику
releases because
основного
we
продукта Postgres.
depend on the release
И
schedule
таким
of the
образом
main
получать
product
больше
Postgres.
обратной
And
связи от
thus we can get
пользователей и быстрее
feedback
на
from our
нее
users,
реагировать, и
and
быстрее
we can
исправлять ошибки.
respond to it faster and
И,
amend our errors faster.
Postgres известен
And
своими очень строгими требованиями к качеству кода.
Postgres is known
В
by its very
расширении
strict
можно
requirements to
попробовать
good
поискать
quality,
какое-то
and in the
более
extension it's
оптимальное
possible
соотношение требований к качеству и скорости разработки.
reach of the requirements
Есть и
to
минусы.
quality.
Некоторые
development speed.
фичи просто невозможно сделать в расширении.
Well, some
Например,
features
если не
cannot be
существует
developed
такого
in the
API,
extension. For
которое
example,
позволяет это
no
сделать,
such
и
API that
потребуются
allows us
тогда
to do so.
дополнительные патчи к
In that case,
ядру,
it will be needed
которые
additional
совершенно не
patches
все
to the
пользователи
core,
могут себе
and not all
позволить
users
использовать.
can afford
Также то, что
using
вначале
them.
было плюсом, тот факт,
And
что нам не надо ни с кем
in the beginning, it was an advantage that
договариваться,
we
ни на кого
do not need
оглядываться,
to
становится
agree with
здесь минусом.
anyone, or work with anyone, but
Сложно
in this case,
поддерживать
this is a
совместимость с
disadvantage. It's
изменениями
difficult
новых
to
релизов
maintain
Postgres.
compatibility with
Иногда это
changes
просто
in
какие-то
releases of
небольшие
Postgres.
изменения,
Sometimes
которые
these are small
нужно
changes,
поддержать, а иногда
should be
это
supported.
очень
Sometimes
большие архитектурные
these
различия,
are major
совместимость с
architecture
которыми
differences.
нужно обеспечить
Compatibility with
разработчикам
which
расширений.
should be
Ну и,
provided
наконец, последний
by the
пункт, который,
developers of the
наверное,
extensions.
самый
The
важный
last
и перечислен
the
здесь
biggest
для
important point
пользователей
I want to
расширений.
mention here
Это факт,
for the
что не все
user.
облачные сервисы поддерживают использование сторонних расширений. То есть совершенно не в любом облаке вы можете использовать функциональность расширений PGPartment или
So
PGPartment.
you cannot use PGPartment or PGPartment extensions
Да.
in
Из этого
every cloud.
можно сделать вывод, что
So
лучше
it's possible to
гораздо
conclude
развивать
that it's much
ядро
better
и стараться
develop
как
the
можно
more
больше фич добавлять туда.
to try
Это
to
все
add as many
не
features
быстрый
there as
процесс, как
possible.
мы знаем. И поэтому,
Takes time as well.
опять-таки, я хочу привлечь
So
вас
once again,
к участию в
the
разработке, потому что
to
одна из вещей,
participate in
которой
the
нам
development
не
process.
хватает,
Because
это
one point
взгляд
that we really lack
пользователей и их
is
мнение
the
о
opinion
том,
of the
как
users,
лучше
their
реализовать
opinion
те или иные
about
функции.
the way various functions
Ну и в
can be
завершающей части
implemented.
доклада я сделаю обзор фич, над которыми прямо сейчас активно работает сообщество. Все
That have been
ссылки
developed by
будут
the
на Комитфест, где
all
вы
these
можете
links
присоединиться к дискуссии.
to ConferFest,
Первая
where you
фича
can
на этом слайде —
participate in discussion.
автоматическая
The
генерация
first
секций
feature
для
is
хэш или
automatic
секционирования. Ее
hash
сделала я при
partition
помощи
creation.
своих коллег.
I
И сейчас
developed it together with
она
my
ждет
colleagues.
отзывов
And now
на
we
Комитфесте.
need your feedback
Самое
on
главное, о
ConferFest.
чем нам нужно договориться, прежде чем
So the
эту
main
фичу
thing we
можно
need
будет
to remember
закоммитить, это
before
синтаксис, который
committing
должен быть
this feature is the
достаточно
syntaxes
свободным и расширяемым для того, чтобы можно было
and
добавлять
extensible
последующие улучшения.
in order to add
Следующая
subsequent
фича — это автоматическое выполнение операции
feature.
кластер для секций, у которых есть подходящий индекс.
Partition
Ее
tables.
идея похожа на идею
Its
фичи
idea
индекс,
is
которую я уже
similar to
упоминала
the
на
index
предыдущих
idea which I
слайдах.
already
То есть
mentioned
если мы
in previous
вызываем
slides.
кластер на родительской
So,
таблице,
all
то
cluster
эта
in parent table,
операция
then
также будет применена ко всем
this
секциям.
transaction will also be applied to
И
all partitions.
третье исправление на данном
And
слайде — это улучшение
the
работы автовакуум анализ с секционированными таблицами,
is
чтобы
the
статистика
improvement
собиралась
of
более качественно.
auto-vacuum analyzed on partitioned tables for a
На
more
следующем
qualitative
слайде перечислены разные
slide.
операции,
Various
разные
transactions,
патчи для того, чтобы
various
мы могли
patches
делать неблокирующие операции с
for us
с секционированными таблицами. Например,
to
возможность
conduct
отсоединять секции без блокировок,
blocking
возможность
transactions with
присоединять их
partition
уже есть,
tables, for
начиная
example,
с релиза 13, и она
detach
работает
partitions
прозрачно
without
для пользователя.
blocks.
То есть просто нам не
It's
требуется
possible to
больше
join there without
эксклюзивной
blocks, and it
блокировки
is
для этой
transparent,
операции.
and we do not need
И
exclusive block for this transaction.
также в работе сейчас патчи
And
для того,
now,
чтобы сделать
by
неблокирующие
developing patches,
построение и удаление индексов на секционированных таблицах.
blocking
Ну,
construction and
конечно,
developing
гораздо
indices
больше
in
всего сейчас
partition
находится в
tables. And of
разработке.
course,
Комьюнити у нас большое, и
for all the
я не могу, наверное,
development
так подробно
issues, we have quite
рассказать про каждый из этих
large community,
патчей.
and
Они
I cannot
перечислены на слайде. Вы
speak
можете
about each
посмотреть
of
на
these features
их
in
названия.
details.
Если
You can
вас
see the
что-то
slide,
заинтересует, может быть,
see
я
their
могу
names. If
подсказать
you
вам, в
are
чем
interested,
суть
probably
тех или
I can
иных
give you some
улучшений.
recommendations regarding
И если
the
вы чувствуете, что
meaning
какое-то
of
из них
various
вот прям
improvements.
то, что нужно, чтобы решить ваши
And if you
проблемы,
think
то не
that this
стесняйтесь
improvement
перейти в рассылку
is
и
review,
обрадовать разработчика,
please
высказать
express
ему
us.
свое большое уважение и пожелание, чтобы эта фича как можно быстрее попала в релиз.
So we'll make sure this feature has got into release as soon as possible.
Патчи, которые сейчас
This is work in progress, patches in development, and certainly to finalize the presentation, here are the links. For resources that I relied on, thank you. I'm looking forward to your questions. We have quite a lot of time for discussion. I also have a question to you. What features, which I probably did not mention during the presentation, are important for partitioning in Postgres? Thank you.
Спасибо записанной Насте за интересный доклад.
Nastya, thank you very much for your recorded presentation. So we're moving to the Q&A session. So the first most popular question, is it possible to download your slides somewhere?
Настя.
Nastya, do you hear our question?
Ну, наверное, можно.
Probably the answer is yes.
Я не думаю, что они секретные, я пока за Настю отвечу.
I don't think those slides are confidential. I'm talking for Nastya, of course, but I believe so.
Настя, тут на вопросы, заданные в чате, частично...
Nastya is answering questions in the chat, at least some of them.
У меня вопрос такой, уникальные индексы...
I have a question. Unique indices and primary keys, do they fall under the current constraints or not?
Так, у нас небольшие технические проблемы, поэтому...
I think we have some technical issues.
Начать вопросов,
I will start from the questions.
на них знаю ответ.
If I know the answer, I will say, I will answer. So I'm sure the slides, it will be possible to download the slides. I'm almost 100% sure.
Можно скачать, видео тоже будет выложено попозже, на самом деле просто достаточно большой массив.
And also the video you will also be able to download the video, although it's quite big. The file is quite big.
Отлично.
Nastya, can you hear us? Yes, I do. Here is the question.
Уникальные индексы и первичные ключи.
Unique indices and primary keys. Should they be part of the partition key? Is it a current constraint or a future constraint too? It's a current constraint, but it is not easy to remove it. So it will stay for a while, this way, at least for the several upcoming versions. To eliminate this constraint, we need to learn how to do global indices. And as long as we don't have it, please use the partition key for your purpose. Understood, thank you.
Народ беспокоит PG-Patman. Во-первых, выглядит как более
PG-Patman. It looks like a temporary solution. Is it worthwhile using embedded partitioning? PG-Patman is part of Postgres Pro products. It is also uploaded on the hub, but you can assemble it on your own as an extension for the vanilla Postgres. It looks like a more robust solution, but in my presentation I was trying to show that we're developing, and it looks logical to invest into its development and not just to support several competitive products. So for the users, so it's up to the users to choose which is more appropriate for their load. But in the future, most of those features will be implemented. At least I hope so. This is not the first case of that kind. When improvement of Postgres was independent, it was developed independently and then it was accepted and approved by Postgres. And a related question, are we going to have embedded partitioning in version 14? I guess the question is it going to be as good as PG-Patman? In release 14, we'll probably not have it, because we're in the middle of the release cycle. We will not have enough time to move all the features there. So again, I'm looking forward to your review, and by means of the feedback and some comments, we'll be able to bring at least some features there. We're working on it. They will hardly be moved in the fashion as they are now in Patman, but in Postgres it will be in the form of declarative syntaxes. We will not be able to bring them over directly. Clear, thank you. When you use the several partitions, can we use parallel approach? Several streams per one query. Is it possible? Honestly, it's hard for me to say. parallel approach is used at the level of each separate partition, I believe.
Каждую отдельную таблицу, вероятно, мы
So
можем
each table
читать параллельно.
can be read in parallel, probably.
Чтение на несколько таблиц,
But
не уверена.
to make reading parallel, I'm not sure.
Спасибо. Еще вопрос из чатика.
Another question from the chat. Do you support migration of lines as you update partitions?
Подозреваю, что это изменение ключа позиционирования при апдейте.
Is it due to the change of the partition key? Yes, someone answered that starting version 11, this feature is supported, has been supported.
Вот у меня есть вопрос лично от меня, который...
I have a personal question. I mean, it's my question.
Вот если мы подсоединяем партицию,
If we add a partition,
проверяется на то, чтобы констрейнты были такие
is it
же, как у...
verified
или они дополняют?
for constraints to be the same as in other partitions or not?
А в смысле констрейнты?
How do you mean it?
Например, not null какой-то.
For example, mode node.
Нет, по-моему, на разных таблицах можно задавать...
No, in different tables, you can you can assign different constraints to different tables.
Что нет. То есть я думаю, что к
I think
соединяемой таблице добавляются...
if you add a table, you add to it a parent constraint, but I'm not sure 100%. So at present, it is possible to create a hierarchy with constraints, some constraints which are inherited from the parent table, and it will then propagate to all other inherited partitions. Or you can define separate constraints per each section, and there will be no contradiction.
Хорошо, неожиданно, но хорошо.
Unexpected answer, but good. Thanks.
Может быть, это и будет поначалу озадачивать. Еще вопрос.
It's a bit confusing at first.
Не знаю. Подскажите, пожалуйста, есть ли возможность ускорить вставку в
Is
родительский...
it possible to expedite insertion into the parent table?
Мне довольно сложно представить, как сбор
It's hard
статистики
to
ускорит
imagine
вставку.
whether gathering of statistics can expedite insertion, but statistics in the parent table, for that there is a patch which I mentioned that improves auto vacuum.
То есть, возможно, он поможет
So it will probably,
кейсу, который
this will probably help the case
сейчас.
related to this question.
Статистика для
So
отдельных
at present,
родительской
statistics
таблицы,
for
насколько
each
я
table
понимаю,
and for the
независимо
parent table
и
is
очень
gathered
хорошо
independently,
друг с другом.
and it's not very well automated, but there is a patch, auto vacuum patch, aimed for partition tables, and it aims to cure the situation.
Вот прямо сейчас поступают вопросы, я даже перестаю успевать.
More questions are coming. Well, I have no time to read them all. Are there plans to optimize planning on partition tables?
Каждая миллисекунда на счету.
Because every millisecond matters.
Но я думаю, что это довольно сложно, как и
I think it's quite difficult
сам планировщик.
as anything related to the Postgres planner.
Ускорять планировщик.
So we will not
Патчи я не
be
видела.
accelerating the planner or the patch to accelerate the planner. Haven't seen such patches. It might be possible to add some new optimization.
Конкретно планирование у вас тормозит.
Also,
Вы считаете, что
if planner
вообще
is
без этих оптимизаций
slow,
все сделано отключено,
better
они сейчас
avoid optimization. It is possible to switch them off.
штуки. При умении
Aggregates
все можно отключать.
can be turned off.
Спасибо. А какие
Thank you.
ограничения сейчас есть у ограничений
What
функционированных таблиц?
are the constraints of partition tables during replication or backup?
Насколько я помню, начиная с
As I remember, starting from version 13, they replicated
прозрачно для пользователя и
transparently, physically and logically for the user.
ограничений, которые были бы связаны именно с
There are no
таблицей,
specific
таблицы нет.
limitations related to the fact
Честно говоря, не вижу, какие бы могли
that you're doing backup. I don't see any constraints here.
физический бэкап
If you do a backup, if it's a physical backup,
данных и в целом
these are the data files,
внутренним миром.
and we don't really care about what's inside those files. If it is pgdump, we back up the scheme and the full partition scheme and the data. I don't think there are any constraints there. And there is a personal question. I hope you won't be shy to answer it. How did you become a major contributor? How much time do you spend on this, and how do you combine it with your main job? This is my main job, which is good. So I develop Postgres, which is my job, and try to work on open source project of the community. I become a major contributor. I don't know how I became one. I just received a letter saying that had become a major contributor. I think it was a cumulative effect of all my previous efforts. Scare everyone. I guess you should frighten people. Okay. Index only scan logist. This is what I started with in my presentation. It covers indices for B3, duplication for B3, which we did together with Peter in release 13. And now we're working on partitioning. There were some small patches, but a lot of reviews as well. This is an important part that is valued. Thank you. So it's not that you forced someone to make you a major contributor. No, of course not. So I guess the community is very responsive, and if you make efforts, it will be noticed. And also, if you want to write to me, please use the email Postgres lists. It's above the list of contributors. Oh, no, if you decide that your efforts have been overlooked, please use this email to write about it. If you believe your efforts have not been appreciated enough. Questions about blocking. What blocks are needed as we add or cancel partitions, and how long should they be? Let me remember this. It was in my presentation, by the way. You need blocks for the parent table as you add or switch off sections, or in order to change the scheme in the catalog and to address the queries. And the queries will come to the parent table. So for those queries to know that we have a table added, that we have included it, or on the contrary, that we have ignored it because it is no longer related to our partition tree. What blocks are needed to add and cancel? Now, in order to add, you only need a shared blockage, very short term and exclusive. To turn it off, you still need exclusive, but we are working on a patch that would make this departitioning competitive. Nothing special. And also to add, you need blockage for the default partition if you need to scan. Clear. Thank you. 2 more questions. We have 2 minutes. And then you will be able to ask questions personally, because her presentation contains contacts. I think I'll move to the special chat, which is available for us, and I will talk to the guys there. Question. If the parent table is signed for replication, if you change data directly in the partition, will the subscriber receive those data? I think it's about a logical replication.
То есть получает ли подписчик все изменения во всех
So
секциях, если он...
the question is, does the subscriber receive changes from all the partitions if he is subscribed for only the parent partition? Well, I can't say off the top of my head. I think you should double check in the documentation. It should be described there.
Не знаю, я не изучала эту часть внимательно, поэтому
So I haven't
положить, как там сделано.
Looked into it deeper. Well, it's no surprise because replication is a separate world. It's another universe with its own miracles. And the final question for today,
Что можете сказать про timescale DB?
timescale DB. What can you say about it? Can you compare this solution? Yes, I think there was one more question about it. Timescale DB is LSM, although it is an extension of Postgres. Well, it has not been included in my overview. They have their own storage level. So this product is much different from Postgres. I believe that for some loads and some data, it's a very good extension. They are certainly optimized to store and process time series data. So I believe it's a good product, but not as multi-purpose one as PGConf or embedded partitioning, of course. Thank you very much. This is the end of our Q&A session online. So Nastya promised to come to the special chat and also answer questions in written form there. Don't forget about putting likes, giving likes. Online conferences are not easy because you don't see the audience, you don't see the reactions. That's why your reactions are important. Your likes matter. So we will prepare for the next report, which will start in 12:05 at 12:05 in 15 minutes. Nastya, thank you very much for your contribution, and goodbye.
Hi everyone, my name is Alexey Kondratov and I will be a chairman of this section for the next 1 hour. Let me introduce our next speaker, Yiga Nagata. I think that many of us are familiar with views and especially material-based views in Postgres, but maintaining the offload requires manual intervention to refresh the content. And the next talk will cover this topic and will be about incremental views maintaining. This talk is pre-recorded, but Nagata-san will join us during Q&A session to answer all your questions. So please be active in the chat and ask questions in advance. Thank you for attention. Let's enjoy the talk together, and I will get back for the Q&A session.
Hi everyone, I'm Yiga Nagata. In this session, I would like to talk about my proposal to implement the feature for updating materialized view automatically and incrementally. First, let me introduce myself. I'm Yiga Nagata, software engineer at SRA OSS Inc. Japan. I'm in charge of research and development on PostgreSQL, and now I'm working on incremental view maintenance. That's today's topic. This is the outline of this talk. First, I'll introduce incremental view maintenance, IVM. Shortly, this is a way to refresh materialized view rapidly. Next, I'll explain our implementation of IVM, its outline and details about how it works. Then, I'll show some behavior example, including performance evaluation. Finally, I'll summarize this talk. First, view is a virtual relation defined by a view definition query. The query is executed when the view is referred to by a select statement. On the other hand, materialized view is a view whose results are stored in database, so it enables quick response for client. This is useful for data warehouse for analyzing large data. However, materialized view needs to be maintained after a base table is modified to keep consistency between views and its base tables. Refreshing materialized view is one way to maintain the view. In the current PostgreSQL, the refresh materialized view command. When this command is issued, the view's contents is recomputed from scratch, so it takes a long time. By using concurrently option, a refresh materialized view is performed with a weaker lock, but it still needs recomputing. Incremental view maintenance, called IVM, is another technique to maintain the materialized view. It computes and applies only the incremental changes to the materialized views, so it is effective if small fraction of the view is updated. This figure represents IVM informally. When we have a base table D and view definition query Q, we can get the contents of materialized view, V. When a base table is updated, we can get changes on tables and updated base table. And this updated base table and view definition query, we can get updated materialized view. This green line is recomputing. That is what refresh command is doing. On the other hand, if you can get changes on view from changes on table, we can compute updated materialized view contents by applying these changes to all the view contents. This red line is incremental view maintenance, IVM. IVM is not supported in the current PostgreSQL, so we developed it and the patch is proposed to developers mailing list. The subject is implementing incremental view maintenance. Using this feature, materialized view can be updated automatically and incrementally when its base tables are updated. So you can get the latest state of the view just after table changes, even in the transaction. Of course, you don't need to write trigger functions by yourself. As a view definition query, we are supporting selection, projection, and join, including self-join and outer join. And we support distinct clause and views with tuple duplicates. Now we are supporting some aggregates with or without group by clause, count sum, average, min, max. And in addition, we are supporting exist clause, simple subquerying from, and simple CTEs. So how effective our IVM implementation is? To test this, I test performance on TPCH query. TPCH query 1 is aggregates on a large table like this. Select to this query took about 10 seconds. And by creating materialized view, the response time is 1.5 milliseconds. So it enables quick response. However, refresh of this materialized view took about 36 seconds. So it takes so long time. On the other hand, using incremental view maintenance, when one tuple of the base table is updated, it takes only 70 milliseconds. So, and the view is updated automatically. The view is updated so rapidly. This is more than 2,000 times faster than normal refresh. In another example, using TPCH query 9, this is an aggregate on 9 tables join. The refresh of the materialized view took 6 seconds. But IVM took only 30 milliseconds. It is more than 200 times faster than refresh. Okay, IVM is so effective. Okay, I'll explain the basic theory of IBM. A view definition can be described with relational algebra. For example, simple natural join view using table R and S is represented like this. And when a table R is updated, its change on table R is represented like this. This inverted triangle, inverted delta is nabla. Nabla R means tuples deleted from the table. And Greek delta R. Delta R means tuples inserted into the table. Using these table changes, we can calculate changes on view, nabla V and delta V. And by applying these changes to the view, we can get the latest state of the view. Using this example, there's two tables, R and S. And this is a natural join of them, V. When R is updated, nabla R and delta R is like this. And using these changes and table S and view definition, we can get nabla V and delta V. This is a changes on the view. Finally, applying these changes to the view, we can get the latest state of the view. This is an IBM process. About timing of view maintenance, there are two approaches: immediate maintenance and deferred maintenance. In immediate maintenance, materialized view is updated in the same transaction where a base table is modified. In deferred maintenance, the view is updated after the transaction is committed. For example, when the view is accessed via select statement, where as a response to user command like refresh materialized view command, where view can update it periodically in background and so on. However, we started from immediate maintenance approach because it requires less number of calls. Deferred maintenance, implementing deferred maintenance needs a mechanism to manage logs for recording change of base tables. It is not trivial work, so starting immediate maintenance is easier than deferred maintenance. So we decided to start from immediate maintenance. This is an overview of our implementation. There are 3 steps. First, when base table is modified, the changes on table is extracted. And using these changes and view definition, we calculate changes on view. And applying the change on view to materialize the view and update the view. In our implementation, we use after trigger and transition table to extract the change on table. And calculation of changes on view is based on relational or bug algebra. And changes on view is applied to the view using SQL query. Okay. Create incremental materialized view. This is a tentative syntax to create materialized views with IVM support. This incremental keyword is our extension to the original syntax of created materialized view. And when view is created, after triggers are automatically created on all base tables. For insert, delete, or update command as statement level triggered with transition table. This transition table is a feature of after triggers. Using this feature, changes on tables can be referred to in the trigger function like normal tables. There are two tables. One contains tuples deleted from the table, and another contains tuples inserted into the table. In theory, these two tables are corresponding to number R and date R respectively. Using these changes on table, delta table, we can calculate delta on views. For calculating delta on views, we use a view definition query with some rewrite. In this rewrite, the modified table is replaced with transition table. For example, this is view definition, and this is modified table. And in return query, this table is replaced with transition table. In addition, the multiplicity of each tuple is calculated by using count as the aggregate. And the result is like this. This IVM count column is multiplicity of each tuple. And finally, these delta on views is applied to the view. When deleting tuples from the view, tuples in the view are deleted as many as the specified multiplicity. The same tuples in the view is numbered and using row number window function. There are three same tuples, but only two tuples are deleted because the multiplicity is 2. When inserting tuples into the view, tuples are duplicated to the specified multiplicity. This is performed by generate series functions. For example, this tuple's multiplicity is 2, so this tuple is duplicated 2. Here, I'll show the result of simple performance evaluation. We use the two materialized view with the same definition query, but one is a normal materialized view and another is created with incremental option. First, the refresh of the materialized view took more than 10 seconds, so it takes a long time. But after creating an index on the materialized view and Updating a table in the base table. It took only 80 milliseconds. Of course, the models view is updated automatically and correctly. So the view is updated rapidly. On the other hand, here we created an index on the materialized view. But the index, the IBM updating a table in base table took 4 seconds. So although this is faster than normal refresh. Normal refresh took 10 seconds. It is 4 seconds, so it is faster than normal refresh. But for efficient IBM, we need appropriate index on materialized view. This is an important point. Next, I'll explain aggregate support. Now we are supporting built-in count sum min max average with or without group by clause. When using group by clause, expressions specified in group by clause must appear in the target list. In aggregate view, views have one or more hidden columns. For example, the number of tuples in each group is stored as hidden columns. In addition, for average aggregate, we stored the value of count and sum as hidden columns. When view is maintained, first, aggregates are performed on table deltas, changes on tables. And aggregated value in the view are updated using the result. The way of updating the aggregate value in the view depends on the kind of aggregate function. This is an example of updating aggregated values in the view. For count or sum aggregate, we can easily calculate the new value by applying the count or sum calculated from the data table. To get aggregate value, we need some value, new sum value, and a new count value. So these two aggregate value stored materialized view as hidden columns. For min or max aggregate, when tuples are inserted, for min, list value between the current min or min calculated from the delta is used. This is similar to max cases. And when tuples are deleted from the view, if the existing min or max in the view is deleted from the view, it needs to recompute the new value from base table. So in this case, it takes a little time than other cases. Here is a simple performance evaluation on aggregate views. There are two material views of aggregates on PGBench tables. One is normal material view, and another is a view created with incremental options. First, refresh of the material view took 30 seconds. However, updating a base table took only 30 milliseconds. And the view is automatically updated, and the content is of course correct. So the view is updated more than 1,000 faster than refresh command. Great. Next, I would like to explain outer join supports. In outer join views, there are null extended tuples. It is called dangling tuples. This appears when the join condition does not meet. So when tuple is inserted in the table, dangling tuples might be deleted from the view. And when tuples are deleted from the table, dangling tuples might be inserted into the view. So it needs some extra work. So outer join view is maintained by two steps. First, calculate and apply deltas as similar to inner join case. And then additional dangling tuple handling is performed. We implement this based on an algorithm in Russian and so, with some theoretical extension to our duplicated tuples, because original algorithms don't allow duplicated tuple in view. Here is a performance evaluation of inner and outer join view. We create two materials view. One is inner join, and another is use full outer join. Also, there are three conditions about index on the materials view. First, there are no index. Second, the view has an index on the primary key columns of base tables. And third, view has additional two index on columns used in join conditions, as well as primary key columns. This is a result. In both cases, refresh took about 8 seconds, so it takes a long time. And in all index condition, IBM is faster than refresh. But for effective maintenance, an appropriate index is required. Without index, it takes 2 or 3 seconds, but with index on primary key columns, the IBM is so effective. In addition, with additional index, the execution time on outer join maintenance is almost same as inner join views. So we can update both inner and outer join views with almost same cost. Finally, I'll explain subquery support. Now we are supporting exist clause in Fair. Well, for implement this, the row number count of exists subquery is stored as a hidden columns in each tuple in the materials view. And when a table in this subquery is modified, in this case, table 2 is modified. If the count becomes 0, the tuple in the view should be deleted. Otherwise, the tuple remains because this exist condition is true. Also, we are supporting simple subqueries in from clause and simplicity is that is with clause. Simple means subquery or CT contain only selection, projection, or inner join. Aggregate or outer join is not supported in simple subquery. As the restriction of the current implementation, we were not supporting aggregates other than built-in count, sum, average, mean, and max, and having clause and complex subqueries and CTs, including aggregate, outer join, and window functions, set operations, order by clause, limit offset clause, and not supported. As for outer join, we support only simple equijoin, and it cannot be used together with aggregates or subqueries. And as for exist clause, we support only or exist. We support only and exist, and we don't support or exist or not exist. And exist clause cannot be used together with aggregates. We test how many queries in TPC benchmarks are supported in our implementation. As a result, 9 of 22 TPC-8 queries and 20 of 99 TPC-DS queries are supported. In both cases, order by and limit offset clause are ignored. In TPC-DC cases, 33 queries failed due to complexities, and 11 queries failed due to aggregates in subquery. So, relaxing the restriction and supporting more general view is one of our future work. Performance issues. As shown in this talk, using IVM, materialized view can be updated faster than refresh command. But appropriate index are required on materialized view for efficient IVM. So, in the latest patch, appropriate index is created automatically when the view is created, if possible. So we don't have to make an index by yourself in this case. In our implementation of IVM, views are updated for every table modification. So there are impact to performance of updating table. So it's not suitable for write-heavy workload. Instead, it will be useful when update is not so frequent, but users would like to know the analysis result immediately. As other features, we support with no data option. This is an option of create materials view or refresh command. With this option, the materials view becomes not scannable, and triggers on view is dropped, so the view is not automatically updated even when a base table is modified. So this means the performance of updating table is not affected by IVM. It is useful when large data is loaded on a base table. For supporting low-level security, when a view is updated incrementally, its base tables are accessed with the view owner's privilege. And now PGDump and PGRestore is supporting this new syntax, create incremental materials view, of course. Okay. We explained our implementation of incremental view maintenance IPM on PostgreSQL. This enables rapid and automatic update of materials view, and it is faster than normal refresh command. Also, of course, you don't have to write trigger functions by yourself. The patch is discussed on mailing PGConf hackers developers mailing list, and we are targeting PostgreSQL 14. We also have GitHub repository, and there are Docker images on Docker Hub. This can be used to test our IBM. So we would greatly appreciate if you would test the IBM and you could give us any feedback. Okay, that's all. Thank you.
Hello, I think that we get back for the QA session, and welcome Nagata-san. And we have one question in the chat so far. It is, I think that it was answered during the talk already, but still. It says that what is the performance impact and what is the overhead of maintaining this incremental materialized views compared to without this incremental feature?
Okay, even though there is no data in slide, then I forget the real the performance, but exactly there is an overhead of IBM. So every time the base table is updated, view is also updated. So the overhead is large, and at least it is slower, at least a few times slower than the normal update of view.
Yeah, I think that it is expected then when you update view together with data, then it takes some overhead. But if we choose to do this deferred materialized view update So can we neglect this overhead, or it still persists?
I asking about optimization.
No, I mean that if we update this incremental view immediately with the data, then of course we have this overhead. But if we do deferred updates, then I think that the overhead will be lower.
Exactly. So reduce overhead of IBM, we need deferred maintenance approach. So I think this is a future work. So I would like to implement this for more practical implement for more practical.
So we have no questions, but I will use a chance to ask my own questions for you. And first of all, I want to say that it is interesting that there is such a solid theory, this relational theory under doing this incremental use updating, because so I think it is interesting. At the first sight, it seems like maybe a simple topic, but internally there are a lot of problems. And I think that you talked about it in your talk, but I cannot say get entirely. So how we calculate this delta? Because I think that if we have no internal like index or something like that, then to create this delta of changed rows, which we need to process to do an update, we have to do an entire sequential scan of the table to calculate this delta. But how it is implemented in your patch? So do you have some kind of index where you put the changed rows?
Well, basically, when calculated the change on views, we use view definition query just after replacing modified table with transition table. So if the base table has an index, this index is used, and the delta of views is calculated rapidly, but there is no index on base table. If there is no index on table, to calculate view delta will take a long time. Yes, so yes, for efficient IBM, we also need appropriate index on table.
So, okay, in other words, we put these modified rows required for incremental update in some transient table, and after that we pick them from there and do this update.
Well, sorry, could you rephrase?
I mean that in other words, we if something is updated on this data table, we put these rows into some transient table, at some like, and after that we pick them from this transit table and do this incremental update.
Do the same. Perform to the same query. Sorry, I didn't catch your question. Sorry.
So okay, maybe we can ask. I can ask another question from the chat because it was on my list also, and it says that is it like natural restriction? So we cannot do an incremental update for any query. So we have to manually add implementation, for example, for some aggregates. So, for example, we cannot support like user aggregates, or there is a chance that we can implement like general solution to support all possible queries for materialized views in Postgres.
Wow, this question is about view definition query restriction.
Yeah.
Yes. Yes. Well, okay. We are trying to reflect these restrictions, but I think it is a bit hard to treat complex subqueries, including aggregate or distinct. So to handle these complex queries with complex subqueries, we will need to handle nested IVM. That means materialize some expression in the views and incrementally maintaining the sub-expression in the view, we can handle more complex view definition query, I think.
Okay, thanks. So I think that the work is in progress, and there is a chance that it will be implemented maybe one day. I don't know that I think that I have no additional questions, and there are no questions in the chat. So I want to thank you again for your talk and for answers. And also I want to advertise this thread in the hackers. And I think that it is really, I think that it's one of the hot topics, and it will be interesting to implement this feature to improve speed of some analytics and so on. And reviewers and commenters and testers are very welcome to this hackers thread to try this new feature and to help testing and implementing anything there. So thank you again. And I want to say that we have some special chat. It is called special chat, and all participants and speakers can communicate there. And it is like Clubhouse, but on our platform. And you can talk with speakers using voice, and during all days of conference. I have not tried it so far, but I'm going to get there and try it. So thank you, and we have a half an hour break before next talk, and there will be a new chairman there. So I have to say goodbye to you for today. Thanks.
Thank you.
Okay, thanks, Yiga, for participating.
In the early days of Intel, Robert Noyce once said, "Don't be encumbered by history. Go off and do something wonderful." And wonderful, we did. For more than 50 years, we transformed computing, putting Intel Silicon at the heart of innovation. But with all the breakthroughs we made, all the possibilities we created, what's truly wonderful is we did it together. Let's go higher, higher than we've ever gone before. And today, as we head into the future, fueled by cloud, AI, 5G, and the incredible potential of data, we are united by what we must do. We're making Intel hardware and software a catalyst for a better tomorrow. To protect our planet, make technology accessible to all, and enrich the lives of every person on Earth. Because the truth is, if you have an idea and Intel inside, you have everything you need to go off and do something wonderful.
Всем привет, меня зовут Анастасия Лубенникова.
Hello everyone, my name is Anastasia Lubennikova, and now I'm taking the form as the chairperson of this track. I'm a contributor and a developer of Postgres from, and I will be the host in this room till evening, so we continue our work. The next presentation will be developed to the use of high availability RDBMS in cloud. So we will welcome the speakers a bit later because this presentation was recorded, and now we will show you the recording. Please be active in the chat and ask questions. Speakers will answer them after the presentation.
Всем привет.
Hello everyone. My name is Andrei Borodin. My co-presenter is Evgeny Dukov. We developed management database in Yandex Cloud, and today we would like to speak about some problems of using high availability DBMS in cloud. In Yandex there are a lot of Postgres. Probably you know that we have Yandex Mail that gets about 1 million queries per second. It is in Yandex Cloud. I mean, the base of Yandex Mail are in Yandex Cloud, as many other services of Yandex. And totally, in Yandex Cloud, about 3 million queries per second are received. So, let's talk about the things that we want to get from cloud database. First of all, we want it to be available all the time. We need 4 nines for reading and 3.5 nines for recording. So for reading it means that total downtime should not be more than 4 something minutes. And we also want to get scalability in several availability zones in several data centers. And we would like to have relevant data copy in the analytical system. We need to have a reliable system that will satisfy the requirements of the service. And to build a reliable system, we can use our usual components. These disks are fault tolerant. Processors and memory can break up, as well as connection. So, data center is the reason of fault in most cases. And normally this is the way we formulate our requirement of database. It should tolerate the fault of one data center, and it should not result in serious consequences for the services that use the database. Another interesting aspect, speaking about clouds, is virtualization. Virtualization is a way to mix up the load of different users. So some components use disk, others the central processor, still others the memory, and only when we mix up different load profile we can get optimal use of the equipment. But speaking about virtualization, at some point one user may want more resources. They may need vertical scaling. And for the service, it looks like an inability to provide the resources. Well, it is not a fault, but this is a situation that requires serious change. And it can be referred to as a problem that can be resolved with high availability means. The standard approach to solving these problems is redundancy. So it means that we duplicate the equipment that allows us to be ready for faults. This approach is used in many cases. For example, airplanes have more than one engine normally, and other technical systems have redundancy as well. In cloud, a standard way of using duplication would be to use network disks. However, these disks resolve the issue of scalability for programs and systems that are not ready for scaling with their own means. And the database is written with the account of fault tolerance problems. That's why network disks will not be considered here. To use redundancy, we need to be able to create database copy and make it as relevant as possible. Traditionally, in Postgres, write-ahead log is used for it. And the main question, speaking about developing a relevant copy, is the way of delivering write-ahead log into the place where it will continuously restore most relevant state of the database. There are two technologies to deliver the changes that occurred in the writing node to the node where only reading queries can be fulfilled. This is, well, I cannot say that some of them are simple and others are complicated. But one of such ways is write-ahead log archive. When on the writing node, archive command is called, it saves a segment of a service of the archive, and on the restoring node there is a restore command that checks whether a new segment is present or not, and if it is, it brings it for restore. We need to understand that archive doesn't cancel replication, and replication doesn't cancel archive. A problem is that archive is a simultaneous interface, and it executes restoration and archivation on file-by-file basis. Many servers can implement this interface. Streamlined replication. These are several processes. Wall center process is launched on the writing node. It reads write-ahead logs from PGConf and by TCP send them to vault receiver following the standard processor protocol that pull this wall next to the replica, and the startup process of the replica, I mean the copies, execute these records and restore by each record the most relevant state of the copy. Streamlined replication also allows us to create cascades that is useful when the resource of network interface of the writing node is limited. Besides, streamlined replication accounts for the use of slot replications. They write the amount of data that were sent to the replica and the amount of data that were executed by the replica from the thread of write-ahead log. They are measured in bytes, and the coordinates are stem logical sequence number. Streamlined replication can be synchronous or quorum. It means that we have one guarantee. It's quite simple. When the client executes writing transaction and call for commitment, database does not confirm query execution until write-ahead log is transferred to the necessary number of synchronous replicas or quorum of synchronous replicas. Another important concept in Postgres replication is timeline. Every time when we install the base from backup or convert reading node into a writing node, the coordinates of write-ahead log choose a new timeline in order not to mix up the measurement history, I mean the measurements that were made on different nodes. And if replica did not stop in the timeline we need, we have an opportunity to travel in write-ahead log to the past. This yellow line is a timeline, and we can use PGRewind utility to go back And after it reaches the point of new timeline, we can start a story of a different timeline that was archived on a different node.
So logical replication is a replication where we transfer not binary changes, which bytes change on which page, but lists of modified lines in the database which were remotely created or modified. And logical replication has a number of benefits. It can help transfer changes to a portion of the database. Logical replication can also transmit data to another database of Postgres, and the receipt of logical data in logical replication is much easier than in physical replication from the software development point of view. And also it is possible to do major upgrade of the Postgres in the real-time mode. This is the topology of the cluster in the cloud, when we have some writing node which sends changes to the logical system. Synchronous and non-synchronous replication sends changes to the self-restoring nodes, and we can perform reading queries, and also those nodes ensure backup copying. And there are primary nodes, writing node. We can do archiving to the object storage. In our case, it is Yandex object storage. How do clients know where to go in this topology? We use target session address technology, where we indicate all hosts in each line of connection. Also, in the connection line, we mention the desired level of recording. The driver, be it GX, or APQ, or PGSQL, or JDBC, it will go through the list of hosts and ask each host, select PCG recovery, and if the node is not in the restoring mode, then it can accept writing queries. What happens when we reconfigure topology? The client receives a disconnection or hanging connection. With timeout, he understands that it is necessary to search for a new writing module in the cluster. It is critical to configure timeouts accurately. TPC uses a timeout time of expectation, and also correctly configure keep alives count. So keep alives will help understand that the network connection has been disrupted, and we need to look for the writing node again. So in this topology, sometimes we need to cover the writing node from the load, stop it, and promote to the synchronous replica. So convert the writing replica to the converting module, and return the writing node to the cluster by attaching it with the replica to the primary node. Do it with DBA is not easy. There are a number of systems that can orchestrate all this. PGOut failover, but the most common one is Patroni, Stolon, and RepMGR, and many other great tools. Sergey Dukol will explain how we wrote our HA solution, how we developed this solution together. Hello everyone. Let's start from the overview of a standard cluster. Fail-safe guarantee. We use an agent on node with Postgres. a lot of utilities use this, like a table, for example. As a DCS, we use Zookeeper, and Zookeeper cluster has several thousands of clusters of Postgres. It makes our life easier because there are fewer machines. To protect from the load, we stop the connection pooler, so we may not need to stop Postgres to do the reload. So this has been in production for more than 6 years. Let's have a look how the failover takes place. Let's have a look at the simple case of primary or failure. This may be due to the network or hardware failures. So log is kept in the Zookeeper. When PGConf at the replica sees that log is not held by anyone, it starts coordinating the failover. As soon as we understand which node is going to be the new primary, PGConf takes the log and launches promote. When the new primary node is fully available, we can turn the remaining replica to it. Starting from Postgres 13, it happens without restart. At the older version, with restart. We don't want to sacrifice availability, if possible. If all replica fail, but primary is available and DCS is alive, we switch to asynchronous replication. This leads to inability of failover as long as we don't have at least one replica and we don't synchronize with primary. Such optimization may be quite dangerous. We'll see later how we verify that we don't lose data as we use them. In distributed networks, there are a lot of moving parts, and a lot may go wrong. Humans have limited imagination on how to break the system. For that reason, they rely on fuzzing. There are similar utilities to test distributed systems. We use Jepsen as such a framework. This is what our test stand looks like. We take a group of containers with group compose, then Jepsen enters the container to launch the failure. It launches useful load with means of JSBC. There are a lot of ways to identify anomalies in distributed systems, but because we are interested in the loss of data, we use very little functionality. The breaks introduced in the cluster are not very complex. We use 3 major scenarios and combine them in different ways by making random delays between them. Number 1 is distortion of network connection between nodes when there is loss of connection between data centers. Number 2 is shown on the screen. We can do out of memory with poor OM killer. And third scenario is switch over launch. The way users do it through control point of our service. By doing this, we make sure that if the user launches this procedure and something unexpected happens, he will not lose data. Test load is quite simple. We create a table out of one field and try to insert values of the global counter into it. We do that in all Postgres nodes, regardless of what role they have. It's logical that the queries are lower in replicas, except for cases when PGConf killed the pooler and there are not enough replicas to meet conditions for synchronous replication. We remember the successful query and use it for understanding whether we lost data or not. We can split the query results into several multiples. Some of them overlap. Number 1 is errors. Can be separated between known and unknown. Unknown errors, it's an answer of inability to insert data. The rest is issues with the network, downing of the Postgres. But if we insert value, it was replicated, but we couldn't receive it as primary, connection is lost. If primary said OK for insertion, but we couldn't find it in the final table, this shows that data was lost, were lost. Let's have a look at the real bugs by which we found by using this approach. Example number 1 is quite simple. 7 years ago, we used an asterisk for the value of synchronous standby names. This Postgres then selects the replica. To understand why it is not always good, we need to have a look at the PGSync of those times. This is the old logic on primary and replica. For primary, we test whether we have lock in the zookeeper. If we do, then we update the visible replica in the zookeeper. This is necessary to understand who is the synchronous replica at a given point of time. What do we do at the replica? We see whether the primary lock is there. If not, then we need to double check. If it is available, then we need to promote. If we break the network connection, let's have a look on how it happens. On the left-hand side, we have primary and a synchronous replica and one host of zookeeper. On the right-hand side, synchronous replica and two hosts of zookeeper. This is the quorum for zookeeper is not available. It cannot maintain the windows. The synchronous replica will notice it and promote. And will promote. Only if Postgres doesn't decide to choose another replica as synchronous and fails to answer the user on the successful recording. Because information cannot be delivered to zookeeper, we will lose these records. This is an unpleasant scenario. What can we do to avoid this scenario? Let's add one more log. Any living replica will try to take it, and we will promote only when we hold it and we were a synchronous replica from the point of view of the primer. In primary, we compare the current owner of the new log and update the standby names if necessary, and we keep updating the information in the zookeepers about their connected replicas. The word new is in brackets and in parentheses. Let's have a look at the more recent example. There is a quorum commit with 4 major versions. Is it possible to lose data in this scenario? Let me remind you, what is this and why do we need it? Let's have a look at this cluster with 5 nodes, 1 primary, the rest are replicas. When we commit on primary, LSM increases. In this case, from 1 to 2. It goes up from 1 to 2. If it is necessary to wait for the answer from replicas, we may wait for any, if 1 is enough, of course. This helps us not rely on the productivity of 1 node. Obviously, we will not be able to avoid loss of data. We need to wait for 2 replicas out of 4 to make sure hosts have 2 before they give over to the client. Alas, higher performance will complicate switching to primary in case of a disruption. Let's have a look at a simple case with distortion of network connectivity. In our case, primary increases its LSN to 2 and waits for 2 replicas before it sends confirmation to the user on the successful record. Why do we wait for 2 replicas? It will help us to make a decision on selection of the new replica if most of the hosts are available, and we also keep the records confirmed by the user. If disruption occurs, we check if most of the nodes are available and select the node with the maximum LSN. As long as 3 hosts out of 5 are living, we can survive the disruption. In our case, to avoid loss of data, it is necessary to have replica with LSN 2. We need to understand what this LSN is and how to recognize it in the right way. To simplify this, we can show changes of LSN in this way on the slide. Primary hires its position, sends val to replica, replica writes val on disk, synchronizes the record, and replica plays val changes. The client may confirm the last 3 items, recording or playing of changes, or not to wait for replicas at all. In the last case, we cannot guarantee the data availability. At least the user should confirm record on the disk. So in the last case, there is a great function which helps us obtain something like this. Let's try to use this and see what happens. will have loss of data. Let me remind you that this is not the network disruption, but the CPU disruption. If we do this simultaneously, val receiver will start from the start of the segment, and the use function will return LSN to the past for a long time. Here we can look at the other command, but all clients will wait for replay to be confirmed.
PG-val receive LSN также сложно,
PG-val receive LSN traction is as difficult because then we'll need to use timeouts to guess
ситуацию, когда мы не теряем данные. Так что нам нужна
the situation where we're not losing data. So that means we need an alternative of some kind. And this alternative is quite simple.
Делаем мы это с помощью экстеншена, который смотрит
We
на
use
repo LSN
extension,
и
looking at repo LSN.
пока не споткнется.
So basically it runs until it stumbles. This is what PG-val dump does. You can do it, but val should be read more. And now Andrei will explain why all this is still not necessary to keep data intact, not to lose data. Yes, imagine we have a cluster where all issues mentioned by Sergey have been addressed. Then we have other new issues emerging. One of them emerges on the side of the query. Cancellation of query is important. If the server is overloaded, the driver of the client will automatically cancel the long-standing query, and the client should repeat it after some time to give the system to digest the peak of load and try to handle the pressure of queries. What guarantees are provided by synchronous replication in the cluster? For example, we have 3-tier cluster with synchronous replication. We have network partitioning, when primary instance is cut from the network from the rest. Any query must hang on the synchronous replication. This is a guarantee that we provide. What is the pseudocode of transaction? First, we find data that we want to modify, block from change, block them from modification, then change them in shared buffer. And before we record anything in English, we need to write a head log that we flashed locally and remotely to some of the replica. We wait for both these things happen, both events happen, or we wait until flash of LSM will get to a necessary point in the transaction. Then we can log data, and these data will be observed by new transactions. You also need to understand that replica may show inconsistent data. A good example is when replicas are lagging behind from the primary node. But it may be the opposite. If primary instance has a very slow disk and replica has a fast disk, then it gets val faster and applies it, and in principle on the replica you can see data which are a bit ahead of the primary instance, because primary instance does not immediately raise logs from data, and replicas those constraints will be lifted right after delivery. But the situation may aggravate. Let's have a look at the cluster of 5 nodules with arguable application on 3 nodes. 3 remaining nodes in one available domain of the node can select a new primary if they believe that all the rest are cut from the network. Imagine this happens. Primary node and 1 quorum replica are cut from the rest of the cluster. With that, the data that we try to commit to in primary those data are blocked on primary, we cannot see them, but we can see that on quorum replica, which disrupts causal consistency, and the external systems may believe that those data have been saved. But this is not the main issue. Let's move to the more serious issue. Let's imagine we perform a query that contains insert conflict do nothing. From some queue before the cluster, we need to insert it into the database. If the data has been inserted, it's an important question. We may repeat this query. We may think we may repeat this query, but in real life, it turns out that if these data are already in the database, we don't need to record anything. So we won't have to wait for flash on the disk, and we won't need to wait for the synchronous replica. If we send such data in primary, cut from the rest of the cluster, we wait for synchronous application because the cluster is cut off and no synchronous replica will not be able to confirm data. Then the driver says cancel.
We wait for some time, and after that the driver is cancelled. Postgres will remove this query. The data will be committed locally. And if the client tries to execute this query once again, they will get confirmation of the transaction because these local data are visible, although they were not replicated on a replica. So, after we realized this problem, we developed a patch that prohibits cancellation of executed locally query. This patch is available on CommentFest, but unfortunately it can resolve the problem with query cancellation only. So, if we reload the cluster, this problem can be resolved as well, because the logs installed on the data will disappear after the cluster is reloaded. So the system that provides for high availability of the cluster should monitor cluster reloading, and if the cluster is not a primary instance, after reloading it should prohibit reading queries to get into the cluster, into that node, until it is a full-fledged participant of a full-fledged replica in a newly built cluster. More information on this problem can be found in PGConf on Conference 2020. Let's speak about changed data capture. So, we take the changes, we capture them, and bring them to the analytical system. This is the scheme of our system. And from primary instance, we logically stream our data into the system. We should be ready that master in this system will change. And logical replication can be sent from master alone. This is a problem, because we need to change the threads of logical replication. Similar problem was seen when building analytics calculated by Postgres means. We needed to have replicas that will never become masters. This is non-highly available host groups. So we have a group of hosts that are HE hosts, highly available hosts, and they are authorized to transfer writing node, and everyone is streaming the changes from the current master. That is important to provide for data security. And we have hosts that are not hosts. They stream from one and the same replica. If one of the replicas fail, then the whole branch of this tree of cascade replicas fails. This is a problem. And we do not have clear rules regarding appropriate rebuilding topology of non-HA replicas. This idea of non-HA replicas does not help CDC because CDC in Yandex this is data transfer management. It is available in cloud only, and it can implement changes from Postgres, but we can stream these changes from primary instance only. To start streaming changes, we need to develop a slot. Physical replication slot can be created in the past. Logical replication slot can be created only in the current LSN. So, if after failover some time passed, between the launch of a new master and the connection of change monitoring system, we have a hole in the logical replication. It's not good for us. It's not possible to create a logical slot in the past. What can we do about it? Well, we could develop a logical archive. In physical replication, this replica comes to the current master, stating, I need this wall, master states, I do not have it. Then the replica will go to archive and find it in the archive because it is available together with point-in-time recovery. We do not have a logical archive. So, what could we do? Probably we could teach wall G to decode wall in logical stream. So it seems that for Postgres to deconstruct wall into logical stream, it's necessary to have shared buffers so it's necessary to have this PB data that can take several terabytes. We haven't started work in this area, but this idea of having a physical wall in logical replication is very attractive for us and we would like to see it. In analytical systems, sometimes we face a strange situation. Analytical systems can be ahead of synchronous replica. A synchronous replica is not always the newest replica with newest data. It can be just a replica that was designated as a synchronous one, and analytical system can be ahead of quarrel. And if failover occurs, if master changes, the analytical system will get some data that were not present in the timeline that remained the main timeline for the cluster. It would be convenient to have a logical rewind, but unfortunately it does not exist. It's not possible to rewind the flow of change in the other direction. To resolve these problems, we had to go to Postgres kernel. So we developed PGTM aux extension, auxiliary function for data management. This execution allows us to create a function to create it in the past. Probably in Postgres 15 we will have a function for creating replication slots in the past. We need to understand that if there are no WAL files about the past, it's not possible to create a slot. If there is a vacuum in the catalog, it's not possible to develop a slot in the past. It means that this extension does not give us any guarantees, but at least it is an attempt to do so. I would like to say a few words about similar technologies in MySQL. This is a serious database where logical replication was developed in a much better way, and all fault-tolerant systems were implemented on the basis of logical replication. There are several features there. The first feature that is noticed by everyone who is involved in change archive. If we do not have archive comment, it will not be synchronous. It means that we need to have a cron that will be scanning whether there are new logs that should be sent to archive. It's not convenient at all, but still we can do with it. In MySQL there are no timelines. Every host writes bin logs with their numbers. For example, in one cluster, there can be bin logs written by different nodes, and their numbers will be different. So, when we restore a cluster where primary instance was changed, we want to save 3 stories. And if we want it to be efficient, then these parts of story that did not happen should be deleted from the storage, or at least they should not be archived. And this is a complicated technical task. I'd like to say a few words about the advantages of MySQL. Logical transaction coordinates, state sets. They describe the position of every node of a cluster in all the history of changes at the same time. This is a genius technology, and I would like to have it in Postgres as well. And the main thing is that MySQL logical replication can position, so it can understand how much one replica lags behind the other. Not with the use of LSN of physical log, but with the use of JIT. This is very convenient. The instruments that you can use here.
Well,
the simplest one is the patch for disable cancellation of executed locally query. A will dump extension. This extension allows us to install true LSN for which replication was used on that replica, and PGDMOX extension that allows us to develop logical replication slot in the past. All of that is available in GitHub or in CommitFest, and we will appreciate any feedback. And in conclusion, I'd like to mention that high availability is complicated. Indeed, there are a lot of problems there, but we do not face them frequently, and the main thing is that we can do something with each such problem. We are very responsible for every byte, and we think that we have managed to develop a system that guarantees data protection with the set parameters. That's it. We will happily answer your questions.
I'm
happy to welcome the speakers on air, and we are ready to start our Q&A session. Hi everyone. Hello. So, we're waiting for questions on the chat, and I would like to thank you personally for the presentation. I watched it for the first time, and it's really great that you have this high-level description of the system, and you also described very interesting details. And now we have a question on the chat. In Avita, they developed Select for Update for the queries where it's important to read only the information replicated on the replica, and these selects will be slow if there is no synchronous replica. Oh, this is not a question, I guess this is an answer. The selects will freeze if there is no such replica, so it is possible to detect this situation. That's true. Select for Update approach works, but Select for Update changes data.
Xmax для таплов, которые лочит.
It creates Xmax for the tuples it locks. If several transactions lock the same tuple at the same time, multi-exact multi-transaction is developed, it is physically recorded. So we came there to read, but the data start changing, and it's possible to have some problems with the performance. Multi-transaction system is single-thread system, so it will be difficult to resolve it. In Comet Fest there is a patch that can improve it a bit, but this problem of multi-transaction is that this problem lags behind. It's difficult to reproduce it in a laboratory. So in principle, this approach can resolve a number of issues, but I would recommend you to use a patch for disabling cancellation of transaction awaiting for synchronous replication. And actually, I wanted to congratulate Anastasia with the status of major contributor, because you actually introduced yourself as a contributor, but I thought that probably you don't know that you are already a major contributor. Oh, thank you. Yes, I'm just being humble. So we do not have many questions on the chat, so I would like to ask my questions. I'm wondering, how do you return replicas if one replica fell and master wants to go back after a new master was selected? You do PG rebind, or you started from scratch? Well, it's interesting. At first, we wait the connection, because probably there is partial connectivity and we can see zookeeper hosts but not primary ones, and if we try to launch rebind against the host that is not available by the net, rebind will fall. And after that we try to do rebind. If we did not manage to do so, or if after we did rebind Postgres did not manage to get the primary, then we will refill it from backup. And there is an interesting point here. When we do promote, when we select a new primary, then some part of the wall that we had in the old primary can be in archive. So, val is recorded locally on primary, and after that it is sent to replicas, and archiver can have some time to download files. The history file should be in archive. It's important to avoid the problem of timeline following. We manage it, and with fallover from backup, our replicas are normally filled without problems. So the first attempt is rewind, and if we didn't manage to do so, we use backup. Thanks. Genia. There was a problem regarding the extra history file in the archive. Could you please remind me why it occurred? It occurred because sometimes we promoted unsuccessfully. And in that case, there is a probability that after the promote, Postgres will fall. And history file can stay in archive, and it's possible that we are on timeline 1, and we have two possible candidates, replica 1 and replica 2. We read to promote replica 1, it uploads its history file in the archive, but promotion is not successful. For example, there is a SIG fault. And after that we will not be able to promote replica 2 normally, because its timeline is 1. In the archive we will have a conflict. We can download these files incorrectly. So from the archive, this file should be deleted, and after that we do promotion. So the key knowledge is that fail can happen when we work out this fail. Well, it is expected, but we want to avoid it. Thank you. Another question from Maxim Milutin. In your HA scheme, how do you fulfill fencing of an isolated master? I spoke about it. The matter is that we put puller below, so we have connection puller, and when we understand that we need to close the master, we just put it down, and clients cannot connect it, and replicas turn to primary. But we do not launch connections in circumvention of cooler. Right, client cannot connect without cooler.
Another question, how do you fight with logical replication being so slow? Given the amount of modifications, everything will be quite slow in the loading system.
Я так понимаю, вопрос логической репликации
не тормозит? It's about logical replication and does it slow the process or not? We don't really see and feel this on our side. Logical replication. We use movement. We make movements with logical replication. Anyone who wants to move, they do that with logical replication, or they may face issues. I haven't had any questions or people coming to me with questions about performance. So it looks like this issue is not an existent issue.
Так, и еще тут есть благодарность за расширение
PGConf AUX. Well, people say thank you for the extension, and a question, is it possible to restore logical replication after the fallover of replic to the stream replication? Yes, this is done to be able to create a logical slot on replica right after the fallover. And this is the purpose of this tool. Another question. Have you tried synchronous and logical replication for the replica not to run into the future related to sync standby?
Синхронность репликации состоит в том, что мы...
The simultaneous feature of the replication is that we delay confirmation to the client. At the same time, we do not stop the attack on replica and emergence of data. Replication may be faster than synchronous replication, and the simultaneous feature of the replication doesn't prevent this. But this is an open issue. The analytical system may be a bit ahead of the cluster, and in case of a failover, it may have data which have not been delivered. But I guess this is a question for Postgres 15. Do you have work in progress? We discussed it once. This is the second time we discuss it. That means it is in progress, because interaction and dialogue is part of the process. So we are moving forward, of course. So we rose the issue. That means we started addressing it. Yes, it's good that you have identified it. One more question. Prohibition to bring the transaction back, may it lead to permanent, when the client permanently waits for the transaction? Yes, this permanent waiting may occur, but in this case, the client should have statement timeout configured, and then he will understand that there is no point in waiting more. So cancellation of synchronous application should look like this. If the client is connected to the old primary node, he should be prepared that it may not have network connectivity with the synchronous replica, and all transactions will freeze.
Спасибо. И, наверное,
Thank you.
последний вопрос.
And the final question. Before our speakers move to the special chat, please share your experience. Have you encountered an issue when you initiate logical replication on big tables, like billions of records? If yes, how did you resolve it? I do face it. I have people who came from Yandex, one of the Yandex services. They brought me the logs and said, so this is the report I received, and we see a mistake, an error that should have never had happened. So I saw this error on Friday, and I don't have a solution yet. There are some exclusive cases, and you need just to delve into it to understand the root cause. Table replication was possible even with more than billion records. 10 to the power of 9, yes, it was possible. 10 to the power of 12, probably not. Yes, we've had such issues, and we're fixing them. It's important that you fix them. Thank you for your presentations. Thank you for the answers. So, anyone who is interested can move to the special chat and interact with the presenters. And please vote for this presentation. Please express your appreciation. Put likes. We're going to have 5 minutes as a break. And at 2:30, please come back for the next presentation. Thank you.
Снова всем привет, и теперь я хочу пригласить в эфир
Welcome again. The next speaker is Ivan Panchenko. He will present live, and he will speak about the news and roadmap of Postgres DBMS. Welcome. So he will speak about Postgres Pro DBMS, although I cannot hear Ivan yet.
Небольшая заминка, извините.
There was a small delay, sorry about that. I'm back. I will speak about DBMS Postgres Pro, about the news. Of course, I will not be able to tell you everything. There are other colleagues who will speak about that as well. The one, by the way, going right after mine. Arseny also spoke about this. He spoke about the multi-master, and it was a great presentation. I will touch upon some general things and provide some examples on the new elements of Postgres Pro DBMS, because a lot is being done, a lot is being developed. So let's go. So what's new? So those who don't understand what is Postgres Pro, I will explain. Postgres has a lot of forks. So the community policy encourages creation of forks. They're useful to develop PostgreSQL and to develop the community, and a lot of companies follow that path. Basically, half of big companies who develop Postgres have their own commercial forks, and they are sometimes different from open source. There are companies who create specialized forks, and we have been working on our own forks, but at the same time we continue interacting with the community and with the open source. So where does it come from? In 2015, when we created Postgres Professional, we wanted to work with open source only, and we didn't even think about having forks. But our experience with working with customers made us conclude that customers sometimes need functions and features. If we create a lot of patches and each customer gets his or her own pack of patches, we have a lot of uncontrolled versions of Postgres installed. And if that customer comes to you and says something is not working, it is hard to understand what exactly is not working. So any software developer comes to an idea that it is necessary not just to create a different version for different customers, but to create a set of releases. So that's why we moved to our own cycle of releases and our own forks. So even in the first year of our company, we created Postgres Pro Standard, which had a set of patches, and then we created Postgres Pro Enterprise, the option that was expected to be used in the open source because it will be used for development of major changes. We wanted to give it to the community, but it was hard to do it technically, and it is sometimes hard to do it for other reasons, apart from technology reasons. Support of 1S, for example, or support of functions of certification of our regulators, certification authorities, might not be interesting to the rest of the community. But our Russian customers are interested in this, they need it. So it happens so that we have this fail-safe system with open source, Postgres Pro Standard, and Postgres Pro Enterprise, which is moving forward and is installed with major customers. Last year, we started moving towards the next generation of the databases. We called them Adaptive Cloud, which can adapt to various loads or may require various loads. When this project is implemented, it requires less management and administration, less management and control. So we are working on this Postgres Pro Adaptive Cloud to make it more available to operate in the cloud environment, to be more scalable, and to have other features. What is Postgres Pro standard features? This is the right set of tools for our users, a useful set of extensions. For example, for 1S ERP system, which is popular in Russia, it also offers extensions and patches which are not available in the open source Postgres. They are fully or partially open source, but these are our own developments. P-Track is a new thing that helps us create incremental backup by tracking changes between regular backups. And we have developed tools for backup copying. It knows how to work with P-Track and perform incremental backup. Another set is tools for monitoring, PG Pro Stats and PG Pro Power. PG Pro Stats is a tool that remembers the plan of queries and can move along the plan. PG Pro Power is similar to Oracle AVM. So this is what can record snapshots. And as a result, we receive a history of loads. I think we'll have a separate presentation dedicated to it, so I will not dwell on it too long. We'll move on. Enterprise, Postgres Pro Enterprise, is a deeper version of Postgres, and one of the fundamental things that it has is 64-bit XID. When Postgres Pro Enterprise was put together, we met with the customers who had wraparound at the operating base. It was very painful and hard, and we thought that for the enterprise application, it was necessary to create the 64-bit XID. Well, the wraparound has improved over time, but still, 46-bit XID is important. It helps you avoid a lot of issues and headaches. Multi-master. We've had an interesting presentation made by Arseny this morning. Arseny spoke about a lot of subtleties of multi-master. I should mention that the current version of Enterprise that will be released this month, multi-master has been seriously redeveloped and advanced. It has become much more reliable, and it offers better performance. Another important feature is compression. I must mention this because in some cases it reduces the scope of the database in some cases. Anton Doroshkevich will speak about this and provide examples about data compression, how data is compressed several times, and it is performed better than at Microsoft SQL Server. There is a lot of criticism. When you move from Microsoft to Postgres, you may have some issues, but as far as compression is concerned, compression is really good, so you will hear this report later. So the new version don't have anything new in terms of compression. We only checked a couple of bugs, and that's all. What about the rest of the features? We've had some internal optimizations that we've done that may be related to the sizes of data structures, related to blockings. This is what we see in our customers, and we just make changes in the minor versions for Postgres to be able to handle high loads. Auto-prepare is an interesting feature. It is helpful when your software cannot handle all the queries, and for that there is shared cache, shared prepared statements cache, operating on the part of the server, a very useful thing, and there were customers who were looking forward to it, so there it is, we have it. A relatively new thing that we have is built-in connection pooler, with some constraints, of course, but it may be helpful, faster than PG bounces in some cases, and there'll be an article on Hubble dedicated to it in a couple of months. You'll be able to read about built-in connection pooler. The next thing is machine learning based on adaptive query optimization, AQO, and we set high hopes on it. We've been researching this issue for several years, and the next version will include AQO, and we know how we're going to develop it further in the future. One more new thing, and we did not have this in the past, is seamless minor updates. This gives you an ability to update the database without stopping it, although it is not possible all the time, in every case. This should not be, in principle, because the shared memory structures which were provided in the previous minor updates. Well, we cannot really guarantee it 100%. If the next minor version doesn't make any changes, doesn't change the data format, then this will work. Seamless minor updates will work. It will tell you that in a given minor update, you can apply this. If you don't use this and that, you can apply seamless minor update. Moving on, there will be a report on seamless minor updates and on AQO. What are we going to develop this year in 2021, and what is in progress? Number one priority is sharding. Dmitry Ursegov will speak about sharding at this conference. So the approach is that when we do sharding on the basis of regular Postgres, such as replication, FDV, and partitioning, we can easily imagine that if partitions are located on remote servers, partitioning turns into sharding. But it isn't that simple. To make this work fast and provide scalability and performance, ability to work with a big database quickly, you need to work hard. And this is what the team of Dmitry Ursegov is doing. It is trying hard, and we are now releasing sharding in the experimental mode. However, everyone can test it. This is not part of enterprise solution. It's a standalone assembly of Postgres. But we're doing more research to that regard, it may turn out that our approach is simply a way to say no to RDV, for example, and we may replace some elements with the specially developed elements. So catch-up replica is something that enhances reliability. PG Pro Backup, I mentioned this. This is a means for backup copying. We've been doing this for quite a long time. And this year, we're going to learn how to store reserve copies on various servers.
It will be very useful, and it will allow us to easily apply it when it's necessary to back up a lot of servers. And it's not convenient to have a lot of data warehouses for backups. It's more convenient to have one cloud storage. Wall circular buffer is a new feature. I will describe it on the following slides. It increases the reliability of high-performance system with replication. AQO, we continue developing it, and there are also works devoted to JSON performance improvements. This is a very good optimization, a very beautiful one, and in a number of practical cases, such optimizations allow us to increase performance of JSON. Of course, it cannot be applied for everything, but in cases when in JSON there are small data and large data, I mean that there are metadata. For example, you store a large text in JSON and a description to this text, then it will be easier to work with this test. The work will speed up several times, probably even 10 times faster. We are planning to finish SQL JSON in accordance with 2016 standard. We will make JSON table functional. We are developing TDE, transparent data encryption. Many banks want to have it, and we have found a technological partner, together with which we can develop it. And our community is developing it as well, so it's possible that we will have 2 or 1.5 versions of TDE. And we are also actively developing a convenient environment for Kubernetes setup. Now I'd like to say a few specific things. So what is circular wall buffer? Normally on master, working with wall looks as follows. Wall writer takes brackets from the memory and puts them on the disk, and wall sender sends them to replica. But it turns out that an error can occur on the disk or in the memory. And it can happen that the wall will be distorted. In Oracle, it's possible to write wall twice. Of course, it slows down the process. So we decided that we do not want to slow it down, because it is done for high-performance systems, and such errors can be found fast. We do not want to write the second copy of wall. That's why we developed the following approach. We develop circular wall buffer in the memory with wall brackets. They are recorded continuously, but they are used if it wasn't possible to read it from the disk. So, if we read a wrong CRC from the disk, this is a fault. It means that we need to throw away this disk and this server. But if it's not possible to stop the system, it can function for some time until they bring the disk and switch to the replica. So this algorithm works the way you can see it in the right part of the screen. So if CRC was wrong, we should try reading it from circular buffer. If the circular buffer was exhausted, it means that we were waiting for too long before sending the ball. In that case, it will not function. But probably I didn't tell you about one feature. This is catch-up replica. This is the next thing. When you need to restore a replica because of wall loss, imagine that you are having replication but something went wrong. Due to some reason, the replica was suspended, or during the transfer of wall segment, a fault occurred and wall segment is defected and you cannot continue replication. In that case, normally, you should just reload the replica from the master as a whole. It can be quite big and it can take a long time. That's not good. That's why a system was developed. Using this system, it's possible to reload this replica to refresh it on the basis of reading changes on master. This is quite similar to ptrack when we see what has changed, download it on the replica, and in that case replica becomes synchronous with the master much faster than if we reloaded it as a whole. This is catch-up replica. Now I'd like to speak about our long-term plans, what we're going to do in the future. So, I'd like to speak about 3 main areas, but it's difficult to select 3 of them, that's why we'll speak about 5 of them, so that it will be easy for you to count them on your hand. This is scalability. First of all, it's sharding. But sharding is needed not just to learn to implement the scheme with cluster on the basis of FDV and partitioning, but we need it to make something that will increase performance, because all the elements that we are using now are quite slow. Manageability. This is something that clouds need first of all, and a cloud is a situation then there are a lot of bases and not enough admins. This is actually the world is now. The number of bases grow faster than the number of admins. That's why it's about different level manageability, monitoring, decision-making system, database configuration, ability to develop indices, partitioning, sharding, all of that should be automated in future. Another important aspect is the aspect of security, increasing reliability, and actually I spoke about 2 solutions that we developed for reliability, and all of that leads to the cloud. This is a happy person sitting on the cloud, and enjoying Postgres. Probably you can see an elephant on his laptop. So, this is what I wanted to tell you, and you can learn some details, asking questions, or listening to my colleagues from Postgres Professional. Thank you. Thank you, Ivan. You can see that you have a lot of thoughts, and it was quite difficult for you to speak about all of them within this brief time. So, the presentation was really interesting, and I would like to move on to questions. First of all, enterprise. Are you planning to open code? And here they're asking about scheduler and connection pooler. Well, speaking about opening code. Actually, we are continuously trying to give something to the community, and we will follow this way. Of course, we will not open everything due to various reasons. And speaking about connection pooler, we'll see. Well, probably, it's quite probable that we will open it for connection pooler, but most likely there will be another option of connection pooler. It will be more advanced. Speaking about scheduler, it's quite probable that scheduler extension will become open. It has worked for a long time, it is quite good, and the community needs it for sure. So, you can await it. Speaking about calculation and planning of statistics inside JSONB. Now JSONB is engaged in another thing that is also quite useful, so probably next year we will be able to do it. What else do we have? Are you planning to optimize working with transient tables? Yuri is asking that. Yuri, we had several approaches to the optimization of work with transient tables. Some of them were included in Enterprise. I don't remember which of them were included because I really hate transient tables. And we decided to postpone this issue. Not all our approaches were successful because they require a lot of changes in Postgres, and unfortunately, transient tables are made in a simple way in Postgres. They're quite similar to normal tables, and that's why it's difficult. And if we want all these transient tables to work appropriately with clusters and CMasters, it is related to even more constraints than we can afford. That's why now we will not do anything new for transient tables in the near future. Well, I guess that we will have time for another question, and after that we will continue talking in special chart and normal chart. Question: are you planning to optimize structures of PG-lite objects? If there are a lot of records with this data type, PG update can take a lot of time, just as PG dump. That's true. This problem exists. So, we're thinking about the extension that will be used instead of PG-lite objects that will optimize all transactions with large objects. PG-lite objects, well, many people are afraid of using them because there are some constraints, and they use bytes instead of them. So actually we've seen byte tier with hundreds of megabytes size. It happens, but we will follow a different way. Thank you, Yvonne. I would also like to thank our listeners for their questions. Now you can continue communication in our special chat. We'll have a very brief break, just several minutes break, and after that we will invite our next speaker. Thank you, Anastasia.
Итак, у нас 15:00, время следующего доклада. Он продолжает тему разработок компании Postgres Professional. Это доклад о постгрессовом планере.
So we will have another presentation about the Postgres Memory Planner, about optimizing Postgres Planner for various situations. This presentation was recorded. After this presentation, we will see the speaker that will answer your questions. Hello, my name is Andrei. I am Postgres professional company developer, and in my presentation, I would like to tell you about the problems faced by Postgres Optimizer and about the way it would be possible to resolve these problems if it had memory. Actually, we had a product, AQO, this is Adaptive Query Optimization, and initially, in 2016, it was offered by Oleg Ivanov, one of our developers, and it was devised to improve the quality of query optimization in the course of work of Postgres instance with the base, knowing what queries are received and their frequency. Actually, the issue of adaptive optimization is quite complicated. We tried several approaches. We tried recommending it to the optimizer of cardinality, but the essence is similar. The system is built on machine learning, so it can mistake. It can suppose something and it can mistake, and that is bad that instead of several milliseconds, a query takes several hours. So now we'll speak about another functionality that is much more stable. This is something given by the base of knowledge collected by this tool, and we will speak about the way it can influence query execution. To store data on queries in a compact manner, the system of signatures is used. I would like to consider a simple example. We do not have much time, but this topic is quite difficult. That's why I created a repository on GitHub, and here you can see QR codes. You can follow them, and this will be a direct link on the data scheme and on the queries. So, the first example is two tables, persons and employees. Here we are trying to find all truck drivers that are older than 65. So you can see that every node has its attributes. Scan node has attributes. Table, each. The other one has employees and position truck driver, and join node has both these tables. Aggregation is not used here. Probably it's not good, but it is this way. And these parameters form a signature for every node. For scan node, we unite two lists. We join two lists from the tables, form expressions, and we take hash for storage. We do it in a similar manner for the second scan. For join, these are all below tables and all below expressions, including the filters on age and position. And here we have another type of signature. This is query signature. This is a view of all the query and a hash taken from it. This is feature space. And the signature of every node of this query is feature subspace. We divided them in such a way to decrease correlation between queries and correlation between hashes. And it is stored on the disk in the following manner. For every feature subspace, we have information of its feature space and its queries. We store selectivity and cardinality of each expression. But these are absolute figures. You can see that we drop constant and systemic fields from the signature. It is done for one and the same hash, for one and the same signature, to describe as many options as possible. Thus, we can achieve compact storage. We made a test on 1C Highboat database recently, and it turned out that there were not so many queries.
and we have identified subspace, so it is quite a compact storage for a given database. Once we have this knowledge, we can recommend as follows. For example, we recommend through hooks. Hooks are taken at the time of determining the cardinality and also at the time we understand the number of joins, and we create a hook at the end of the query performance, so at the end of the executor's performance. And after the executor did its job, it is possible to correlate its suggestion with reality and how successful its operation with the node was. So after the performance, we can adjust the forecast. How does it help improve the planner operation? Here is a simple example. Dependence between the columns in the table. Here we have an example. We select person from the table, age below 18, so the forecast is 286. But if we add a second condition, availability of a passport, and a passport is issued at a certain age, so we see that the planner slightly reduced the number of predicted rows, but it could not, it actually predicted 2 times lower than we actually obtained. The number was 2 times lower. So if we turn AQO on, the first iteration is regular, and the second iteration, at the second iteration, we received the accurate value, and the forecast was accurate. Also, you can see where are the fields, what are the fields, and from which fields the information is added. And also, we can see the operating mode. This is not a very practical example because such functional dependencies may be adjusted in one table through expanded statistics. In this case, if you create statistics for 2 fields, age and passport, then those functions will be analyzed simultaneously, and the forecast will be accurate. At the same time, it is not easy to find those functional dependencies, especially if the database is big or if it is not your own database. And also, if the database, you don't really own it 100%, maybe this is 1S. 1S can create its own table and columns and do the same job. AQO helps find areas where queries are wrong and easily find those functional dependencies. In other words, analyze the database in full. The next example is more practical. This is about join. Predict cardinality of join is possible if there are functional dependencies between the attributes, although it is difficult because we don't have cross-table statistics that would help us analyze. We can refresh regular statistics, but it doesn't really help every time you receive an inaccurate result. Even if you see that the query is wrong, you can't do anything about it. Let me demonstrate you an example. For instance, you search for loaders. Imagine a loader, a person can become a loader or handler after 16 years of age, a person older than 16 years of age. So if we select loaders older than 50 years of age, you can see that on the right-hand side, although one of the scans was 10 times wrong in terms of the number of people, but the join was predicted accurately. So in both ID fields, you can see distribution, and the forecast was accurate, but the number of rows was predicted accurately. If we look at the people aged below 18, here we have functional dependencies,
and you will find nobody in this position. Here, join is mistaken by three times. Makes errors during scanning. This might not be a big issue, but if query will be part of a bigger query, we may face a lot of latency, a lot of delays. Another example is about auto-join. Auto-join issue occurs in 1S quite often. Auto-join is a connection of two tables, and the result is all rows from the left-hand tables and the rows that match with the right-hand side table according to the given conditions. So if there are rows from the left-hand side table and no rows from the right-hand side table, they're inserted into the right-hand side table. So they may appear in an arbitrary number. It is not easy to forecast such situations, and you can see it in this example. In this query, you need to understand the number of non-working garages. So there is a connection between person in the left-hand side and employee in the right-hand side. You select the field called company and then calculate the number of zero fields with zero values. And on the right-hand side, you can see auto-join did not even try to make a forecast, to make an accurate forecast, and made mistake by 5 times. So instead of 1, it showed 90,000. What might be the implication of this? This is a more complicated query where we use the previous subquery and we ask to select the number of handicapped people among the non-working people. So here we join with the table of people with disabilities. So it's a regular join of ID. And we see that the query is slow working, 4 to 5 times slower, even with the best settings of Postgres. 70 versus 16 milliseconds. How can AQO help us? On the left-hand side is the simplified query, standard optimization of Postgres, and here you see it looks like everything is correct. Join in one case, hash and joined in the other case, but when we transfer data that the number of cells will be much higher, then on the right-hand side, so we know that we will get 90,000 cells. So it has included parallel working. It changed the order, the sequence of joins. It omitted connection, disabled table with employees, and it used disabled and employees nested loops. Not simple nested loops, but parametric nested loops through index scanning. And the acceleration was quite good. The obtained acceleration is easy to identify this manually. Another important thing about it is availability of memory. In Planner is foreign data wrappers. We've faced this issue recently. Foreign data wrappers help us connect to remote servers, even Postgres servers, and work with them as with regular tables. And here we saw that this methodology was quite raw in some of its aspects. For example, to create statistics for such a foreign table, you had to download all rows from this table to the local server and analyze them. Moreover, if you deal with partitioned table, you need to download those rows 2 times. First time you download all rows of each foreign partition to the local node and build statistics. And the second time you do it, you download all rows of all partitions to build statistics for the partitioned table. So planning will not be possible without either of the two. There are also issues with push down of the join. Postgres Planner, by default, believes that join on the remote side will be performed through nested loops. Maybe worse than just making hash join and downloading all the data locally. It is not easy to explain this to it, and the availability of memory helps us make such decisions, memorize which join was performed, and then use it next time. The same tool that is supposed to fight remote estimate in foreign data wrappers. It is implemented inefficiently in the form of explain. Explain needs to be done on each foreign scan in each partition of each join and send a query to a remote node, do it, but it is quite slow. AQO helps to meet a query, and next time you will not be able to repeat it. You will not always have to update statistics in this case. And finally, I would like to tell you about the search of possible query performance. Some colleagues said they would like to see alternatives of the planner, which the planner had when it planned queries. How to analyze this and provide the best option. If there is memory available provided by AQO, it is possible to do this. I'll show you how it can be achieved. Here we have a simple query. Select all managers in the company with SAD1. A simple merger. You see the explain of this query, and it looks a bit suspicious. In the following places, we have overestimate of join, we have overestimate of scan, and thirdly, the second of the merged tables is very small. It is in the enabler. Let's try to do something with it. We turn AQO on, it adjusts forecasts. It gives you the number of forecast rows, and nothing changes. It happens because optimization hash may change. And it might be the case here. That's why we will try to change the behavior of the planner by changing the forecasts. For example, for index scanning in-person table, we take hash. It starts at -115 and see what we have in the table. In the knowledge base table, AQO. Here we have a record. It belongs, we see the number of expressions. Most frequently, it is 0 in our case. And we see target field. Target is an implemented view of cardinality, an algorithm of cardinality. So we take the update in the target field and put a small value close to 0 to get 1. So we turn 100,000 into 1. And then we get the totally new plan. We see nested loops here. We see that the planner changed the tables, switched the tables, and they made a parameterized plan, and we see that we have acceleration. And this is how we were able to see options and understand how things can be performed faster. Then AQO saves such a result and will use this plan, or at least it may have an alternative, as updates are adding up, or columns are adding up. Maybe distribution will change, and the plan will be different. That's all I have. Thank you.
Спасибо большое за запись доклада. Теперь с нами в эфире.
Thank you for the report. Andrei Lepikov is with us online. He is ready to take your questions. Andrei, thank you so much.
Так, тебя, кажется, не слышно.
It looks like your microphone is muted.
Да, что я могу пока сказать? Я могу...
So what can I say? While we're waiting, yes, indeed, it has been a very interesting presentation.
Даже в других докладах мы слышали вопросы про планировку.
And in some presentations, we heard about the planner and how to optimize it. I'm sure this extension will help cure some of the issues.
Да, наверное, у нас технический перерыв на минуту или две, пока мы ждем.
I think we'll take a short break, technical break. It will take about 1 or 2 minutes, and we'll come back to you, and we will start the Q&A session.
Да, после небольшой технической неполадки мы вернулись.
So we're back after a short technical break. Let's get to the questions. Question number 1, how to use all this magic and when it is going to be available, in which version and with what extension. It will be, it has been available starting version 9.6. You will be able to use it starting version 12. You can always take a master and apply it, and everything will work. So this is AQO, the extension of Postgres Pro. Exactly. Thank you. I will send this link to the chat as the answer. What is hashed for the plan? What exactly is hashed for the plan? There are 2 types of hash. Feature space. This is hash for the implemented view of all the plan with removed system fields and constants. And the second feature subspace is hash from end node. And there we use a different principle. There are two lists, table list and expression list. They're all sorted to avoid any switches. And then we take hash. Thank you. The next question, are there any head costs used with AQE? Well, if the queries are short, then there are costs. We thought we would. So, but the cost will be close to zero. On average, with AQO, you have the throughput, which is 2 times higher than without it. Thank you. And the next two questions are very much alike. Number one question, are there plans to add AQO to overscore? And the second question is, what does the community think about AQO? We haven't discussed it with the community yet. This feature is very enterprise associated, because forecasts may be negative, predictions may be negative, and this deviates from the planner that we have. So community wants things to be intact, not to be go wrong. Another question, it's a similar question about overhead costs. If you use AQO, what would be the overhead? At the execution level, there will be no overhead. Only at the time of planning. It should read it from its tables and define its predictions. And also in the end, there might be a slight overhead, a small overhead, when you need to enter data in your tables. So if you use self-TP for very short queries performed in milliseconds, it wouldn't be good. You'll have to use it in the manual mode. There is a special mode called frozen, which minimizes recording in tables. For big queries, you won't see the difference. Thank you. What about the manual mode? Is this the one that we turn on for specific queries? Yes. When we turn it on for specific queries, train, and then turn off training, and you just rely on the available knowledge. So there is no recording. And this minimizes overhead costs. Thank you. One more. AQO looks like Luma join. I don't know how Bloom filter on Oracle operates, to be honest. But in this version that we have, we do not recommend to use join. It's quite dangerous. You may make a mistake, and a gross mistake. What is available in master is improvement of optimization through improvement of predictions, of cardinality, each of the subtrees of the query. Thank you. Well, no more questions in the chat. I have my own questions. AQO, do you use it only for select or complex queries like insert can be optimized with AQO? Yes, insert which has select inside it. Yes, actually it doesn't care. It identifies signatures. And signatures is a set of relations and a set of expressions. It is the same for select. So everything will work fine. Thank you. One more question in the chat about interaction with community. Can you commit it as contrib? Well, there are 20% of chances because we're always able to make a bad prediction. It is hard to understand whether the prediction will become many times worse than it is.
So we have some time left.
Еще у меня такой вопрос тоже про...
And I have the following question about partitioned tables.
оптимизации для них.
Are there any optimizations for them? Optimizations that are specific for them? From the standpoint of query, that is quite normal. It's just necessary to correctly process append. That's great. And are there any other limitations in AQO? What do you mean by limitations? It's always possible to face a combination of nodes that it doesn't know. In that case, it will just ignore it. But actually, we tested it on 1C, and we didn't find anything of the kind. So, normal planner will work out, and query will be processed as usual. Yes. Great. So it's not that dangerous. Well, this is one of the safest tools. That's great. Really interesting. Thank you for your presentation. And now, I would like to invite you and other people who are interested in this issue to talk to each other in a special chat. At 4 o'clock, we will have a masterclass of Alvaro Hernandez. He will speak about deconstructing Postgres into a cloud platform. This is a masterclass. At first, there will be a presentation, and after that, a demo. And this demonstration will be in real-time mode. You will be able to repeat after Alvaro in your PC. And for that, you need to set Kubernetes cluster that you will use after that. So, please use this break and get ready for the masterclass from Alvaro. Thank you.
It's the most powerful word we have. A simple word. Do. As in, I do. As in, just imagine what we'll do. As in, don't tell us what we can't do. I'm unstoppable today. Because with Intel-powered AI, cloud, 5G, there's no limit to what we can do. They said we'd never do this. Soon we will from 12,000 miles away. But there's still so much left to do.
So what are we gonna do about it?
How about something that enriches the lives of every person on Earth? Impossible? Not if we do it together, because all you need is an idea, an intel inside to do something wonderful.
Так, добро пожаловать всем на продолжение нашей конференции. Следующий слайд.
Welcome everyone for the continuation of our conference. Our next slot is quite large. We will have 3-hour masterclass. At first, we will have presentation that will last for about 1 hour. After that, Q&A session. I will conduct it together with Alvaro. And after that, we will have a masterclass where you will be able to try to set your cloud cluster from Postgres. The presentation and masterclass will be in English, in live mode, with simultaneous interpretation.
Talk about how to run Postgres in the cloud, how to turn it into a cloud-native platform, and you're welcome.
Привет, как дела? Я по-русски русский, so I'm gonna continue in English. Hello, everybody. I'm very happy to be here again on this conference. The first year I'm going to this conference, and I'm not in Russia. I really regret that, but it's what it takes. So thank you for being here attending this talk. The goal of this talk is to basically take a very wide and open view on how to take Postgres, the Postgres that we all know and use every day, and see if we can rethink it. And actually, I'll explain why we constructed it into a platform that may run natively in cloud environments, or particularly what's called cloud native, which typically refers to Kubernetes and its ecosystem. So the path we're gonna follow today is basically how to take this Postgres, again, that we all know, some people call it the monolith, but definitely it's a piece with a lot of integrated components, and see if we can take some of these components out and offload functionality to well-known software on the cloud-native ecosystem, such as Kubernetes ecosystem, and run it on a different way. Rethink how Postgres is deployed, how Postgres is automated, and how Postgres integrates with all the components to make it a more cloud-native experience. I will explain what does it mean. I'll not get into buzzwords. This is not about trying to make things hype or overhyped, but a reality on how to really take a very old, but at the same time, of course, new and powerful technology, Postgres, into the Kubernetes ecosystem and cloud-native ecosystem. So bear with me. We're gonna have this session split into two. There will be a presentation part at the beginning, starting right now. Then we'll take a short break before a Q&A session. We'll have a Q&A session, then we'll take a short break just to freshen our minds, and then we'll go into a hands-on lab session. I'll run that hands-on lab session, but you're more than welcome to also try this at home or at the office or wherever you are. The only thing that you need is a Kubernetes cluster. I'll also explain how to create one on cloud if that's not, just in case. But if you have a Kubernetes cluster next to you or handy, get it prepared, because in the second half of this presentation, you're going to be able to exercise everything we're going to be explaining today on your own Kubernetes cluster. So before starting, compulsory slide about myself, or the who am I? I am the founder and CEO of a company called Postgres. Postgres means on Postgres, so it's pretty easy to understand what we do. We're specialized on Postgres, right? I've been myself for more than 20 years a Postgres user and Postgres DBA, application developer in Postgres. Like I've worn all the hats related to Postgres world, and I love to basically belong to the field of R&D, research and development, trying to come up with new ideas, new technologies to empower the Postgres world. I'm actually a quite frequent speaker. This is, I don't know, my nth talk at PGConf.Russia and many other database conferences, also some programming conferences. some past projects that I've created in the past or architected, lead, like ToroDB, for example, software, open source software that we developed to replicate real-time from MongoDB to Postgres while transforming JSON documents on the fly to relational data structures. And I also like to do a lot of community work. I founded a nonprofit in Spain, but with international aim, called Fundación PostgreSQL, a nonprofit dedicated to Postgres. And well, I tend to have experience in the cloud. I've got this recognition called Amazon Data Hero. But I like all environments, all cloud environments, and I work all around the place. If you want to find me, I can be found on Twitter, on my email, but also all my references, public references, are on my website, aht.es. You'll find on the bottom right on the screen. Feel free to check it out. All my talks eventually also end up being there. This one will not be an exception. So ping me on Twitter, email, LinkedIn, website, no problem. All right. So before diving into how we can deconstruct Postgres, let's look at what I call the stack problem. So let's look at, if we take Postgres and we look at containers. Containers, are a convenient way to pack functionality of a given software and gives us an uniform comparison point. And let's look just at the beginning to start with at the size of a container. And let's compare Postgres containers with Oracle containers. This might not be a fair comparison, but bear with me. So if we take Postgres container, the official Postgres image by default, it's around 300, 400 megabytes. There's even a simplified or reduced version, which is based on Alpine Linux instead of Debian Linux, which is even less than 100 megabytes. So we could say that Postgres database, it's actually quite small. Source code of latest, not the latest, the prior version, just as an example here, Postgres 12, source code is just 19 megabytes, of course compressed, but then compiled Postgres, all the binaries are actually no more than this size, around 20, 30 megabytes, all these binaries, and you don't even need all of them to just run Postgres database. It could be actually possible to create a Postgres container with just the very few binaries and libraries, shared libraries and small some configuration files on a kind of a distroless container that will be able to run Postgres perfectly well, ready for production environments in probably around 20, 30 megabytes. Maybe a little slightly more, but this is the order of magnitude we're talking about. Either less than 100 for like strictly strongly optimized containers, or a few hundred megabytes for containers including full-blown distributions. So I would say it's a pretty lightweight given all the functionality that comes with Postgres. Now, if we look in Oracle container for version 12, for example, it is 3.5 gigabytes in size. Wow, this is 10 times more, one order of magnitude more than Postgres worst case scenario. So why is this? Why Oracle container is so much bigger than Postgres? Is that Oracle is so much better? Well, definitely not, and I'm not going to get into that fight right now. It just comes with more things, which obviously makes up for this size, right? So if we look at this, Postgres in reality is just a kernel, right? When you run Linux, you boot a kernel which takes care of the operating system and devices and exposes an API, the system calls, but then you need tools on top of that. It's typically the GNU ecosystem, right? All the tools that we know, the shell, the grep, log, ls, and all these binaries and shared libraries that we have, that typically goes together. You normally don't use just the kernel itself, right? So Postgres is not so much different from this. You just typically don't run Postgres itself in production. You need to bring together with Postgres a set of tools that you will use in production environments to provide functionality such as backups, connection pooling, monitoring, etc. We're going to talk about this. So we tend to think of Postgres more as a distribution, that what you need is a distribution of components, including Postgres plus some others, in order to deploy production workloads. So it can kind of require a red hat of Postgres to really run Postgres in production. Now, where do we find all these tools? In the Postgres ecosystem. Most of them don't come with Postgres itself. Postgres relies on the ecosystem, where you may find typically it's open source, but there's also proprietary tools, and you'll find everything, practically everything that you need for this enterprise stacks, enterprise workloads needs, all the tools that you may need. Now, the ecosystem, it's a little bit like Dr. Jekyll and Hyde, Mr. Hyde, because there's good things about this, and there's also not good things about this. The good thing is that there's a lot of variety. You can pick any tool that you want from the ecosystem, and there's a wide variety of tools for almost any functionality you want to cover, and so you're well covered. And the bad thing is that there is a lot of variety, exactly the same thing, because there's a lot of variety, you need to pick, and picking is not easy, especially if you're not a Postgres expert and you're not well into Postgres. Which of these 3-4 connection poolers should I use? And how should I configure it to interact perfectly with all the components that I have selected? So it's good for Postgres experts, might not be that good for non-Postgres experts. And one of my goals definitely is to bring Postgres to many more people than it is right now, including non-Postgres experts. So what are those components? These components that I'm referring to all the time that should compose what I call this Postgres stack. It should be an enterprise-grade stack, which is what you need to run Postgres in production. There are several of them. Let me briefly describe them. First of all, we should talk about optimizing the configuration. Postgres configuration by default is quite bare bones, is quite conservative, and we really need to tune this configuration, right? There are several resources that you may use for this. There's not like a lot of downloadable tools you may put into the stack, but at least there's some online resources. There's one that actually we created in our company called PostgreSQL co.nf. So it's like PostgreSQL.com file, except shifting the dot 2 places to the right. It is a quite handy free online resource containing both documentation about all Postgres parameters in all versions and translated to 5 or 6 languages. But it also contains a new functionality recently launched where you can just upload your PostgreSQL.com file and have it tuned, getting a tuning guide with recommendations there, store your files there like if it was like your GitHub or repository of PostgreSQL.com files. And you can also download in several formats or use an API to gather these files and include them in your Ansible or deployment scripts or whatever you want. So this is the first step, to configure, to tune the optimized Postgres configuration and being able to have an optimized configuration, which you may leverage some tools that exist. Then it goes connection pooling. It's well known that Postgres needs to be deployed with connection pooling. There's very few use cases where you shouldn't deploy Postgres with connection pooling. I'll not get into the details. This is a really long topic and conversation, but basically this graph that is shown in the screen shows that Postgres on a small server, in this case, just to show as an example, may struggle, may do well with if you throw in a lot of connections, concurrent connections, in terms of TPS transactions per second, but latency will spike to unacceptable levels. And the way to solve this is by using a connection pooler. So you typically want to use a connection pooler with Postgres. Now, which one? If you look at the ecosystem, there's PGPool, there's PGBouncer, Odyssey, PGAgrol, which was a new addition. So which one do we pick? Which one is the best one? Or which one is the best one given my needs? And by the way, where do I place the connection pool? Should I place the connection pool just fronting Postgres next to it? Or as a middleware layer? Or on the client side? Or a combination of those three? Or in the 3 places, all of them? And which connection pool in which location of this architecture? It's not easy, right? So there's a lot of questions to provide there, and also to fine-tune and configure the connection pooler itself. So this is what I was referring to, this ecosystem problem. There's a lot of variety, there's tools to choose, there's tools to configure, to fine-tune, and then to make them all operate together. And this is definitely not an easy problem. But then we'll talk about high availability, right? The same problem appears. There's several tools to pick from. There is a PGPool, Rep Manager, Patroni, PG Autofailover, PAF, Stolen, and even other considerations for high availability, right? Which one to pick? Which one is the best? Some of these tools may cause some problems actually in your cluster. Pick wisely, right? The same applies with backups. Which tools should I use? There are several you can see on the slide, right? And where do I do backups, right? Do I do backups to cloud storage, to disk? And what about PG dumps? No, that's not backups. It's logical snapshots of data. that will not back up your database for production environment, unless it's also on top of any of these tools that do continuous archiving. So you also need a tool for backing up Postgres, and there are several alternatives. Again, there's a problem to choose where should they go. There's an aspect that is often overlooked into enterprise Postgres deployment stacks, which is the logs. Normally the logs just happen to go on the file system and that's it, right? But what happens if you need to troubleshoot an issue that happened on one server, but also that was running on another server, it was replicated, and you need to start, or you don't even know on which server it was. So then you go to SSH to each server, cd to the logs directory, do a grab there or awk or whatever you're going to use to find the specific log that you're looking for, and then you realize that was not the server, so you SSH to the other one, rinse and repeat. It's very complicated, and that's why we believe that an enterprise-grade Postgres stack should have the logs all sent to a centralized location where I can parse or query all those logs together at the same time. I don't need to go to each and one of these servers, which would also require their own storage for the logs and rotation policies, and actually complicated systems to store all the logs. There are some tools that are not specialized for Postgres that you may use, like the ELK stack, which will bring a whole lot of new dependencies. It's a quite complicated stack technologically from a technology perspective. But there's no significantly specific technology for Postgres except the one I'm going to present today. There's also the entry point problem. Whenever you have a Postgres cluster, you may have a primary node and replicas. But if this primary node dies, the high availability software is going to promote one of the other replicas. But how do the applications know where the primary is all the time? How we avoid changing the applications? This is called the entry point problem. And you can solve it in several ways, including DNS, virtual IPs, or all the mechanisms. But basically, you need to have from the application a standardized and stable entry point to the application. Now, one thing that we can do, and it's not very usual, but it's starting to get more popular, is to use a proxy to serve as the entry point to Postgres. In particular, I'll show you and explain you later why we're using Envoy proxy with a filter that we have developed for Postgres to enhance the experience of using Postgres through this proxy and what benefits it will include. I'll show you. I'll talk about this later. What I'm going to say about monitoring Postgres for enterprise-grade workloads is absolutely critical. Here we have so many tools. I'm not even going to mention them. Prometheus may be one of the most used right now, but it's by far the only one. And we need to understand which tool to use, how to configure, how to monitor, and even how to not overwhelm Postgres with too many queries just from the monitoring perspective, which can happen. So it's also, again, another component of this stack that we need to consider. And last but not least, and it's the user interface or a web user interface. There's not a lot of tools for managing Postgres clusters. There's tools for accessing Postgres and running DDL commands, doing queries, but not for managing clusters. And I am a command line person, don't get me wrong, but there is a lot of people, a lot of users who are more comfortable with user interfaces. And it's great to have some kind of web interface to manage all your Postgres clusters. So this is what I call the stack problem. We need all these components which are external to Postgres. They don't come with Postgres, the official distribution, right? To run a Postgres enterprise workload. And then where are we going to run this? So we can deploy the stack into many environments, like cloud environments, like on-prem, right? So how do we actually take all these components, program all these components together, make them work together well, and ideally automate all these to work on any environment? Sounds like a quite complicated problem. Practically the answer to this, the only answer as of today to this, practically speaking, is Kubernetes. Kubernetes offers us a programmable API against which we can program the deployment of all these components and make them all together. And that is basically what I'm going to be talking about today. We've built a software called Stackres, which, as you can imagine, includes a stack. This is a stack of components on top of Postgres, hence the name Stackres, a set of stack components on top of Postgres. And it enables to run Postgres with all these components that I've mentioned before on Kubernetes, on a cloud native platform, right? And in doing so, and thanks to this programmability of the Kubernetes stack, we've been able to introduce several innovations that that enable to do things in Postgres in a significantly different way. So let me go with these innovations. But you may say, you know, we want Postgres to be boring. There's this great tweet by Kelsey Hightower, very well known in the community, that says Postgres is what happens when tech gets so good for so long that it becomes boring, right? And databases are technology that we want it to be very stable. We don't want to risk anything. That's why we call them boring, right? Because we just want them to work. Now, how does Postgres being a boring, which is a good thing, right, technology, couples with innovation? Well, I claim here that being boring and innovating are not at odds. They're not the opposite of each other. And the main idea here is that for sure there's place for innovation in Postgres, but in particular, the kind of innovation we're talking here is not on the Postgres core itself. Postgres core itself is untouched, but rather innovation on top of it, around it, on the stack of components that I mentioned around Postgres, and basically being able to separate, take out some parts of Postgres that may be better handled, but other specialized components, as you shall see, and then leverage those to make Postgres expose as a reduced footprint, first place, and then to be able to operate with this whole ecosystem. But the core is the old Postgres that we all know, that is boring and works so well. So where are these innovation opportunities? So there's three areas which, if you really look through the history of Postgres, this 20 or 30 years history, depending on where you want to start counting, they haven't changed much. How do you deploy Postgres? Pretty much the same as, I don't know, 2 decades ago. Well, there's Ansible, Chef, Terraform somehow applies here. Other than managed services, the way you deploy Postgres right now is still pretty much the same as you were doing it, again, long time ago. The same goes with automation.
То же самое можно сказать про автоматизацию. Есть скриптинг, специальные инструменты, которые позволяют оптимизировать. Они тоже играют свою роль. Но помимо этого можно использовать и эквиваленты для того, чтобы выполнять те же самые задачи.
Is there a way where we can just say some parts of Postgres functionally, we may just delegate them to some specialized component that already exists that may do some of these tasks even better than Postgres? They are not core to the Postgres experience. Sounds mystical, but I'll explain you with examples, real work this. So how do we do this on the Kubernetes environment? Well, deployment and automation, both parts, can be done by leveraging the Kubernetes APIs and the operators pattern. Deployment is trivially explained by this, especially in the presence of an operator. An operator will expose a high-level interface, typically a CRD or several CRDs. We're going to see on the demo session a lot of this. And you'll be able to deploy a complex Postgres stack with just a few lines of YAML code or JSON, whatever. And in this way, deployment, the way Postgres is deployed, has significantly improved experience by the use of Kubernetes operators. The same goes with automation. Instead of creating shell scripts which are prone to failure and goes as far as they go in automating some parts that are more complicated, especially in the context of how do you automate tasks across different servers. So in other words, on a distributed environment, this is something that somehow can be handled by Kubernetes APIs. Also, with the help of the operators, we can coordinate tasks and dependencies across nodes on a distributed cluster with significant ease of use. It's not trivial, but it's definitely doable. Whereas with shell scripts or other automation tasks, it's quite hard to do. And finally, how do we innovate in terms of offloading functionality? Well, by looking into the Kubernetes ecosystem. The Kubernetes ecosystem has exploded and is exploding right now, and there's a lot of various specialized tools that we can use to leverage and to try to offload some parts of the Postgres functionality. So let's look into the core of this talk today, which is how to deconstruct Postgres, how to take this monolith that we know that is Postgres and see if we can shake it a little bit and maybe rip off some small pieces that we can offload to some functionality external to Postgres itself. So what is the agenda? Which topics are we going to cover here? I'll just go directly with them. There's 6 key areas that I'm going to be talking here today. Let's look at the first one, Envoy, which, by the way, there's going to be another talk tomorrow, starting at the same time as this one on this conference about this topic. So if you're going to dive deeper into this topic, I invite you to come to my talk with Fabrizio, my colleague Fabrizio. We'll be talking about this in more detail. That I mentioned that one of the problems that we face on a Postgres stack is the entry point. And we can solve this problem by using a proxy. We were looking at this problem in detail, and we found that one of the proxies most used in the Kubernetes and cloud native ecosystem, but obviously not restricted to it, is Envoy. Envoy is a great proxy developed from scratch several years ago, very high performance, very wide ecosystem, very well tested and running in so many production environments. And Envoy is quite interesting because it has a plugin architecture similarly to Postgres extensions, by the way, or to plugins in browser that allows you to support different protocols and different capabilities of Envoy. So we pulled together in Congress and some other teams with the Envoy community to develop a specialized filter. They're called filters for Envoy that will understand the Postgres protocol. So Envoy can proxy TCP traffic. Most people know it because it proxies HTTP traffic and does miracles with it. But it also proxies TCP. So Envoy as is can work perfectly to just proxy Postgres traffic, but it does nothing with it. Thanks to this filter that we implemented in Envoy, it is obviously all open source, then Envoy is able to decode the Postgres protocol. By doing so, Envoy is able to extract metrics from the Postgres wire protocol, and because Envoy is already capable of sending these metrics to metrics collectors such as Prometheus, then we can push metrics to Prometheus of the Postgres protocol. What does it mean? This means that, for example, just by fronting Envoy with the Postgres filter in front of a Postgres database, the traffic will flow through it, and it will capture metrics on the fly. So we can expose to Prometheus metrics like such as inserts per second, updates per second, deletes per second, connections per second, transactions per second, rollbacks per second, errors per second. There's like 30-40 metrics already exposed right now that you can have them graphed nicely on a Grafana dashboard if that's connected to Prometheus. And these all, if you think about it, comes absolutely for free. Postgres is not even aware of this. You don't need to install any extension into Postgres, which may cause Postgres to be restarted. You don't need to configure anything. You don't need to do queries to Postgres just to gather these metrics. Just by proxying Postgres with Envoy with this Postgres filter, it will capture all these metrics, send them to Prometheus, and then proxy the traffic to Postgres, which will not be aware of this metrics collection whatsoever. So this is quite interesting because it already increases Postgres observability basically for free, with no interaction, no harm on Postgres in terms of performance or extensions or restarts or anything. But we've gone even further, and for Envoy 1.18, which should be out by March 31st at the end of this month or early April, there's going to be, it's already committed, support for offloading SSL. This is a major milestone for this Envoy proxy filter because it will allow to turn off SSL in Postgres. By having Envoy with this filter fronting Postgres, you'll be able to decode SSL at the Envoy layer, and then if you're connected via Unix domain sockets or in Kubernetes container, again, also by connecting by Unix domain sockets, but operating on the same sealed space, then you can connect from Envoy to Postgres without SSL. This means that not only you're relieving Postgres from all the effort of doing SSL, computational effort, but also you're relieving Postgres from doing all the certificate management. Enabling SSL or rotating SSL certificate in Postgres means restarting the database. And restarting the database may not matter much on your laptop, but on a production environment, it means downtime. By the time the database restarts, you need to stop the connections, and there's an effective downtime, maybe seconds, maybe a few minutes, but it's downtime. This might be a significant problem for many production environments. But by offloading SSL to Envoy, Envoy has the capability to change in all configuration, including SSL, dynamically via a set of APIs. So not only we're relieving Postgres from the effort of having to decode SSL and manage SSL, but we're also relieving it from the role of having to manage certificates. So this is, for me, one of the best examples of how we can deconstruct Postgres and offload functionality to components of the cloud-native ecosystem. We just take Envoy proxy, which is a very, very good proxy, very high performance. We develop a specific filter for it for understanding Postgres, and then we decouple SSL from Postgres and let Envoy do it. If you're interested, there is a presentation on, there's a blog post that we have had as a guest blog post on the CNCF, the Cloud Native Computing Foundation, talking about this blog post. I recommend you to check it out. And there's even more functionality that is going to come into the future. So stay tuned, because there is a lot of functionality coming to this Envoy filter that that will enhance the Postgres experience. And as I said before, if you want to know more, join us on our talk, Fabrizio and I's talk tomorrow, starting at the same time as this talk. Now, how it works from an architectural perspective, just to make this a little bit more tangible. Normally, let's say that we're operating Kubernetes, so we have Postgres as a container running inside of a pod, and we have a user that connects to Postgres via the Postgres wire protocol, right? Pretty simple stuff. Now, if we would just use the TCP filter that came with Envoy since a long time ago, in other words, that is able to proxy TCP traffic, this Envoy proxy can be another container running as part of the same pod that is called Kubernetes sidecar, right? And so we have a sidecar Envoy proxy next to Postgres container, and the traffic now is intercepted by the Envoy proxy and goes to the TCP filter. And then it speaks a wire protocol. It's just basically it's a pass through. Just lets the Postgres the protocol, the wire protocol, go through it, and exports a few metrics to Prometheus, but are basically bytes per second in, bytes per second out, connections in, connections out, which is already helpful. Could actually let us troubleshoot some, for example, queries returning a lot of data. Sometimes that's useful. But let's look at this picture, how it looks like when we add this Postgres filter that we developed. By having this Postgres filter, as I mentioned before, understands and decodes the Postgres wire protocol and is able to export to Prometheus additional metrics. But these metrics are now very rich. There are what I mentioned before about inserts, updates, deletes, connections, transactions, errors, and a few other commands that are all decoded as counters. In other words, they can be graphed or varying over time. And they're all exported to Prometheus. So we have a lot of rich metrics. And when we add this SSL functionality, there's yet another filter, which is based on the start TLS extension, that takes as input the key and the certificate, and then is able to decode the SSL protocol. So the user is connecting via SSL, but this SSL stops at the Envoy layer. And to Postgres, it only goes normal unencrypted, basically, Postgres wire protocol. So we're able, just by using Envoy with these filters, to not only enhance Postgres observability significantly, but also to offload SSL functionality and certificate management without Postgres even knowing about it. So this is why I mentioned this is a great example of how to decouple this functionality, to deconstruct Postgres and to rip off a small part of it, which is in this case is SSL management and monitoring, part of monitoring. It doesn't cover all the monitoring that you require for Postgres. It's definitely part of it, enhances the observability and offloads to a separate component. Just as a graphical representation, this is what it looks like on Stagres. We use Envoy in Stagres, and there's a web interface. This contains the specialized dashboards, and this is showing metrics, for example, in this case, from exported by Envoy, right, including loggings per second or sessions encrypted or non-encrypted. Let's talk about logs now, that I also mentioned before. That was a key component of Postgres stack, that we cannot go to every container, every server, SSH, CD, grep, whatever, just to try to understand what happened. Logs, in our opinion, should be going to a distributed component outside of the database with its own storage, collect it all together so that whatever operation I want to do with these logs, grep, query them, run a PG badger, whatever it is the case, that they're all together in the same place, from all the instances or all the pods in Kubernetes terminology coming to a single central location, right? Especially also to avoid problems with partitions filling up or log writing overwhelming the database. That can also happen. So what if we just think about a system which has few dependencies? Because as I mentioned before, one option is to run on ELK stack, but that's a very heavyweight, let's say, stack with a lot of components and dependencies. Can we just imagine, devise a system where we'll send all these logs to a central system where it has not only less dependencies, but that is well known to us? We're Postgres people, right? We love SQL, right? I hope so. I definitely do. So why don't we send Postgres logs to a database? Okay, which database to pick? Should be obvious, right? Postgres. So why don't we send the logs to a separate Postgres database? Well, you may say separate database, may not be performant enough. But I'll show you later how we use timescale extension for time series data and inject the logs into a database that is Postgres with timescale, which supports high velocity and high volume of logs. So how will this look like from an architectural perspective, which is what I'm interested in showing you today. Let's look at a pod. Again, we're Kubernetes land, and there's a container which is running Postgres. And let's say we configure Postgres to produce CSV logs, which is one of the configuration options for Postgres. Now, the logs are produced inside a container by default. And container storage is ephemeral, which means, if the container dies, the logs are lost, and it may also fill up at some point, right, depending on the system. So what we do with these logs? What we can do is connect a sidecar, again, another container that runs within the same pod, that is based on FluentBit. FluentBit is another cloud-native CNCF ecosystem tool that is specialized on this task, on log collection. Again, look at the pattern I'm trying to bring today. By leveraging tools that already exist on the cloud-native ecosystem, we're going to try to offload functionality off of Postgres or improve, enhance the functionality that already exists in terms of monitoring or log capture or equivalent. So FluentBit is a very lightweight agent. It's written in C, and it's able to collect the logs, apply some log enrichment. It adds, for example, information about the pod and the system where it's running, Kubernetes environment, and then it's able to send them somewhere else. So in this case, the ephemeral storage within the container is just used as a buffer for before the logs are collected by FluentBit and push them out. As soon as these logs are pushed out of FluentBit and received like a collector, as we're going to see right now, they can be removed from the ephemeral storage as part of the Postgres container, and they can be rotated. So basically, we're just buffering and then sending to FluentBit, which is collecting the logs, running inside of a container, which is a sidecar to Postgres, and then they're going out. Where they're going, there's another component coming from the cloud-native ecosystem called FluentD, which is a logs collector, basically. It is a tool specialized on receiving flows of logs from potentially many locations. So in other words, it can be multi-tenant and supports collecting the logs from many distinct locations, many distinct components, and is able to collect them. And where does FluentD stores these logs? It's not defined. FluentD does not store logs, it just collect them and then forwards them somewhere else. In this case, this else is what I mentioned before, a Postgres database with a timescale extension for time series data, And so we use a plugin for Fluentd, which is able to store the logs into Postgres. There's some transformation behind the scenes because the inner details are basically that the Postgres logs may contain, even though in CSV format, they contain multi-line records, and multi-line records are not handled perfectly by Fluentd. So we use some transformations before inserting them into Postgres to just avoid a Fluentd management problem with line breaks. But in a sense, the logs flow from the Postgres ephemeral container to Fluentd. Fluentd forwards to a central multi-tenant, potentially multi-tenant Fluentd instance, which stores them on Postgres and timescale. So now, how do we query these logs? Because they're coming from all pods on the system, right? All servers. They're coming to this central location. Well, one option, this is a Postgres database. You just connect to the Postgres database and do SQL commands, which was what we wanted at the beginning, right? Just be able to query with SQL these logs. The second option is that we have developed a third component, which is a controller. And this is basically a REST API, which exposes an interface to query the logs. So now you can query these logs via SQL by connecting directly to the database. You can query the logs by issuing commands to this REST API via normal API clients, or because Postgres, as we shall see later, comes with a web interface. The web interface has an option to show these logs and calls this API. So you can basically see the logs on a web console. This is more or less how it looks like to check the logs on the web console for your information, but we'll see them on a live demo later on. In summary, the features that comes with this functionality are that we are collecting currently the Postgres and Patroni logs. Patroni is a software for high availability, also used in Postgres. And this is work in progress. We are adding more logs functionality. Next item, we're going to also try to collect PG Bouncer, because Postgres also uses connection pooling via PG Bouncer, and to also collect PG Bouncer logs and send them through the same interface to be able to query them all together. This architecture basically creates what we call a distributed log server, and this distributed log server is multi-tenant. Not only it supports collecting the logs from all the pods of the same cluster, but also supports multi-cluster. So if you want to collect the logs from multiple clusters, all the pods of multiple clusters, you can do with a single instance, or you can create multiple instances. That's your choice, right? So, but they're multi-tenant by default. And as I mentioned before, you can query them with SQL or via the web console. Some questions sometimes arise about the use of timescale. First of all, we use the open source version, the Apache 2 licensed version. And we also use timescale for log retention management. So Postgres, when it collects its logs, also will retain the logs for the amount of time that you can specify on an optional retention policy. And then because it uses timescale, it uses partitioning and basically deleting all logs that are no longer held by the retention policy is as trivial as dropping partitions. So it's quite convenient. This is all automated for you. You don't need to worry except specifying what retention policy do you want, and it will be managed automatically by you. This is another example of innovation in Postgres. As you can see, it doesn't affect Postgres core itself, the Postgres operation, how you connect with Postgres or run queries. It just separate another component, which is usually quite important for production usages, for troubleshooting especially, but at the same time, an area which before there hasn't been much innovation before. And we have created this system to send the logs to a distributed log server, which is a Postgres database, which does handle automatically rotation and which exposes both a web interface and a SQL interface for you to query the logs. Let's look also a little bit about architecture in general of how we structure components on Kubernetes. So you basically know that in Kubernetes, the basic unit of deployment is a pod. A pod is just a term that implies kind of an abstraction, the kind of abstractions that containers offer as a dedicated potentially storage space, process space, and IP networking space. And a pod may contain one or more containers. This normally there's like a main container. In our case, is Postgres. And there can be other containers which hold additional functionality. These are called typically sidecars because they implement this side functionality, right? Now, if you think about what is a container is just a process hierarchy, which this means is that there is a hierarchy of components that that start on a root process, and this process may fork and have children, right? But it's a single rooted hierarchy. If you look at a VM, there might be multiple processes, multiple roots. There's an init system, which is the parent root, right? But hanging from this init system, there might be multiple processes. But a container, in reality, is just a wrapper of a process and its children. So it's not a good practice to have multiple processes running inside a container unless they are typically inherited from a single parent. So containers should be basically initless from the perspective that should not have an init system to spawn multiple processes. They should have specialized processes running from a single hierarchy, and then instead of bundling everything together into a single huge fat container, split it into separate functionality and have these separate components as sidecars. So knowing it, how did we structure this in Postgres? So basically, here you see the whole pod. And inside the whole pod, there's going to be the main container, which in this case contains both Patroni and Postgres. And someone may say already, oh, but you're having two things there in the same container. That's breaking your principles. In reality, it's not, because Patroni is actually a parent process for Postgres. The way Patroni works is by basically starting and managing the Postgres binary. So it creates a single hierarchy. There's no init system to run both Postgres and Patroni. Patroni is the parent of Postgres. So it's still a single process hierarchy what we have on this container. And this container connects, has a handle of a persistent volume of a PV. It's called a PVC, persistent volume claim. All right, so this is the main container. Now, as I mentioned, in Postgres, we have connection pooling that sits in front of the database. This is an optional component. You may turn it off if you want to. We'll see later. But it is very good to separate a separate container, because within a pod, they can connect via Unix domain sockets, as you can see on this picture. But at the same time, we are, by using this connection pooler here, we're able to limit the number of incoming connections going to Postgres, or we can set the max connections as a lower value, which in turn makes Postgres operate on a more efficient regime. It's more optimized configuration and so forth. I'm not entering into that discussion, but basically we can have PG Bouncer as a separate container, as a sidecar to Postgres, and within the pod they can connect via Unix domain sockets. Now, we also have Envoy, as I mentioned before, that we use for SSL uploading, for NAS monitoring, and for future uses in the future. So Envoy is going to be yet another sidecar. Envoy connects to via PG Bouncer for handling the connections, also via Unix domain sockets, as well as directly to Postgres for the replication traffic. This is because PG Bouncer doesn't handle replication traffic. So when we have Envoy and PG Bouncer, the normal data plane, the normal connection goes through Envoy and then through PG Bouncer before going to Postgres, whereas replication traffic goes directly from Envoy to Postgres. In both cases, all connections happen via Unix domain sockets for maximum performance. And this is a very, I would say, well-architected way of connecting to Postgres, which exposes the SSL offloading, the enhanced observability, and connection pooling, and all this transparent to Postgres. Just connect from the outside of the pod to the port, and then it's packed to you, it's transparent. You don't even need to know that all those components are there, but they offer all these benefits. And as you can see, Envoy is yet another sidecar. This sidecar on one side exposes these metrics to Prometheus, and on the other side, it exposes a couple of ports, one for Postgres connections, one for replication connections. But if we're looking at the anatomy of the pod that we have in Postgres, there's some more sidecars in this case, right? One of them is Postgres util. Postgres util if you really think about it, what I was saying before, a container is just a hierarchy of the processes and the process of its and its children that perform a task. In the case of Postgres, Postgres spawns many other processes, but they all start from the same root. But what about administration tools like PSQL, right? Where are those tools located? Within the same container as Postgres? Well, definitely that's something we can do, but in my opinion, not necessarily. The goal of containers is to basically pack the minimum number of assets that are required to run that process. PSQL is not required to run Postgres. I may not even need PSQL ever within the container. So this is a separate container that right now is started by default. In the future, it's going to be set up as an ephemeral container, which means a container that you will only create on demand whenever you need it. But for the time being, it has to be, for compatibility reasons, always turned on. But because we want to enforce very strictly this separation of concerns, tools for administering Postgres go to a separate container. Anyway, the separate container may connect via Unix domain sockets to the main Postgres patron instance, so there's no performance degradation by doing this. Now, we also want to export metrics to Prometheus that are not exported by the Envoy filter, because some metrics really need to query Postgres. So at least as of today, we'll look into the future because we also have some ideas here. But for now, if you want to query the Postgres catalog, you still need to query Postgres, right? And that gives you a very rich metrics that in our case we want to expose to and export to Prometheus. So we have another sidecar container running here, which is the exporter that runs a well-known Postgres exporter component that connects to Postgres. We also connect to PG Bouncer to also expose metrics from PG Bouncer, and from all the databases that we have in the Postgres database, they're all exported to Prometheus via this exporter. But remember, there's distributed logs, and I also mentioned this FluentBit component that was, I already mentioned there was a sidecar running within the same pod. So here we have also FluentBit sending the logs to FluentD. And also, there's, whenever we take a backup, and Postgres handles backups automatically for you, there's agents. And agents are jobs that are created within the pod because they also need to connect directly to the Postgres container to run the commands to basically take the backups, right? To run PG-based backup and access the file system. So this is at the end of the day, the anatomy of the pod may look a little bit complex, but in reality, all this is transparent for you. There's nothing that you need to do. This is all done automatically, and it just enforces this principle of separation of concerns. Different tasks are handled by different containers which have their own minimal footprint, and they're prepared to work together. In the future, it's not implemented right now. There's going to be yet another component called the local pod controller. This is going to be a small container that may end up basically even substituting the functionality of some other sidecars here, which is kind of a operator. You know, in the operator pattern in Kubernetes, there's CRDs and there's controllers, and we're going to have a local controller for the pod, which is basically a software that is going to be handling reconciliation loop connection with Kubernetes, but needs to perform local operations on the cluster. There's some binaries that we need to call to perform central operations that inside of the pod, and it's better to have some controller that is local to the environment, whereas having to running execute commands on the pod. So this is an optimization for the future. Will also bring significant benefits, but it's not present right now. But when this is going to be the case, there's going to be this local pod controller here. All right, this is the architecture of the pod, right? Like what we have here is the whole view of the pod. And now, what does it look like, the whole architecture of a cluster? So let's zoom out a little bit right now, and we'll see that we may have several pods across the cluster. One is going to be the primary, the other ones are going to be replicas. They all have their own independent storage. Now, in Postgres, to solve the entry point problem, apart from having the Envoy proxy, we expose services, Kubernetes services, which typically are associated with a DNS entry. And there's two services that are exposed by default. One called name of the cluster -primary, which exposes a read-write connection that always points stable to the master. and one called replicas, that is a load balance service that connects to all the other replicas. You can see in the diagram here. Then there is the StackRes operated services. We may have the distributed log server to collect the logs, as I mentioned before, which contains the API, the distributed log server itself, with a Fluentd component and the Postgres plus timescale database. This is used to collect the logs remotely. Then there is the StackRes controller itself, the StackRes software itself, which contains two components on itself. The controller, which speaks, is basically listening on the Kubernetes API, reacting to changes, and is basically running what it's called the reconciliation loop, reconciliation cycle, and a REST API. This REST API does two things. One exposes an API, so you can also manage everything in StackRes with an API if you want, but also is able to power a web UI, a web console that StackRes comes with, that I'll show you later during the demo. So this is more or less the whole picture of what all the components look in the StackRes architecture. Now, let's go a little bit faster here. This is more or less well known, the integration with Prometheus and Grafana. We have also done this in order to try to streamline and also externalize monitoring from Postgres to more cloud-native components. Now, integrating Prometheus and Grafana is pretty much easy, right? This is trivial. So what we have done beyond this? So we have the Postgres exporter, but we have also implemented a PG bouncer exporter, which actually uses a quite neat trick of using the Postgres extension DibbleLink to connect remotely via PG bouncer. So to connect to Postgres and Postgres to PG bouncer to gather the metrics, and to connect to all the databases present there to gather all the metrics from both Postgres and PG bouncer and all the databases within. But we didn't want to stop there, and so we're providing customized Grafana dashboards, which are heavily optimized for Postgres operations. So it's just not the dashboards that may come from the fold. It's dashboards created by our team of experts, Postgres DBAs, which have decided which dashboards do we want to see when we administer specifically a Postgres cluster. And the same with the alert managers, alerts. So if you know the Prometheus and Grafana, they also have a component called our alert manager, which can trigger alarms when certain thresholds or events happen. And we also provided a lot of customized alert managers. You can customize your own, but if you like the ones that we bundle by default, you just need to connect to your alert technology, like PagerDuty or Obsgenie or whatever you use, or Slack, and you'll get paged when any of these alarms are thrown. And last but not least, and I'll show you these, we have integrated these Grafana dashboards into our own web interface. So within the web interface, you can connect to the dashboards. This is how it looks like, but we're going to see as part of the demo, so I'll just move forward. And the last part that I wanted to mention in this presentation session is, sorry, not the last one, but the second last one, is a mechanism that we have also used on this web interface to provide authentication and authorization. And it's basically, instead of reinventing yet another system for authentication or having another set of users and passwords for the web UI, we're going to rely them, as the topic of this talk is all about, offload these to a component that already runs on the CNCF ecosystem. In this case, we're going to rely on Kubernetes authentication and authorization mechanism called RBAC. It's more of authorization than authentication, but we can leverage it for both, for the web console. So how it works? Basically, we have a user, and this user, let's say, authenticates on the web console. We're going to see how the web console works later. It says user HT, password, whatever, and this goes to the web console. The web console is going to submit an authenticate request to our REST API, which is the StackRes operator itself. This REST API is going to look for a secret that should exist on Kubernetes that looks more or less like here, right? It's a secret. This is a standard Kubernetes secret, and this secret has to have a key called password and StackRes username and potentially Kubernetes username, which might be different. When queried this secret, the password will be validated, and if it's validated, then the REST API is going to generate a JWT, a JOT token, which will include the Kubernetes username, and this will be returned to the web console. So basically, we're using here JWT authentication, JWT tokens, but the passwords, they're going to validate it against secrets, which are standard Kubernetes objects. Now, we're not leveraging Kubernetes RBAC yet, but stay tuned. Let's now fire a command from the web console. So now let's say we want to perform any operation. This operation, we call again our REST API from the web console, and this is going to include the JWT token. The JWT token is going to be decoded by the REST API, and it's going to extract this field called a Kubernetes username. Now, this Kubernetes username is going to be used to call the Kubernetes API using a field called impersonate. This is a header. You pass it. It says impersonate user this username. In other words, the REST API, which has by default more broad permissions to call Kubernetes API, is going to say basically sue to this user by calling the API. And Kubernetes is going to perform that action, based on the real authorization capabilities of that user. So if that user is allowed to perform that operation, that will succeed. Otherwise, it will not. And then the operation will be performed. So this is how we're leveraging Kubernetes RBAC without having to invent our own users and passwords and authorization mechanisms. We're just using this impersonation header extracted from the JWT token that we generate to call Kubernetes API on behalf of a given user, which typically will have reduced privileges compared to just running, operations with broad privileges. And the last innovation I wanted to discuss here today is what we call the cloud nativization of Postgres DBA operations. So one opportunity that Kubernetes brings us is the automation of what is typically called day two operations. Day two operations are these operations that you need to perform once something's already deployed, installed, running, and you want to start doing maintenance tasks. For example, in Postgres, running vacuums or PG repacks for removing bloat from indexes and tables are great examples of day two operations, right? And Kubernetes brings us the opportunity to automate these operations. The way we have chosen to automate these operations is by leveraging what in Kubernetes are called the CRDs, custom resource definitions, which are very high-level objects that you create on Kubernetes representing a concept. And we have decided to make these concepts very high level, so to expose a top-level interfaces so that all the complexity is hidden behind them, and expose a very simple interface to users. These users, they don't need to be Postgres experts at all, just to understand why you want to run this operation, but not how to run this operation. And just by typing this YAML or JSON files that represent the CRDs, Kubernetes and the Postgres controller will perform this operation for you. So let's look at an example. We call this CRD SGDBOps, which means Postgres database operations. And it supports several operations. One of them, for example, could be make a manual backup. Backups can be automated in Postgres. We'll see later during the demo. But you can also have manual backups. And to create a manual backup, you just need to create a YAML file like the one you're seeing on the screen. This is fully functional. This is complete. You may add some extra parameters, but this will work. So it's very simple. You can see in basically the green color the fields that you need to type in, the name of the backup, the cluster you're referring to, and the operation which is backup, because we also support other operations within the CRD. The way this will work is that you'll basically run kubectl create or apply. This will call to the Kubernetes API. The Kubernetes API is going to persist this information on etcd because this is a CRD. Once this is persisted, this is going to call our operator, the Postgres operator, which is listening on events happening on this CRD. So it's going to call the Postgres operator. Postgres operator is going to realize, oh, someone is asking me to perform an operation on behalf of the user, which is a backup operation. So let's take a backup. And this will all happen behind the scenes without you having to do anything else. It will create a backup job, which will run inside of the pod. And in this case, we use WALG for backups. We'll run the WALG generate command. And then we'll capture, well, obviously the backup will go to cloud storage. And then we'll capture the output of this backup. This backup status is going to go back to Kubernetes API, and Kubernetes is going to, because of our instructions, is going to fill this information as the status part of the CRD. So you see now there's in yellow here in this YAML file has been completed with status part that says the operation is completed with one retry, because you can also program the operation to do several retries if it fails, and is completed. So basically, we have created here a very simple textual interface for users to run behind the scenes what could be potentially complex operations fully automated by just specifying a very simple minimal specification, the part in green, and the result of the operation, the status in general, the messages back will flow you as part of the same CRD in the status field. With this, we have right now implemented manual backups, Postgres benchmarks, repacking the database, vacuum operations, minor version upgrades, major version upgrades, and a few others that are coming down the road. And all these operations are absolutely fully automated. You just need to create this YAML file, or JSON if you prefer that as a format, do a kubectl apply, and watch and sit and relax and see how it works. That's all that you need to do. So this is what I wanted to bring today to this session as part of the presentation. If you liked what I've been talking about for now, feel free to join our Slack and/or Discord communities. This the Postgres software open source is Postgres.io. Their respective communities are slack.postgres.io, discord.postgres.io. Feel free to join us and ask any questions. What we're going to do now, we're going to have a Q&A session. Then we're going to have a small break to probably there were too many concepts here. So we'll take a 10 minutes break. And after that, we're going to do a full hands-on lab session. For this hands-on lab session, as I mentioned before, I'm going to run it, but feel free to have on your computer your own or access to a Kubernetes cluster. You may run the same commands I'm going to be running with you. At the same time, you'll be able to reproduce this on your own environment. Before jumping into the Q&A session, what I'm going to do is I'm going to create everything from scratch, so you can definitely reproduce this totally from scratch from your home or office or whatever you are. And so I'm going to go now and just fire a command to create a Kubernetes cluster that we're going to use for the demo later. So you also see I really start from scratch. There's nothing prepared. And obviously, this is going to be a demo. Demos sometimes fail. I hope this will not be the case. But if everything goes well, it should run. And I'm going to create everything from scratch. You can also do the same. In this case, I'm going to create a Kubernetes cluster on Amazon. So I'm going to use Amazon EKS for this. If you want to do the same, just have handy your Amazon credentials, and you'll be able to follow my commands. Other than that, you can use any Kubernetes cluster in principle to do this. So feel free to do that. So let me briefly turn off this presentation and look at the steps we're going to take. If you want to follow this tutorial, again, at home, at your office, just go to Postgres.io/doc, or let me actually just go directly. The main website is Postgres.io. Then go to documentation. It's very simple. And then tutorial. And this is the steps we're going to follow along the way. So for now, what I'm going to do is just create a, I hope the font size is okay. I'll make it big enough. What I'm going to do right now is just create a Kubernetes cluster. Creating a Kubernetes cluster on AKS takes around 20 minutes. So I'm just going to create it right now from scratch, again, because I want to demonstrate you that there's no tricks, no hidden, nothing here. And I'll take questions, and then we'll do the break, and then we'll do the demo. So to create this Kubernetes cluster on EKS, just going to need to run these commands. I'm just going to copy this, and I'm just going to paste here. And I just need to actually set up a profile here. So yeah, I'm going to use an AWS profile. I'm going to create a cluster in the East2 region. I'm going to call it Postgres. It's going to have 3 nodes, 100 gigabytes per node on 3 regions, version 1.17. Let's fire this command. As I said, this will take around 20 minutes. And I am doing this because I want to demonstrate that I'm creating everything from scratch that there's no tricks hidden here, anything prepared, that everything may fail, but that will be fun. Hope it will not, but in other words, it will be fun. And I'm ready to take some questions, if there's any, which I hope there will be some questions.
Okay, thank you, Alvaro, for your presentation. It was really a lot of information, and I think we will need some time to just understand it. And there is already a question in the chat, and it's a question about backup copy of stack trace, whether it's full or increment.
Yeah, so the backups are using continuous archiving. So from that perspective, it's what's called physical backup. So it takes a base backup from which you'll see later, because we'll do this on the demo, but you can select the frequency and the periodicity where you want these base backups to be taken. And then in between the base backups, all the wall archives are stored. So from this perspective, it's differential backup, because we're storing the wall archives, and you basically incurring almost zero data loss, or zero data loss if you want to restore from them, because as soon as the wall file is generated, it's also being pushed to the cloud storage. We use object storage for storing the backups. And you can also, if you want to do a PITR, point-in-time recovery, you can go back to any instant of time as long as you have at least a base backup older than that instant of time where you want to recover.
So you decided to go with base backup and not use any other tool for backups. It's like enough for your system.
No, actually we use internally WallG, and we use WallG to generate the base backups on the given schedule that we specify them to run, to push the wall files as soon as they're generated, the wall segments to be more precise, and to also manage the lifecycle of the backup. So basically, we'll see later, but I can quickly go there if you want to see. But if we go to the backup configuration, we'll see that you specify as part of the backup configuration, we'll do that a demo here later, but a cron schedule, which is when you take the base backups, how many of them do you want to retain, and everything else will be fully automated. There's nothing you can do. According to this configuration, which is only for this tutorial, but obviously, a backup will be taking every 5 minutes, base backup, and 6 of them will be kept. So basically, you'll be able to keep 30 minutes of backups. Obviously, this is only for demo purposes. But other than that, you'll have basically 6 base backups always taken, or less. And whenever a new one is created, the other one will be deleted automatically. And then in the meantime, all wall files are being backed up automatically.
Great, thank you for this answer. And also there was a question, maybe even a little discussion in the chat. Which persistent volume do you recommend to use under Kubernetes with Postgres?
Well, that's a broad topic. It really depends on the environment in which you are running. We are quite agnostic because we want you to run Stackers on any environment that you want to run it. But obviously, typically, you're going to be running on a. So we need to distinguish on-prem and cloud environment. So if you're going to run on a cloud environment, I typically recommend that you use network disks. If you're on Amazon, it will be EBS. If you're on Google, it's going to be persistent disks and so forth, because they're highly reliable. They may not be the best performance at times, but they're highly reliable. And Stackers just basically ask you to provide a storage class. So any way you want, you can do it. You can create a storage class and just specify that storage class when running the cluster. We'll see how to do this later, and it will just use that storage class. On-prem is a different story. And on-prem, but also applicable to cloud environments, you can use technologies like OpenEBS, for example, to create your own distributed volumes, which again will be exposed as a storage class. It's very broad topic. There's many options, but we are quite agnostic. The only thing that we require is storage class. However you create that is really up to you.
Okay, thank you. And next question, are you planning to use 8 containers in one pod?
Yes. At some point, we will also reduce that number. As soon as we introduce the local pod controller, that local pod controller is going to eventually grow in functionality and start absorbing functionality of some of the other containers. For example, the Prometheus exporter, it's going to be absorbed eventually by the local pod controller, and so at some point we'll have 8, then we'll have 7, and we also want to coalesce some other functionality into other containers into the future. Like, for example, we'll try to also implement connection pooling in Envoy proxy, so maybe able to remove the connection pooler.
Cool, thank you. And speaking of Envoy, I would love to ask, are there any security issues with such proxy?
I'm not aware of. From an architectural perspective, there should be no difference by using Envoy as a security proxy, as a proxy, than not using it. There will be if, for example, you would use Envoy to offload SSL and then have an encrypted connection from Envoy to Postgres that goes across a wire. In this case, yes, you're just transmitting data unencrypted over the wire. In the case of Postgres, Envoy is a sidecar to Postgres, so they run within the same pod, so that connection cannot be tapped. And that's why we use Unix domain sockets and unencrypted connections. If you run it a different way, that might be one of the potential problems that I can think of. There's also, right now, there is no HBA, host-based authentication in Envoy, which, by the way, is being discussed these days. So we also want to offload HBA authentication to Envoy and actually be able to stop, for example, kind of denial of service attacks at Envoy before reaching Postgres. But right now, Envoy will just let pass every connection. It will have to be, as of today again, Postgres that stops connections that are not authorized to connect to the database.
Thank you. And next question, how do you guarantee that killer not occurs on Postgres container?
Sorry, I didn't understand. What may occur?
Killer.
Oh, yeah. Well, that's a hard one, right? This may occur with or without pods. So the quick answer is that if it happens, the nature of Kubernetes and the Postgres operator will just trigger, first of all, that the container will die. This means that some other replicas will be elected as a primary node. The services will be readjusted, and there will be small downtime on the database, but you'll have a new primary node, and this node will recover eventually. This will all happen automatically and transparently for you, but obviously it's not ideal. So there's many reasons why an OOM may occur on Postgres. We are taking some measures like configuring SAHM size appropriately on containers, which is not appropriate by default for Postgres, which uses a lot of shared memory, and a few others. But in reality, it really depends on how you configure Postgres. If you configure Postgres to use more memory than available, OOM will kick, right? But that's not different from what may happen on a physical node. We have some, actually, Postgres, you may go to our issues. They're all open. They're on GitLab. We have an open issue to consider using Facebook OOMD, user space OOM killer, to ease these problems before they may happen. It's not very developed yet. But again, as of now, the situation is slightly better, I would say, than on physical virtual nodes not handled than on Kubernetes.
Okay, I see. Thank you. And the last question in the chat so far is Postgres a Kubernetes operator?
Yes. We typically say it's more than that because an operator is typically just concerned by deploying something, and what Postgres is a stack of components around Postgres and a lot of automation and a lot of validation. And we just call it a platform for running Postgres on Kubernetes. But if you want to be like very, very strict and correct, it is definitely an operator.
Mm-hmm. I see. So there are some more questions. Do you think we need to stop them at some moment because you want to leave more time for your masterclass, or we can continue?
Yeah, I would say let's do a small 10 minutes pause here to also be able to make a demo. I would love to make a demo, and we can take questions along the way or at the end of the demo, or obviously there's this virtual room after the session where I'll be happy to take further questions.
Mm-hmm. Okay, so thank you so far, and yeah, I think the question in the chat, which is the last one for this Q&A session, is how do you tune Postgres configuration in Postgres containers? Is it automatic tuner or something else?
I'm going to show this as part of the demo, how you to ship your own tuned Postgres configuration. We are providing a very well-tuned configuration by default, which is much more tuned than Postgres default configuration, which is not very well tuned, let's say that way. We're tuning around 30-40 parameters, and you can see how and which ones. But other than that, we're not doing any auto-tuning for now. It's a quite broad topic. There's even a specific company just doing this, but may come in the future. Definitely there's ways for doing this because there's a lot of automation built into Kubernetes that may allow us to do this. But it's just right now the functionality is that we're providing 30 to 40 approximately already tuned parameters for you for their general case. And you may, on top of that, ship your own tuned configuration, which is strongly validated before applying it to the container, and just create a YAML file with the configuration and it will apply it for you automatically. Stackers will apply it for you automatically.
Great, thank you. And speaking of configuration, I want to thank you personally for PostgreSQL core.nf, which is just great.
Thank you.
Yeah, thank you. So now we have a little break for 10 minutes. Yeah, right?
Yeah.
And then we'll start the masterclass.
Okay, excellent. Thank you. See you then in 10 minutes.
Yeah, thank you.
In the early days of Intel, Robert Noyce once said, "Don't be encumbered by history. Go off and do something wonderful." And wonderful, we did. For more than 50 years, we transformed computing, putting Intel Silicon at the heart of innovation. But with all the breakthroughs we made, all the possibilities we created, what's truly wonderful...
Сейчас, секундочку, вы меня слышите, да? Это Кирилл, да? А MacBook это как-то... Нет, мне опять было плохо. То есть как только я открываю рот, я перестаю слышать говорящего. Это ужасно. То есть что я могу вообще переводить? Ага. Вроде бы Нина, я не знаю, я не успела с ней поговорить, но, по-моему, она пишет, я нормально слышу по этой ссылке. Может быть, мне ссылку надо было? Ну да, сейчас будет лайв уже. Ну, судя по всему, она где-то писала, что сейчас нормально. Ну, судя по тому, что она нормально переводила, ей, видимо, и слышно было нормально. Потому что иначе невозможно столько придумывать. Меню, сейчас. Скриншеринг. Screen one, да? А вам видно? Я должна была английскую закладку с вами английской поделить. Ну да, где мы сейчас разговариваем. Что у меня Google Chrome would like to record this computer screen.
Just imagine what we'll do. As in, don't tell us what we can't do.
Так, не знаю, у меня какие-то апдейты вообще меня побили. А вы говорите Windows, а у меня, например, MacBook, или это не имеет значения?
They said we'd never do this. Soon we will from 12,000 miles away.
Ну, надеюсь.
there's still so much left to do.
So what are we gonna do about it?
Да, еще раз, вот я нажимаю шеринг, то есть я должна буду поделиться с вами, да, правильно, английским экраном, еще раз share, что он тут мне говорит. Нет, ничего не получается. Даже не знаю, что делать. Нет, то есть просто мне нужно зайти в эти, в систем, ну, короче говоря, в настройки, да? Я иду в настройки. Так, где они у меня есть? Почему они не открываются? Да, ну, сейчас звук я найду. Ну, я, в принципе, туда залезаю периодически, тоже как на платформе работаю. Сейчас. Так, вот я зашла в звук. У меня что нужно? Микрофон, да? Input. Микрофон. Вот у меня стоит... Кстати говоря, у меня стоит почему-то внутренний микрофон, а не мой хедсетовский микрофон. Так, ну хорошо, я выбрала вот свой наушник сейчас. Да. Но с другой стороны, мы же с 10 до 4 как-то нормально работали. Я все прекрасно слышала, иначе бы я уже давно забила в тревогу. Так, хорошо, значит, что в звуках мне, в микрофоне сделать? Выбрать свой наушник, да? Так, выбрала. Угу. Это, наверное, sound effects. Так, ну, наверное, есть сейчас. Ну, я понимаю, да, на самом деле, где-то я это видела, я уже не помню. Play sound effects through. Тут написано, играйте как бы звуковые эффекты через. Опять я свой микрофон должна выбрать, да? Ой, смотри, ну, свой этот headset. Да я тоже не знаю. Тут как бы вариант через динамики компьютера или через... В инпуте, где микрофон, нет, тут никаких вариантов, только в смысле громкость есть, и все. Сейчас вот еще раз посмотрю, где звуковые эффекты.
Так, да, спасибо всем за ожидание. Мы снова в эфире. И теперь Альваро продолжит с мастер-классом онлайн. Надеюсь, что у него получится все гораздо более бодро. So, Alvaro, you're welcome to run your masterclass. I wish you good luck.
Spasibo. Okay, so let's continue. Apologies for the technical issues, but I hope that you'll have had some time to take a longer break and get prepared for the lab session. So first of all, if you haven't done so, please go ahead to this website. So stackres.io, then go to documentation, and then go tutorial, section number 3. Right? Everything I'm going to do is on this web page. You can do this with me. You can do it later. If you have a Kubernetes cluster handy where you can fiddle around, feel free to just do this by yourself. The only thing I've done so far, I was running just before the demo, was this command to create manage Kubernetes cluster, so EKS. I just copied and pasted this into my shell. It produced an output similar to this. We can just check, but basically it created the cluster. There's nothing special here. This is not about Stackers at all. This is just about creating a managed Kubernetes cluster, just to check that everything's okay. I'll just show this. I hope that you can read the font okay. Let me know otherwise. Here we have a Kubernetes cluster. We should have 3 nodes. Yeah, and other than this, the Kubernetes cluster is empty because I just created it, right? So this is if you go on this website, you'll see on the tutorial that there's some prerequisites here. Software installed, it's pretty basic. You just need kubectl, Helm 3, and using a Linux shell. I already have installed this. Then I created a Kubernetes cluster using, in this case, Amazon EKS. This is just to check that everything's okay. So we already have the Kubernetes cluster. Let's look at the next prerequisites. The next is to install Prometheus and Grafana. This is technically optional. You may install and run Stackers without installing Prometheus and Grafana, but you will not have monitoring. And because I think it's something cool to have, let's actually do this. To install Prometheus and Grafana, this is dependent on Prometheus and Grafana installation. They reproduce here to have all in the same place, all complete, but you should refer to the official documentation for further information. But anyway, let's just go and do it. It's very simple and quick. So first of all, we're going to create a namespace within Kubernetes specifically for monitoring purposes. And there we're going to install Prometheus and Grafana from the Helm chart they have that comes everything together. And so just paste this command here. And this will take 1 minute, more or less, and it will install Prometheus and Grafana in this namespace monitoring that we have just created, and we'll have it ready. Again, this is a prerequisite before installing Stackers. This is optional, but if we don't have Prometheus and Grafana, then we will not be able to have monitoring. Everything else will work perfectly well, but I want to try to show the demo with this. Remember, this is a live demo. Anything may fail. Hope nothing will fail, and if something fails, we'll try to fix it. But let's hope it will work well, and we should get some output here. Excellent. While Prometheus install, I'm going to move forward. We're going to try to do everything a little bit faster, so I'm going to just try to move forward. The last step into having all the prerequisites are to have an object storage bucket ready. This is also optional. We don't strictly need it for installing Stackers, but it's going to be used for backup. So as long as we want to have backups taken, then we're going to be using object storage. So we're going to go ahead and also execute these commands such that we can take backups from Stackers. In this case, it's dependent on the environment. I'm going to use here an S3 bucket from Amazon AWS, but you could use anything. Even if you want to have your Kubernetes cluster running on GKE and then have the backups on S3 or whatever, that's absolutely possible. You can also, if you don't want to run them on cloud, you're running on-prem, I would recommend you to go and use MinIO, which is an S3 compatible implementation that runs also very well on Kubernetes. You can just install it in a very simple manner.
But for this case, I'm going to be using a S3. In this case, again, this is not about Stackers at all. It's just about creating an S3 bucket and policies. It's a little bit cumbersome. This is AWS specific. I'm just going to go quickly through it. Just let's sure that, yes, Prometheus is installed. Everything looks good. So basically, if I would say right now, monitoring the pods, we should see that there are some pods running here from the installation of Kubernetes. Everything seems to be ready and status running. All looks good. So we have installed already, created a specific namespace for monitoring, including Prometheus and Grafana. Let's create the object storage, the bucket. So this code is going to create, first of all, it's going to create a policy, IAM policy for the backup. Again, this is Amazon specific. I'm not going to go too much into the details. Let me just, sorry about that. Let's select the bucket name. Let's say this is going to be demo backups Postgres.io. Need to remember this because I need to do this well next time I run this command. So I should have a policy document generated here. Looks good. And now let's run these commands to create. This is going to create IAM user, and it's going to attach this policy that I just formatted. So let's just paste this here. Yeah, let's set the profile to the account I'm going to be using here. And if all is good, this is going to create the user. All looks good. And last but not least, I'm going to create some credentials. This credentials is the credentials I'm going to be using to access the bucket I'm going to be creating later. This is going to output some credentials because this is going to be a live session. I'm just going to redirect this to a credential file, not to show it on the screen, sorry about that, but this is going to be creating the credentials. I'll use them later. And finally, let's create the bucket. No, sorry, that didn't copy. I think it's just. All right, so at this point, yeah, demo backup Stackers.io, it's going to be created. So I have fulfilled all the prerequisites. Again, this is all previous steps before installing Stackers. Everything should be straightforward. Try this at home. Everything is documented here in the tutorial. So let's go ahead with the Stackers installation. First of all, we're going to create another namespace just for the Stackers. So we have one namespace for the monitoring. Now we're going to install Stackers. Stackers as the operator on a specific namespace. So let's just create this namespace. This should be easy and fast. And then let's install Stackers. Let me just copy and paste and start running the command. This will take like a couple of minutes, and I'll explain you what I'm doing here. So this is already running. Let me show you. So basically, we're using Helm install. We're going to be installing the upcoming 1.00 version of Stackers, currently on Alpha 1. So it's a bit experimental, but by the way, it works well. And it's just because it comes with many advanced features. And we're installing Stackers on the namespace Stackers. The name of the Helm chart is called Stackers operator. And then I'm setting some parameters. The end is just the URL where the Helm chart is stored on compressed format. About these parameters, this parameter I need to set in order to be able to automate Grafana into the web UI. So Stackers Web Console, I'll have monitorings enabled. I'll have the dashboards included in the Stackers Web Console. And these three parameters are coming from the Prometheus installation. So if I have a different Prometheus installation, I may need to tweak these values, such as what is the host where the Prometheus is running, or even if I'm running on a different namespace. This is basically the namespace where I installed Prometheus and Grafana, and the user and password. These are the ones that are come from default if I install Grafana from the Prometheus Helm chart that I used before. So in other words, if you have a different installation, you may want to change these parameters. And finally, I'm creating here a load balancer to expose the web UI, the web console, so that Amazon will create a load balancer in their environment and expose via HTTPS the load balancer. If you don't want to create a load balancer, set this to cluster IP. This link will take you to all these parameters of the Helm charts. There's a lot of options to customize installation, but for the tutorial, let's keep it like this. So once everything is installed, we should get a message similar to this. It should happen anytime soon. And once it is installed, we're just gonna check the web UI. And for this, we're just gonna query. For the web UI, there's gonna be a service exposed on Kubernetes land, and we're gonna have a DNS entry there. We're gonna use this DNS entry to connect to the load balancer and be able to access the web console. I'm gonna do most of the demo from the command line, but I'm gonna go back from time to time to the web console to also show you how it would be done from the web console. But what I want to say is that everything that can be done from the command line can be done from the web console. Everything that you can do on the web console, you can also see the results from the command line. So they are both absolutely interchangeable. So I'm just gonna be a little bit go back and forth for you to show you both faces. Okay, looks good. Looks like it's installed already. Let's use this command to get the service name, the URL of the service that is exposed. It might be creating as of now. But basically, this is the DNS where the web UI is going to be exposed. So let's try to access this. Yeah, we're using here an self-signed certificate, so this is expected. And if all goes well, I should be presented soon with the login interface here we have the login interface to Stackers. Let's make the font size a little bit bigger. The default username is going to be admin. The password is automatically generated, so we need to query it. There's here a quick command to capture the password from that it was automatically generated. I'm just gonna pipe it to clipboard. Again, we are on a public session, so I'm just gonna copy it to the clipboard, and I'm gonna come here to paste it. It's pretty long, the generated password. And okay, good. So we've got access to the web console. This is Stackers web console. We'll come back here later. The most important thing that I can mention here is that it also supports dark mode. I'm gonna go with dark mode for now. All right, so let's continue with the tutorial. We have installed Stackers. As you can see, installing the Stackers is just one command. You may specify some options to customize the parameters, but installing Stackers is Helm install and this command. So it's pretty simple and comes with a lot of powerful stuff, including this web UI that we're gonna be seeing. So let's look at how to create a very simple cluster. And one of the goals in Stackers is that we want to make two things. A, Postgres easy, easy to operate, and especially easy without having prior Postgres knowledge. Because we're all on Kubernetes land and we're using Kubernetes tools, we're also trying to leverage Kubernetes best practices and what Kubernetes users are used to, so that if you're a Kubernetes user, if you have Kubernetes experience, you're going to become a Postgres expert too, without having to know Postgres. So one of the things we're trying here is to make it simple, to try to hide all the complexities about Postgres and connection pooling and high availability and monitoring and backups and many others. Which can become quite complex and may require significant expertise in Postgres. We're trying to hide them behind very simple interfaces that any Kubernetes administrator, even not an advanced one, may understand and may be able to operate with. But the second one is that the result of this, even it looks very simple, it is enterprise grade. It is Postgres clusters created with all the components to run directly in production, with all the best practices that our DBA expert DBA team has built into them, and you may deploy this into production. So it's very high quality components with a lot of moving parts behind the scenes, all prepackaged for you and exposed with a very simple interface. We're going to see now the most kind of probably extreme simple example, but you'll see how easy it's to create a Postgres cluster with Stackers, with a lot of components inside of it. As you may know, in Kubernetes, you may use CRDs. I also mentioned this before, but just to recap, a CRD is a custom resource definition. It's a custom object in Kubernetes. You may think of Kubernetes as an object server, and also supports custom objects, like Postgres supports custom data types, right? And we're gonna expose these custom objects with very high level interface, so you don't need to worry about the internals of Postgres. unless you want to, which you can, of course. And these CRDs are typically created as YAML files. Syntax also allows you to use JSON. I'm going to be using YAML here. It's less verbose. And so let's just create a YAML file and let's apply it on Kubernetes, and this is going to create clusters for us. It's as simple as it sounds. So let's look at this file. We're going to create this simple cluster. Let me first copy and we're going to be creating it here, right? So let's just say cut to this file and copy these contents, right? So this file just basically says we're going to create an SG cluster. This is the name of the CRD. I'm going to call this cluster simple because it's very simple. We'll see that we'll create a more advanced cluster later on. I want to have 2 instances. I want to use the latest available Postgres version. This will resolve to a specific minor version number. And I want the pods definition to, within the definition of the volumes, to contain a 5 GB volume. This is as simple as it can get, right? And this, 10 lines YAML file is going to create a Postgres cluster with 2 instances, with connection pooling, with high availability built-in, and with Envoy proxy, with a lot of components. Let's just go and run it. To run this, we just say kubectl apply-f and the file we just created before. And if all goes well, we should see the pods creating very soon. We can check this, for example, with this command that will watch for the creation of pods. And here we have simple 0. The simple is going to be the first pod is starting to be created. We can also go back to the web console where we already see that there's a simple cluster here, and here we see that is pending state, so it's effectively created. This is what I refer to that what you do on the command line interface. I'm just going to make the font size a little smaller. Yeah, so it's clearer. What we see on the command line interface cooperates with the web UI and vice versa, right? So here we see the cluster creating, and very soon it will start populating the containers, and then we'll go to have a second cluster. Okay, good enough. Yeah, there's already initializing. So while this creates, let's look at what is going to be the next steps. So this is a simple cluster, and it will contain this components. It will include Envoy proxy. It will contain monitoring. It will contain connection pooling and the optimized configuration. Now, let's say that I want to optimize the configuration. I want to use backups. Right? Backups are not going to be enabled for this cluster for now. I want to have the distributed logs that I mentioned to you before. In this case, we're going to go and follow the steps to create a more complete cluster. How it's called here, and we're going to learn some concepts along the way. Just before going that, let's check that this is gonna exist, and we can connect to Postgres to also demonstrate that there is a Postgres database behind the scenes, right? So, okay, looks like cluster number, the first instance is running, and the second one is almost to be ready. So that will be very good news. Yep. Okay. We have our cluster with 2 instances, and each one has 5 containers right now. If I go to the web UI just to check it effectively, here we have the 2 containers. Both are active, and this one is the primary. So let's demonstrate first of all that there is a Postgres here. One thing we can do, this you can also see from the tutorial. I'm just going to do it directly, but you can see from the tutorial that first of all we can just connect via PGConf. So if you remember, there's a container called PostgreSQL which contains Postgres administration utilities, and we can just execute a command inside this container and connect to PGConf. Actually, I'm just going to copy because I prefer to go a little bit faster. I have a little bit less time than planned, and just run the command. I should be able to connect to Postgres. This is pretty simple, and here I have Postgres database, right? So. Good. As you can see, again, with one very simple YAML file, we have created a Postgres cluster with 1 replica in this case. We can just edit that number of replicas, and it will create a 3rd replica. It's very simple. It's built-in high availability. If I kill one node, the other one will become the primary, and another one will be spin up automatically. We can also demo this. It's very easy. But let's just move on. I also want to show you how to connect, because this is actually at the end of the day just running a command. But how do I connect from, let's say, my application? Postgres exposes, as I mentioned before, 2 services normally per cluster. One for the read-write workload, one for the read-only workload. The read one is called name of the cluster / primary. And so I can also connect externally from this. To connect to this, what I'm going to do is, first place, I'm just going to copy this. I'm just going to launch an application. In this case, the application, I'm just going to run another pod with Postgres, but this Postgres pod contains the command line PGConf, but this is external to the Postgres cluster. So just think of a web application that is going to connect to Postgres. And if I just exit here, yes, so we'll see that there is PGConf here, right? This doesn't know where to connect, but there is PGConf here on this other pod. Now, when I'm going to connect from the outside, I need to connect with the user and with the password. It's going to be password authentication by default. What is the super user password? This Postgres cluster that I was created, I didn't specify any password, right? And that's on purpose. By default, it's automatically generated, and it's stored in a Kubernetes secret. However, I can easily query this from this command. So what I'm going to do is I'm going to run this command. Again, because we're in a public session, I'm just going to copy this to the clipboard. And this is going to be the super user password that got automatically generated when I generated the Postgres cluster. And I'm just going to now execute a command on this external pod, so external to the Postgres cluster. And I'm just going to say connect to the simple primary, which is the name of the service that is exposed, because I want to connect to the read-write pod. And I'm just going to connect as user Postgres and database Postgres, and should ask me for a password, which if all goes well, I'll just paste, and I should be able to connect. So in this case, you're seeing that I'm able to connect from the outside of the cluster, from inside of the cluster, and so I have a Postgres cluster running with 2 instances, and everything is good so far. For now, we're just gonna delete this pod, because I'm gonna create a much more advanced one. So I can just say delete first the pod, and then the one that I'm using for PGConf, and then I'm just gonna go on and delete the whole cluster. I can just do this by calling delete on the YAML file. And if everything works, I should get the pods being destroyed, terminating, and we'll have this clean. Now we'll start creating with a more advanced cluster. All right, so let's move on. Let's go to the complete cluster. So first of all, we're just gonna create a specific namespace here. Now so we have one namespace for monitoring, one namespace for Postgres controller, for Postgres controller, the Postgres software itself. And now we're gonna create another namespace for creating the clusters here. The previous cluster, this simple cluster, was created on the default namespace. Now we're gonna create on a namespace, specific namespace called demo. Of course, this could be used for enforcing permissions, access control, and so on and so forth. Now, before creating this complete cluster, we're gonna follow a set of steps. The first one is gonna be creating an instance profile. An instance profile is a way that we have to try to suggest or enforce best practices in terms of resource utilization. We've worked on environments with hundreds of Postgres clusters where each cluster or each instance is of a different size. This is actually chaotic and it's quite hard to manage. It's better to try to standardize on some instance sizes. And this is exactly what an instance profile is. So an instance profile is another CRD, another of these custom resource definitions, custom objects that we have created in Postgres. That is basically to associate a name with resources for an instance, being resources basically CPU, cores, and RAM. So by giving it a name, you can just reference this name later on and say, I want to create a cluster of size small or large or 2 extra large or whatever you want to call those names. And therefore, you can standardize on this best practice and have more uniform sets of instance sizes. And of course, you could even enforce permissions on this such that users may, or of a certain level, may not be able to create new instance profiles, but may be able to create clusters that reference to these instance profiles, therefore effectively enforcing these best practices. So Creating an instance profile is pretty simple. It's a YAML file that looks like this. So let's create this instance profile as a YAML file here, my local file system. Again, I hope you're, if you have a Kubernetes environment, you can also be running this alongside with me. I create the YAML file, so let's just apply it. Pretty simple, and I'll have the instance profile created. This doesn't create any physical resource, it's just metadata, but we'll see how it is used later. So far, so good. Excellent. Of course, we can create, this is called size small, right? And it says CPU cores and 8 GB of RAM, but I could create many sizes, many profiles if I want. For now, this is good enough. Let's move to the next step. And this was one of the questions that we had before, how to tune Postgres. So Postgres, we could have said, you know, like this is very typical in Kubernetes land, create a config map. Config map is kind of some metadata that can be accessed and put whatever there, put actually a PostgreSQL.conf file there, and we'll just copy and paste it into the container. But in Postgres, we want to make sure that users that are not that experts do not have a hard time to mess up with the system, right? What if you put there a wrong file or invalid parameters or with syntax errors? We don't want to do that. We want to enforce a stronger validation. So we have created our own CRD for the Postgres configuration called sg-postgres-config. And so it's another YAML file where you specify the parameters. The main difference is that these parameters are strongly validated before being created. So when you create the CRD, the parameters, their values, and the version checking is going to take place. So if you use a parameter invalid for this version, it's going to be rejected. If you select a wrong value of wrong type, it's going to be rejected. If some value is out of bounds, it's going to be rejected. So this way we enforce also correctness on the Postgres parameters. But also, as we shall see right now, you can tune some parameters, but by default, we are also tuning a lot of those. Obviously, your parameters take precedence. But once you create a Postgres sg-postgres-config CRD, you may query it later and see also which parameters we tune by default for you. So procedure is as simple as it gets. Let's just create yet another YAML file, which is, we're going to call it this way, with this content. Yep, the content is pretty simple. I'm using always the namespace demo. I'm using this name for the configuration. And then I specify a Postgres major version. As you know, major versions are, any minor version will apply. So I just need to specify the major version to which this configuration is going to be valid. And then the parameters as they appear in a PostgreSQL configuration file, except that, as I said, they're strongly validated. And then apply as usual. So let's just go and apply this. I just say kubectl apply, just have this file, and this is also meta information, doesn't create anything other than the validation, and I'll get this. Now, what is interesting is that after being created, I can call the scribe on the generated CRD, and I'll just pipe this to less. So sorry about that. So I'll be able to see what parameters, this is a describe command where we'll see what we just created, and we'll see all the parameters that in reality this configuration has set, which includes the ones that I set by myself, plus some other parameters that we inject by default. As you can see, we have tuned quite a few parameters here. And to make it even more clear, on the status field, we specify which parameters we specifically tune. Not the values, but just the names, so you understand which parameters come from our default tuning, which comes from your own settings. But obviously, you can override all the parameters that we are setting with default values, except a few that are blacklisted because they will compromise the stability of the cluster. But there are a few, obviously. So, good enough. We have created with this an instance profile, which we'll use. We gave this instance profile a name. Now we have created a Postgres configuration with a name. We can also do the same with the connection pooling. If you remember, Postgres will include connection pooling by default. You can disable it if you want. Just set this property, the SC cluster pods disable connection pooling if you don't want it. But otherwise, it will come with a connection pooler in front of Postgres on the same pod. Now, it also comes with a default configuration that you can also tune, but it is tuned by default. Now, if you want to create your own custom configuration, the procedure, as you can imagine, is pretty much the same. This is yet another CRD called SG pooling config. And let's just create this YAML file. We're using PG Bouncer as a connection pooler mechanism. This might be changed in the future, but this is what we have right now. And you can set and override pgbouncer.ini parameters. So let's just generate also this file. Copy the contents and kubectl apply that file. Again, this is only metadata, so this is not going to generate any resource. And we can also describe this this file to see which parameters are tuned by default. I'm just going to move along, but you can see here it's on the tutorial. You can see the result. Good. Now, we're going to create a cluster, and we're going to see, hey, I want to use this instance profile for this cluster. I want to use this Postgres configuration for this cluster. I want to use this connection pooling for this cluster. But I also want to have automatic backups. To have automatic backups, I need to create what's called a backup configuration, which is yet another CRD that represents how to take backups. And within these backups, I need to specify the credentials to access the bucket, in this case, the S3 bucket. Could be any other object storage. In order to specify the credentials, we use usual Kubernetes practice, which is to reference a secret. Secret is a Kubernetes object where you may store information which could be confidential, such as credentials. So what I'm going to do is I'm going to create first a secret, the standard Kubernetes object, and then I will create a backup config that will point to this secret to fetch the credentials from there, and that will be the backup config. So let's go into backup configuration, and from here, let's specifically look at about how to create a specific secret for accessing an S3 bucket from Amazon. The secret, again, is a standard Kubernetes object, and the YAML file I need to create is going to look pretty much like this. However, and in order to save copying and pasting here confidential credentials that I just generated, if you remember on the previous step as part of the prerequisites, I generated the credentials on a JSON file that is stored on my file system. And I just have a handy script here that is gonna basically extract the same, the credentials from this file and create from the command line a secret equivalent to this. So you can either just copy this and create a secret and you do kubectl apply and just copy and paste here the correct values. But what I'm gonna do here is use this script, which is more convenient, and especially because I'm sharing the screen in order not to be able to show what I shouldn't. So no, I'm not gonna cut that. I'm just gonna make sure that this file is here. So this is the file that I generated, just to make sure it was generated a few moments ago, correct? So let me just paste this command. It's gonna be very convenient here, and credentials file is gonna be this .tmp creds.json, and if all goes well, I should get the perfect, the credentials file, the secret generated. So now that I have the secret generated, I can generate the backup config. Excellent. If you don't want to do it this way, just create this YAML file and do kubectl apply, and you should get the same result. So how does a backup config looks like? So the backup config is yet another CRD. As you see the pattern, we create a CRD to represent any concept that we may abstract away. And we assign it a name and then some parameters. What are these parameters? So first of all, the most important thing is this cron schedule, which specifies at which periods I want backups to be taken, base backups. In this case, because this is a demo, I want to have backups taken every 5 minutes, so I'll have time to show you maybe that one backup is created. The retention window, how many base backups I will keep, and in between there will be WAL files. And what is the storage type? In this case, I'm going to set it to S3 because I'm using an S3 bucket. And here I specify the parameters for the bucket. It's going to be the bucket name, which I'll need to specify. And this is the credentials that basically refer to the to the secret that I just created, which is called, should be called the same way, S3 bucket backup secret, S3 backup secret, yes. And this is a secret key selector, which is a standard Kubernetes pattern. It's called a secret key selector, where I specify the access key ID and the secret access key, where the name is the name of the secret and the key is the key that I want to access within that secret. So let's just copy this file. First, I'm giving it a name, so let's just add to this file with this content. And let's edit this to set up the bucket name, and the bucket name is, I don't remember, it was S3, yeah, previous command. Oh, it's probably this variable. This is exactly what I want. So I'm on the same session. That should come quite handy. There we go. I just want to make sure that I use obviously the same backup name, bucket name, right? Otherwise, I won't be able to send the backups here. All right. So I think we have this file ready. And so how to use it? Just the usual apply, just F, sg backup config, and again, it's only metadata. I will create a backup configuration. All right, we're not there yet. We just need one step more, which is to create a distributed log server. If you remember from my previous presentation, I was explaining that we have created a mechanism to ship the logs to a remote location from all the pods, potentially of many clusters. And this remote location is going to be yet another Postgres database with timescale extension installed for handling very large volumes of incoming logs. And guess what? This is exposed as yet another CRD. Behind the scenes, you don't need to worry, well, where's FluentBit, where's FluentD, where's this Postgres, how to install timescale. Everything is handled for you. Just create a distributed log server. Remember that a distributed the logs for all the pods for one or more clusters. And so it's a dependency. We're going to create first a distributed log server, and then we're going to create a cluster that will say, send the logs to this distributed log server. Yet another CRD, it's called SG distributed logs. Pretty simple in this case. We're not messing here with the retention policy of the logs, but we can do that. You can go to the documentation here and check all the parameters. But for now, let's just create this YAML file. So paste this here and the content. And let's create this. Oh, sorry. F. In this case, this is going to create resources because this is a Postgres instance with a FluentD container and with an API service. So because we're operating on the demo namespace, we should soon see here the distributed log servers being created. This name distributed logs is exactly what I specified here is the name. And in a few seconds, we'll get the distributed log server being created. Excellent. Once this is created, I'm finally going to be able to create my Postgres cluster, right? In this case, let's recap briefly what we have done so far. We have, first we created a simple cluster and see how we can connect to it from inside the cluster, which should not be the usual way to connect to it, or how to connect via the service. Or connecting via the service, we gather the generated password for the super user, and then we created another pod with a tool called PSQL, so to be able to connect, and then we pointed the host to the DNS service, which is exposed as a cluster name -primary, and specify this password, and we're able to connect. Then we destroy this cluster because we want to create a more advanced one. This is more advanced in the sense that we are explicitly specifying an instance profile, so we have tight control over the CPU and RAM resources that this cluster is going to be using. We have created a customized Postgres configuration, so we can use this Postgres configuration. We have customized a connection pooling configuration. We have created the secret, which was a prerequisite for creating a backup configuration. So this cluster will also have backup, automatic backups. And we have also created, it should be created already by now, exactly, distributed log server, which will be able to collect their logs from all the pods from this cluster that we'll be creating. By the way, I'm doing this all from the command line. I shall remind you that you can also go back to the web UI and check everything also. In this case, we're operating on the demo namespace. So let's go to the demo namespace. And here we can see, for example, there's no clusters yet, but there's an instance profile. This size is small, if you remember, with 4 cores and 8 gigabytes of RAM. I can create a new one from here if I wanted. Actually, something I can do. Let's create size medium, for example, with, for example, 16 gigabytes of RAM and 8 cores. And here we have another profile, and I could have checked this also from the command line. For example, I could do kubectl demo get st instance profiles, or see. I can also use a shorter version if you prefer, and it will show all the instance profiles that I have created, right? This one I created 15 minutes ago, this one I just created from the web UI. This is what I wanted to show, that everything that you do from the web UI, you can check from the command line and vice versa, because it all goes back to a CRD. From the web UI, we check the CRDs, from the web console, we query and we create the CRDs. So here we can see everything that we're doing, the Postgres configuration that we created. Also here, it's very interesting. Here, I maybe need to make the font size a bit smaller, but it's a little bit more clear which are the parameters that I set directly and the parameters that have default configurations. I also have here some help. For example, if I want to check any parameter, it takes me to this website that I mentioned before, PostgreSQL code.nf, that Anastasia also mentioned, and that it provides a lot of information about configuration parameters. So this the web UI sometimes is also more convenient because it provides you advanced capabilities, like in this case, checking documentation of some parameters. The same with connection pooling, where I have, this is the default parameters and the parameters that I set, and the backup configuration. Here I can see that the backup configuration is pointing to an S3 bucket called like this, with the credentials, which I cannot see for obvious reasons, and all the capabilities here. There's always hints to help you on different properties, etc. And we should have also the distributed log server. Excellent. I think we're ready to create the cluster. So let's go ahead and create this more complete cluster. Yours is not that much hard. It's going to be an SG cluster, as we did before. Let me just copy this and start running it. It won't take much, but I prefer to run this command as early as possible. So let's create this file, and I'll explain what it is later, or what are the differences with the one we created before. Okay, and while this creates, I'm just going to set a watcher here. Demo get pods. Okay, so here I see the cluster being created. This is normal, by the way, don't get scared. This message is normally very scary. Because we're adding a new cluster that's going to ship logs to the distributed log server, it's restarting. This is the consequence of a restart of one of the containers. It will be restarted in a few seconds. But this entails no data. Here you see it's already restored. But this entails no log loss. If you remember, there's buffering on the pod. So while this container is restarting, the logs are not being sent to it, but they're not lost. They're still on the original source of the pods. If they were, in this case, of the clusters trying to send logs, it will buffer them for a little bit until this container is restarted. This is a limitation of FluentD. We're hoping for a future version of FluentD which allows a reshuffle of the configuration without restart, but for now we need to restart it. But as you see, it doesn't really have any effect in practice. And here we're seeing already the second instance being brought up. Again, we can also check this from the, here we also see, yes, cluster appears here, and we see the cluster creation here. Where you have cluster 0, the pod name is already active. Cluster 1 is being fired right now. And this is the primary. Excellent. So it all looks pretty good. This cluster contains 3 instances. So the second one is creating right now. So let me go back and explain what was the difference with this YAML file. Still short YAML file, right? There's nothing super special. The difference are that I'm using a specific namespace. I also hard-coded specific major and minor version of Postgres. This definitely can do. The instances, the instance profile, I'm explicitly specifying which instance profile I want to use. size. I'm just giving it a little bit more size here. And here, under configurations, is where I'm using the references to the names of the configurations that I want to apply. You can think of this as foreign keys, right? So this is a foreign key to the Postgres configuration. This is a foreign key to the connection pooling configuration. This is a foreign key to the backup configuration. And also, I want to say, send the logs to this distributed location, which is the distributed logs. Finally, I want to enable the connection to Prometheus so that I will get monitoring information from this cluster on Prometheus. And that's it. The cluster, it's running already. Looks good. I should be able to connect the same way as before. For example, like this. This is not simple 0, it's cluster 0. And I shall see, yes, because I'm not in the right namespace. I shall see now a connection to Postgres, so I have a Postgres cluster. Let's, by the way, I didn't do this before. Let's demonstrate that there is some replication going on. So let's create a database demo also. It doesn't exist, just to double check. There's no tricks here. It doesn't exist a demo database. Let's create a database demo. And let's connect to one of the replicas, for example, and see that that database exists. Cool. So there's Postgres, it's replicating. If you're low-level user, you may also want to check, for example, connect to the Patroni cluster and issue a command like Patroni CTL list to show what is the status of the cluster from the Patroni perspective, right? Yeah, so here we have, and here we see there's 3 nodes. Well, this is the leader node, and so forth. Cool, excellent. Let's go back briefly to the web UI. Effectively, we have the cluster here, and let's look at what we integrated into this web console. So first we have the configuration. Configuration is just a view of this YAML file, nothing special, but I have here a link so I can go to the instance profile or to the configuration, etc. Right? Then we have the backups. The backups, oh, good. Because I said to 5 minutes, we have already one backup created from the cluster. Next 5 minutes, I'll have obviously another backup here. Created here, see some details about the backup, the size. Obviously, there's almost nothing. Compressed is even less. This is the name of this backup. And I can also, this one it was taken, I can also click on any backup and find detailed information about this backup, right? What is the size, the Postgres major version, the name of the backup itself, where it came from, the name of the cluster, when it was started, the LSNs, when at which point from the Postgres streaming process, the basically representation of the last sequence number in Postgres started and when it finished, a specific UID to globally identify this backup, specifically which pod it was created, which was the master pod at the time, timeline in which it is, the internal Postgres identifier, etc., etc. So we have here a wealth of information coming, even the full control data that came from the backup location. All this is provided automatically for you on the web UI. You can also check the same information from the command line. As I said, everything you can do on the web UI, you can do on the web command line, because backups, guess it, they're just another CRD. So from the web, from the command line, you can also go and check the backups because they're just another object that we create on Kubernetes. The logs. So I mentioned that we use this technology to ship the logs to a central location, and here you can see the logs. In this case, here we have the logs coming from all the pods together on this web interface, right? I can use this to filter, for example, let's say I want to filter only Postgres logs coming from the pod name called cluster 0, for example. And I have here the logs. And I can also click on any log, let's say this one, and I'll see all the detailed information about this specific log. Depending on the command, of course, you may have more or less information here, but here we have all the information about this specific log from this specific pod, in this case from Postgres. And this right now supports Postgres and Patroni. If I clear the filter also, or just select Patroni, we may also see information from Patroni. For example, information, he's the leader. So yes, we know that cluster 0 is the leader. and we have this information coming from Patroni here. And we can click, as I said, on any log to get more information about them. We can also do full text search on these logs. And this is going behind the scenes to a Postgres database, right? So you can also connect via pSQL and execute SQL commands. And last but not least, we also have, if everything worked well, this embedded Grafana dashboard. So I could select a cluster here. By default, it will select the cluster 0, and this will load Grafana. And as you can see, this is embedded into our web console, and it will show all the dashboards that we have created by default. Taking a little bit to load, but it should come soon, or not. Interesting. Ah, there we go. I don't know why it's so slow. Maybe it was the first load. Okay, anyway, by the way, I'm pulling this cluster is right now running on US system, and I'm in Europe. But yeah, okay, here we have it. So here we can see all the specific dashboards that we have created. Of course, this is not very active cluster, so maybe we don't have a lot of information here. Let's actually look, for example, at the database size, where we should have some information already. You see the database demo here, Postgres database, some counters here, the biggest tables. Well, of course, this information on this specific case right now is not super interesting because there's no activity on this cluster. But as you can see, we have created specific dashboards to deal with load, usage information, transactions, for example. These two come from Envoy. Remember that we were exporting specific metrics from Envoy. This comes from Envoy. They're not hitting Postgres. Obviously, general information about the database, etc. So we have all this monitoring information embedded into the web UI. This is one of the advantages of using the web UI. And just think about this. What have we done to create all this? Automatic backups, which probably we should have already. Yes, a second backup already generated. Distributed logs, embedded monitoring, and creating a Postgres cluster with connection pooling, with high availability. For example, I can demonstrate that if we have these 3 pods, I can obviously just kill one. For example, let's say delete pod cluster 0, and the cluster will reheal very soon, and we'll elect either cluster 1 or 2 as a new primary. We can see here this, for example, from here, and it will find one. You see that right now this is pending and already elected cluster 1 as primary. And if we were an application connected to the primary, it will see a small downtime, and then it will again reconnect to this cluster, but now we'll connect to cluster 1, which is now the new primary. And this one, by the way, is being redone again. So you've seen that in a few seconds, after killing a whole server, a pod in Kubernetes, another pod was automatically launched because we're using, in this case, external disk. The disk is just reattached, so this is a very fast process. And we have the cluster rehealed. Of course, it will be different if we need to schedule a physical node, but for the most part, Kubernetes takes parts of this. And now we have cluster 1 as the primary node. And so from the user perspective, it was a very simple operation. So that's all that I wanted to mention today about the tutorial. I would like to insist that you can just go to stackers.io, documentation, and then tutorial, and just reproduce, 3.3 tutorial, and just reproduce the very same steps that I performed today in order to come to the same results. If you're doing this on Amazon AWS, it will be straightforward. If you're using a different Kubernetes environment, you should also have no problem. There's minor tweaks for all the Kubernetes environments, which are also documented in our documentation under production installation. But if anything happens, please feel free to join us on our Slack or Discord groups. They are on the main webpage linked from there, and you can just reach to us. So I really encourage you to try this out, and I'm open. I think we have some minutes left. I'm open to questions.
talk. And
pleasure.
Yeah, and I can report you that everything went smooth, and it seems that everything really works well, which is great for masterclass and even greater for the system. So we have now only one question in the chat, which is about limits and requests for pods, whether they were set or not.
Yeah, it's a very good question. So as I mentioned, Postgres is a quite opinionated framework, right? The team behind the teams, I would say, behind Postgres, they include the developers writing the code, and they include the DBAs writing the specs on how things should be done. And one of the goals that we have from our DBA team is to enforce best practices. One best practices when running a Postgres production database is that you have strict control of your resources, which in Kubernetes land means to specify both the limits and the requests and make them the same. So we're doing limits equals request equals the instance profile that you set. So this is good for production environments. This may not be ideal for development environments where you want to do a little bit more consolidation of resources. So there's actually an open issue for us to let you specify different values for the limits and the requests. But again, this is only applicable for development purposes where you want to consolidate more resources. For production workloads, we absolutely discourage that option because it may make, for example, the OOM killer to fire when you cannot really strongly control it. We also recommend as a best practice, and this is enforced by default, that you run no more than one Postgres pod per Kubernetes node. We use an anti-affinity rule set by default to prevent this. You can override this. You can set up what is called a non-production option, which is to override the anti-affinity condition. But if you want to run several pods on the same node. But other than that, we enforce this. So we're trying to enforce best practices all across the board.
Yeah, thank you. That sounds wise. And yep, that's it. I think there are no more questions in the chat. Maybe we'll wait a couple minutes more, and then you can follow to special chat where maybe people will ask some more questions. And yep, thank you.
Excellent.
My compliments to the dashboards and the web UI, which is quite clear to follow. Even when I see it the first time, it looks really easy to follow what you do. So yeah, that looks really good.
Thank you very much. I appreciate it. And there's been a great effort also on the web UI, and there's even more things coming to the web UI that I believe will be quite interesting. One of our goals, as I mentioned, is to make Postgres really accessible for non-Postgres experts. We want to make Postgres a universal database so that anyone that at least knows the basics of Kubernetes administration will be able to use Postgres, which is, as you know, hard for production environments.
Yeah, I see. So I think that we're right on time. And thank you once again. So I want to remind our listeners that they can vote for the talk and masterclass. And yeah, now you can follow to special chat and talk to speaker. Thank you.
Okay, I'll go there. Thank you, everybody. I'll appreciate your feedback about the session, and see you in the room, speaker room.
Спасибо, Альваро, и спасибо всем нашим спикерам сегодня. Теперь мы переходим к закрытию части с докладами. Спасибо всем, что были с нами. И завтра нас снова ждет целый день докладов в 3 залах.
So, thank you. Tomorrow, we're going to have presentations in all the 3 rooms. So, please vote in favor of certain presentations that you like. And thank you for your today's attention, and see you tomorrow.